Hi everyone, welcome back to the channel. Welcome back to the brand new course on Microsoft Fabric with Real World Project. And if you're someone preparing for Microsoft DP-600 exam, Microsoft Fabric Analytics Engineer, then this course is for you. And in this video, we will quickly look at a brief introduction to Microsoft Fabric, and we'll also look at the roadmap and code structure, and also the dataset that we'll be using across the course, which is COVID-19 dataset. And a brief introduction about me. This is Sheikh Mohammed, and I'm an Azure Solutions Architect and Fabric Analytics Engineer. And I have close to 15 plus years of work experience. And very recently, I've completed my Fabric Analytics Engineer certification. So I just wanted to give you the tips and tricks to pass the exam, and also to showcase and demonstrate with the real world open dataset, which is COVID-19 dataset. So let's kickstart the course. So let's quickly look at the overview of DP-600 Fabric Analytics Engineer Certification Exam. As a candidate for this certification, you should have subject matter expertise in designing, creating, and deploying enterprise-scale data analytics solutions. And your responsibilities for this role include transforming data into reusable analytics assets by using Microsoft Fabric components such as lakehouses, data warehouses, notebooks, data flows, data pipelines, semantic models, and reports. So let's look at the course goals quickly. So you will master data ingestion, data engineering, and semantic modeling concepts in Microsoft Fabric. And we will prepare you for the DP-600 certification exam with all the required information, and we will also go through the study guide. And as and when we learn the concepts, we'll also apply the learned concepts in a real world project using the Azure Open Dataset, which is COVID-19 dataset. Let's look at the skills measured for the certification exam. So planning, implementing, and managing a solution for data analytics would be 10 to 15%. And then preparing and serving data would be the most part, major chunk goes to preparing and serving your data, which is 40 to 45%. And implementing and managing semantic models would be 20 to 25%. And then the exploration and analyzing the data would be 20 to 25%. That's how the split is for the certification exam. You should focus on planning, implementing, and managing a solution, which is like 10 to 15% in the overall chunk. And the most part would be the preparing and serving data. As I mentioned, we need to focus a lot there, which covers 40 to 45% skills. And code structure and modules. So the demonstration in Fabric app with the real world dataset, as I mentioned, we will be taking the European Center for Disease Prevention and Control COVID-19 dataset. Is included in every module. As you can see here, the module 1, we will cover planning, implementing, and managing a DA solution. Module 2 would be preparing and serving the data, which would be the most part. As I mentioned, 40 to 45%. We will focus a lot there with the COVID-19 dataset. And then we will try and implement and manage the semantic models. And finally, we will try and explore and analyze the data, the COVID-19 data further. And let's look at the roadmap. So we will be doing a 10-part video series, and we'll also have a Google Classroom community so that you can follow along, and whatever resources that I need to share with you, I'll be posting in Google Classroom. So I'll be sharing the link in the description as well. So you can raise a request to join the community, and you can start accessing the notebooks or whatever resources or artifacts that we'll be creating as a part of this course will be posted there, so you can access it easily there in the Google Classroom. So the video 1, which we are right now, the course introduction, and we'll also quickly cover the COVID-19 dataset overview as well. And as a part of video 2, we will plan, implement, and manage a DA environment. So we will be looking at the Fabric admin portal, and then we'll look at the data gateways and stuff like that. We'll cover those. And video 3, we will try and see how we can manage the analytics development lifecycle end to end in the video 3. Video 4, we will be looking at the data ingestion into the lakehouse or warehouse, and we'll look at the use case. And then we will try and transform the data and implement a star schema with type 1 and type 2 SCD. And video 6, we will look at the performance optimization, how we can improve the performance end to end. And video 7, we will try and design and build a semantic model with dynamic row level security and object level security, which is very important. And then we will look at optimizing the semantic model in video 8, and video 9 we will do some exploratory analytics, and then we will also try and query the data using SQL as well. And video 10, it's a bonus video. We will look at the DP-600 exam preparation tips, and then finally we'll wrap up the course. And here you can see the Google Classroom invite link, but I will be sharing the link in the description as well, so that you can raise a request and join the community and access the resources right away. Let's quickly look at some of the foundational concepts in Fabric architecture. So the first one would be one lake. And what is one lake in Fabric architecture? So the image below, I've just shown the Fabric architecture with one lake as the foundation for all the analytical engines, and each experience in Fabric, we call it as experience, that is built on top of one lake itself. So the experiences are like Data Factory, Synapse Data Engineering, Synapse Data Science, Data Warehouse, Real-Time Analytics, Power BI. All of the experiences can access the data from one lake itself. So it's a single point, logical, single storage point for organization, wherein you can talk to one lake and pull the data out as well. So all of the Fabric experiences use one lake as their native data store without needing any additional configuration. So one lake is hierarchical in nature to simplify management across your organization. So, and also to make a note, there is only one lake per tenant, and it provides a single pane of glass file system namespace that spans across users, regions, and even clouds as well. And the data in one lake is divided into manageable containers for easy handling as well. So this is very important for you to understand what is one lake in Fabric architecture, and that's the foundational concept. You can think of it as a OneDrive for organization as well. Okay, let's try and understand some of the Fabric concepts, which is very important for you to understand. So like tenant capacities. So those are some of the concepts you need to know before we get started with the course. So let's jump in. So what is a tenant? A Fabric tenant, it's a dedicated space for organizations to create, store, and even manage your Fabric items. There is often a single instance of Fabric for an organization, and it's aligned with the Microsoft Entra ID. Previously it was Azure AD. And the Fabric tenant maps to the root of one lake and is at the top level of the hierarchy. So you should know what tenant is to start with, and it's maps to the root of one lake, and it's at the top level of the hierarchy in the Fabric architecture. And let's talk about capacity. What is capacity? You can imagine it as a dedicated set of resources that is available at any given time to be used. A tenant can have more than one capacity associated with it. And capacity defines the ability of a resource to perform an activity or to produce output. So you can think of it as a computed set of resources required to perform the job. And different items consume different capacity at a certain time. So Fabric offers capacity through the Fabric's queue and trials, which we'll be looking at it in the next video when we are into planning and implementing and then managing the DA environment. So there we will look at some of the SKUs that are available in Fabric to gain more understanding into the capacities. Okay, but right now you should know what capacity is and the other foundational concepts you can say. And what is a domain? A domain is a logical grouping of workspaces. Domains are used to organize items in a way that makes sense for your organization. And basically you can group things together in a way that makes it easier for the right people to have access to the right workspaces. So imagine, for example, you might have a domain for sales, and another domain for marketing team, and another for finance. In that way, you can group all of the required artifacts in that domain, and it will be easy to organize and manage as well. And let's talk about workspace. Workspace is a collection of items that brings together different functionality in a single tenant. So it acts as a container for you that leverages capacity for the work that is executed, provides controls for who can access the items, fabric items in the workspace itself. For example, in a sales workspace, the user associated with the sales organization can create, let's say, lake houses, data warehouses. They can run the notebooks, they can create semantic models and reports, etc. So all of those would be stored in a logical container for the sales workspace itself. And fabric items at the lower level are the building blocks of the fabric platform itself. They are the objects that you create and manage in fabric, like lake houses, data warehouses, notebooks, semantic models, be it. There are different types of items, as I mentioned: warehouses, data warehouses, lake houses, data pipelines, semantic models, reports, and dashboards. And as I already mentioned, understanding these fabric concepts is important for you as a fabric admin, because it helps you understand how you can manage the fabric environment itself. So be very sure about each of these concepts, like tenant, capacity, domain, workspace, and the fabric items. Then it will be easier for you when you start creating and playing around with the objects in the fabric. And we'll look at it in the upcoming videos in detail. And let's quickly look at the overview of the COVID-19 dataset from ECDC, European Center for Disease Prevention and Control. So the latest available public data on geographical distribution of COVID-19 cases worldwide from, as I mentioned, the European Center for Disease Prevention and Control. So each row and entry contains a number of new cases reported per day and per country or region. So we'll quickly look at the preview of the dataset shortly. Okay, let's quickly look at the sample dataset or the Azure Open dataset that we'll be using across the course in the 10-part video series. And the idea here is to try and demonstrate as much as I can to explain the concepts that we learned with the real-world dataset. No, without that, you'll not be able to grasp the concepts, I would say. So the idea in this course is to provide you with the required information and then demonstrate with the real world data set, which is the COVID-19 data set. So let's quickly look at the data set itself. So I can share the link. I will also post the link in the Google Classroom community. You can look at the data set and download it yourself if you want to follow along as well. So this is the latest available public data, as I mentioned. So it's the geographical distribution of the COVID-19 cases worldwide. Okay, and each row and entry contains number of new cases reported and deaths reported per day at the country level or region level itself. So let's quickly look at some of the samples here. I think, yeah, if you download this data set at the moment, I think, it's not 19,876 rows. You might get more than that. But as of May 28, 2020, it contained 19,876 records. Okay, but now it could be more with the data for the rest of the months in 2020 as well. And let's look at the samples. So some of the columns, as you can see here, you will have the cases, number of reported cases, and the continent, name, countries and territories, country territory code, reporting date, day of the month, number of deaths reported, geographical ID, ISO country, load date, month and year. And it's a very simple data set, and I think it's sufficient for us to demonstrate the concepts that we'll be learning shortly in Fabric portal. So look at the preview of the data. So you can see some of the samples here, date reported, and then it splits day, month and year into 3 different columns. And then we have the cases reported in, let's say, Afghanistan, number of deaths that day, and we have some attributes like geo ID, country territory code, continent, and when it was loaded, ISO country. So it's a very simple data set, and I think it's sufficient for us to move forward. And we just now looked at the Azure Open Dataset for COVID-19 cases worldwide, and we will be playing around with this dataset during the course of this course. And I've also pasted the original source to give them the credit for the dataset. Have the link here. You can have a look at the original source for this dataset as well. The original source is from ECDC, as I already highlighted. Credit goes to them, European Center for Disease Prevention and Control, and when the data was published, and you can look at the data there as well. Let's quickly look at the original source as well. So it takes you to the ECDC website itself. It's an agency of the European Union, and you can see the historical data can be downloaded, which has the daily number of reported COVID-19 cases and deaths worldwide. Here we are. I've created a separate classroom, DP-600 Fabric Analytics Engineer classroom in Google Classroom community. And here you can look at the study guide and all of the required resources. I'll be posting it here. So under the classwork, so course under DP-600 course materials, you can see the ECDC COVID-19 public dataset link available. You can go and download the dataset if you want to follow along from there. And DP-600 official course study guide also, I've pasted the link here, and you can, and to gain access to this classroom you need to raise a request. So I'll provide the link for the classroom community in the description. You can raise a request and you can join, and let's begin this journey to learn more about Fabric. And that's it for this video. We quickly looked at the introduction to Microsoft Fabric, and we looked at the roadmap and course structure and how we are planning this entire course in a 10-part video series, and what would be the sample dataset that we'll be using throughout the course, which is Azure Open Dataset COVID-19 dataset from ECDC. We looked at the sample data. It's a very simple dataset that we'll be taking into consideration during the course in this 10-part video series. Thank you very much for watching, and I'll see you in the next video. Hi everyone, welcome back to the channel, and welcome back to the course on DP-600 Fabric with Real World Project. And if you're new to the channel, please consider subscribing. We are in Module 1, Planning, Implementing and Managing a Solution for Data Analytics, which is 10 to 15%. And if you don't know me, I'm Sheikh Mohammed, Azure Solutions Architect and Fabric Analytics Engineer. So let's dive in this video. We'll quickly look at the roadmap. We are in video 2, as I mentioned, Planning, Implementing and Managing a Solution for Data Analytics. So we planned a 10-part video series. And video 1, we looked at the course introduction and structure, as well as COVID-19 dataset, which we will be using throughout the course. So we just had a quick look at the dataset as well. And in this video, we'll be looking at how we can plan the data analytics environment, implement it, and also how we can manage the data analytics environment. So we'll be looking at different settings that you can manage in the Fabric admin portal as well. And let's quickly look at the Google Classroom community. So we'll be posting the articles, videos, or any resources that we'll be creating throughout this course will be posted in the Google Classroom. So you can join there. So the link will be provided in the description of this video. You can join the Google Classroom community, and if you want to follow along. Let me quickly show you the Google Classroom community that we have. So we have DP-600 Fabric Analytics Engineer community here, and you can see, so there'll be postings on different topics that we'll be talking about throughout the course. So yeah, so just raise a request, we'll be able to get to this classroom. Okay, let's dive into this video. So as a part of planning your data analytics environment, so what are all the requirements that you need to identify for your solution, and what are all the capacity SKUs, stock keeping units, that are required? So we'll be looking at different SKUs that are available for Fabric. And before that, if you haven't set up your Fabric trial account, so I'll quickly give you a quick introduction about how you can set up a trial account, because Fabric is offering a trial account for a couple of months, which is more than enough for you to play around and get some hands-on in the platform itself. So I'm not going to show you end-to-end how you can set up the trial account, but one of the co-creator, Mr. Will, who already posted a detailed video to set up a Fabric trial account without having a business email ID, because to set up the Fabric trial account you need the business email address. You can't activate your Fabric trial account with your personal email ID, so you need a business email address, and you can do so without the business email ID, and I can quickly show you how I have done that. And even co-creator posted a video around that to set up the trial account. So I have already posted the video in the Google Classroom community itself, so you can join the community and you can have a look at this video link that I have pasted here. You can go through that video and set up the Fabric trial account to get started, and if you want to follow along in this course as well. So let's quickly have a glimpse on Fabric portal itself. The URL you can see app.fabric.microsoft.com. so once you navigate to that URL, you should be able to see this home screen where it says all your data in one location, organize, collaborate and create, and different experiences. So in the introduction video we have talked about different experiences on top of OneLake. So we talked a bit about OneLake, what is OneLake, and how Microsoft is trying to streamline the storage there, and they call it as OneDrive for organization itself. So we'll be quickly looking at different experiences in the portal, and you can see I've already activated trial account, and 41 days left. And you can see the email address. It is my domain, which is at the rate of sheikhmohammed.in, and I have user smacademy at the rate of sheikhmohammed.in, and I have already activated the trial account. So that is a trick to do this. So if you already have Azure subscription, what you can do is you can go to the Azure AD, or now it's called as Microsoft Entra ID. So you can go and create a user. Okay, if your domain is already tagged there, you can create a user, and then you can use that user to activate the trial for Fabric. So maybe let me quickly show you. So here I am in my Azure portal, and if I can quickly jump over to Microsoft Entra ID, formerly called as Azure AD, now it is called Entra ID. I hope all of you are aware about it. So if you go to manage users, and you can search for the user, just to show you the SM Azure Academy user that I have. It's already created, as you can see, with the user principal name there, and you can navigate to the assigned roles, and I've also assigned a Fabric administrator role for this particular user. So if you already have an Azure subscription, directly go to the Entra ID, create a user, fresh user, and if you don't have the domain tagged as well, that's not a problem. You can still create a user, and you'll have a default Microsoft domain, and you can still use that user to be able to activate your trial account. So you can try that. And if you have any questions in activating your trial account, please feel free to drop a note in the Google Classroom community, and I'll try to help you, or you can even comment in the video as well. Okay. And when we talk about Fabric settings, I'll let you know why I've activated or assigned the Fabric administrator role, and without a Fabric administrator role, what are all the settings that the user can see in the admin portal, and why we need this Fabric administrator. With Fabric administrator role, obviously the user can control all of the aspects of Microsoft Fabric itself. Okay, and if you don't have Azure subscription, I would recommend you to have one subscription, because it's really helpful. You can explore other Azure services as well, and also you can create users in tenant, and you can use that user to be able to activate your Fabric trial. for 60 days, right? And that is more than enough for you to be able to explore the Fabric components, different components like lakehouse, warehouse, semantic models, end-to-end you can play around. So that's a bit about the Fabric trial account that I wanted to provide, because I'm not going to demonstrate how you can create the user, how you can use that user from tenant to activate the trial. You can try with the video that I've posted already in the classroom community that I've mentioned, and try and activate it. In case of any challenges, feel free to drop a note. I'm glad to help further. Okay, that being said, once you have the trial account activated for your Fabric admin portal, Fabric portal itself, you can just play around with different experiences. So I just wanted to give you a quick probably experience, looking at different experiences in Fabric and what are all the experiences we have and different navigation options, just to quickly get started. So on the left side, so this is the home page. As you can see on the left side, if you click on this, you can see different experiences like Power BI, Data Factory, Data Activator, and some industry solutions they are building now, real-time intelligence. And under Synapse, you can see data engineering, data science, and data warehouse as well. And on the right top corner, you can see how many days are left in the trial account, and you can click on the settings and you can see different options are available under resources and extensions, preferences. Then under governance and insights, you have the admin portal. We will talk a bit about different settings that are available in admin portal and how you can control different settings as well with the Fabric administrator role that we have just seen. Okay, and here you can just see your the user and domain that you have activated the trial, and the license type, trial status, and different options if you want to learn more about the trial, and if you want to buy once the trial ends, if you want to buy the Fabric, and you can do so in the portal itself. Now you can go to the servers in the portal, type in Fabric, and you should be able to, I think you have to log into the portal with the user that you have activated, and then you should be able to buy different capacities that we will talk about in detail, right? All right. So that is a quick glimpse of the Fabric portal itself. So let's jump back into the presentation. So when planning your data analytics environment, so we wanted to identify the requirements in first place for the solution itself, right? How we can identify one, so how you can assess or come up with deciding factors to choose whether you need to go for a lake house or you want to go for a data warehouse. So here I have built a comparison matrix just to quickly help you to understand how you can decide on different components when you're planning your data analytics environment for your customer, right? So let's quickly look at it. So there are different criteria that you can look at to decide on which component you need, whether you want to go for a lake house or you want to go for a data warehouse in Fabric. So I hope you are already aware about the basics of lake house and data warehouse. I'm not going to get into detail about it, but when we look at the comparison matrix here, you will get a good idea about which component you need to go based on the data type or other criteria as well. That will help you to understand if you need a data warehouse, if your data is structured, or if your data is semi-structured, or video files, or whatever it is. You can go for lake house experience, right? So let's quickly look at each criteria to be able to understand how you can come up with that deciding factor for your solution, right? So the first thing first, data type. As I mentioned, how your data is going to be, or your customer's data is. If it is fully structured, you can go for data warehouse component. You can create a data warehouse and then start ingesting the data there and then do the required transformations. So for our course, we are going to look at COVID-19 data. So the daily COVID-19 case counts, if it's structured, the data set is structured, you can directly create data warehouse and plan your solution accordingly. Or if your data is semi-structured, if you have JSON files, CSV files, some unstructured text files, then you can go for Lakehouse itself, right? So you need to be able to ingest the semi-structured data. So the Lakehouse is a very good option for that. And even if your data is structured, you can go for Lakehouse in case in future if you are planning, or I think it's kind of a better option to go for Lakehouse at this moment, because if your data is structured at this moment or the current point in time, we may tend to go to data warehouse. But what if in the future you may get some unstructured files like JSON files? So you have to plan your solution to be able to scale it in the future as well. So Lakehouse is a better option, I would say, and all of the data would be stored in Parquet format in the backend. So we will look at how you can build the Lakehouse and go forward. Or if your solution demands the data warehouse, if your data is completely structured, or even in the future it is going to be tables in a structured format without any semi-structured data, then you can go for data warehouse and build your solution accordingly. That's the first criteria that you need to look at. And the use cases, as I mentioned, for our data set that we're going to look at, COVID-19 data set. So data warehouse, the aggregated case data, national statistics, so those kind of data, we can store it in data warehouse. And if you're doing sentiment analysis based on Twitter feeds or Facebook feeds, something like that, you can, or hospital reports, testing data, so you can use Lakehouse to ingest your data and build your end-to-end solution, data analytics solution. And with respect to storage, so data warehouse, it's schema on write, relational, as you all know. And with respect to Lakehouse, it is flexible. You can read the schema when you're reading the data for exploration purposes. It's a bit flexible when you're trying to build the solution with the Lakehouse itself. Okay. And compute engine, data warehouse, it's SQL engine for optimized queries, and Lakehouse, it's Spark for large scale data processing. I'm not going to give you the details about Spark. I hope most of you are already aware about the capabilities of Spark for big data processing already. So on schema, as we already talked a bit about it, so Lakehouse schema can be read, okay, when you read the data set, allows for exploration. Data warehouse, schema on write for structured queries. So that is the first comparison matrix that I wanted to give you to help you to understand how you can decide which component you need for your solution when you're in the planning phase for your data analytics environment, because this is quite critical, because you need to understand which one you need to go for based on your data, right? So and also not only at the current point in time, you need to think about the future. If you need your solution to scale in the future as well, you need to plan your solution accordingly, right? So you need to identify the requirements for your solution, and you can look at these criterias, and you can assess your data set, and then you can decide on which component you need, and then design your solution accordingly. That's the first comparison matrix I wanted to provide. So let's jump on to the next slide. So the second comparison matrix that I wanted to provide you is around Dataflows Gen2. In Fabric, they introduced a Dataflow Gen2, which is a Power Query experience. So we will talk a bit about it when we get some hands-on into it. But right now, we'll quickly look at the comparison matrix on which one you need to go based on your data set. Whether you need to go for Dataflows Gen2 or Spark notebooks, which one you need to decide. And we'll also look at the COVID-19 data analytics use case as well, because that is going to be our data set for our entire course. So we will talk a bit about from that standpoint as well. Okay. So let's look at different features or criteria. Again, the data type comes first. So if your data is ideally structured, then you can go for Dataflows Gen2. Or if your data is semi-structured or unstructured or even structured, you can use Spark notebooks to do the required transformation and then load it to Lakehouse further after the transformations are done. So the second thing is the complexity. So Dataflows Gen2, It's very low to moderate. It's suitable for simple ETL operations, and it also depends on what skill sets you have in the team, right? That's very important, because if you have someone in the team who is very less experienced in Spark coding and all, you can go for Dataflows Gen2, and also you need to assess different factors, as I mentioned, the data types as well. And then you can decide on which component you can go for to do the required transformations for your data. And for Spark notebooks, it's high and ideal for complex data transformations using Spark engine and analytics. And performance, Dataflows Gen2 is very limited to moderate scalability. You have to think about scalability when you plan your data analytics environment, which is very important, as I already touched upon in the previous comparison matrix. And if you need high performance for large scale data processing, you need to go for Spark notebooks. So think about it, how your data is going to be ingested. If it's massive, then the first thing that comes to my mind is Spark notebooks, right? So we can't probably go with Dataflows Gen2, so it won't scale if the data set is huge. And user interface, as I mentioned, it's drag and drop into the Canvas and Power Query based experience for Dataflows Gen2. It's GUI based. But Spark notebooks, you need the skill set to code in PySpark, Scala with advanced functionality. So it depends on what skill set you have in your team, and then you can decide accordingly which component you need to create. And also you need to assess the different factors as well. And use case, Dataflows Gen2 for automated data ingestion, you can use it, and for simple transformations. In Spark notebooks, if you need your data to be processed, then you can, in advanced manner, you can go for advanced data processing, Spark notebooks, machine learning and analytics. You can use the Spark notebooks. Let's look at the example with COVID-19 dataset. What I would choose as a part of this course, because we are going to look at the COVID-19 dataset, right? So we can use Dataflows Gen2 to ingest the daily case data from Azure Open Dataset ECDC. We looked at it in the previous video. So if you need to automate the ingestion from the Azure Open Dataset on daily basis, in case, because it's a historical data that we're going to look at, but imagine if you need to ingest the data on daily basis, you can use Dataflows Gen2 to ingest the daily case data from Azure Open Dataset. And you can perform simple transformations like date parsing, column renaming, and load the data into data warehouse or lakehouse for further analysis. And Spark notebooks, you can use the notebooks to handle semi-structured data, like let's say you are getting some hospital reports from different hospitals around the country. You can ingest those into the lakehouse, and you need to perform different transformations on top of it, so you can use Spark notebooks. Or testing data itself, the COVID testing data. And imagine if you need to do some feature engineering, like if you want to calculate the cumulative cases or moving averages across the regions, right? That we will be doing, the feature engineering and all we'll be doing in the Spark notebooks shortly in the future videos. So you can use Spark notebooks if you need to do such feature engineering as well. It is very with the PySpark or whatever skill set you have in the team. And you can store the transform data back into the lakehouse as well. So I hope this helps you to understand how you can decide on which component you need to pick or plan your data analytics environment, depending on different criteria that we're seeing here, like data type, your complexity, and the skill set you have in the team, performance, which is very important, and use case, whether you need to have a automatic data ingestion or simple transformations, or you need some advanced transformations and feature engineering to be done on your data. Okay, so that's a couple of comparison matrix when you're trying to identify the requirements for your data analytics solution in first place. So these are all the questions you need to ask your customer if you're not sure about the data set itself, right? So you need to have a questionnaire with your customer and ask all of these questions, keeping in mind the different criteria I've just pointed here, and raise those questions to your customer and get the data points, and then decide your solution accordingly and design it accordingly, and decide the components accordingly. Okay, let's move on. And let's look at the data gateway types. So as a part of exam, you may have some questions related to different data gateway types. So if you need to ingest the data into the Fabric solution, how you can get it done if your data resides in on-premises or if it's residing in Azure itself. So again, I've put a comparison matrix just to help you understand in an easy way with different factors. So here again, I have different criteria listed, and when you need to go for on-premises data gateway or VNet data gateway. So there are a couple of gateways that you can use, and I'm not going to get into the demonstration of how you can set up the different gateways. Maybe what I can do is I can share the co-creator videos, because they have already posted videos in detail on how you can set up the on-premises data gateway or VNet data gateway if your data is fully in cloud, or if you have on-premises data, how you can set up the on-premises data gateway. But as a part of this video, we'll quickly look at the comparison matrix, which one you need to go based on different criteria again. Okay, so that will help you to understand which data gateway you need to pick to ingest your data into the Fabric solution. All right, so deployment, how you can deploy the gateway. So on-premises data gateway requires installation of a physical virtual server. So basically it's an application that you need to install on the virtual server to be able to establish that connection between your on-prem server and the Fabric. Maybe let me quickly jump over to show you. Yeah. So I think Microsoft is providing this article for you to set up this gateway end-to-end, or if you're comfortable looking at videos, I can share the co-creator videos to how we can install this gateway in the on-premises server and establish the connection to the Fabric. So basically, as you can see here, it's an application that you need to sign in and then set up the data gateway. Okay, so and in Fabric portal, you can manage the connections and gateways that I can quickly show you now, and the different types that you have and how you can configure that as well. So let's jump over to Fabric portal, and on the settings side, under resources and extensions, you can see manage connections and gateways, right? So just click on that. Here you can see different connections. Okay, let's look at how you can create one, whether be it on-premises data gateway or virtual network data gateway, in case if your data resides in Azure already and you need to provide that link between the Azure storage to your Fabric, right? And here you can see there is a new button on the top left. Click on that and you can see the new virtual network data gateway that you can set up. But I'm not going to get into how you can set up one. I can share the video in case if you want in the community, Google Classroom community, for you to set up or get some hands-on into that. On-premises data gateway. Okay, so I think you might, yeah. So when you under connections, when you click on new under connections, you can have different options like on-premises, virtual network, and cloud. Then you can start creating a new connection and then try and configure your data gateway accordingly. So let's jump back to the presentation to look at different criterias and which option you need to go. So yeah, again, if your data resides in on-premises, obviously you'll go for on-premises data gateway, or if your data is fully cloud-based, okay, integrated with Azure VNets, you can go for VNet data gateways. Data sources on-premises like SQL, Oracle, file shares. Sources for VNet data gateway, Azure services like SQL DB, Data Lake Gen2 storage. You can bring the data into the Fabric. And from security standpoint, so on-premises data gateway, it's encrypted data communication. On the VNet data gateway side, it's VNet level security, which we already have with private connections. Latency, on-premises data gateway, you may have some higher latency for large scale data processing. VNet data gateways, since the data is already in cloud, so it will be low latent and optimized for real-time data as well. And with respect to maintenance, on-premises data gateway, as I talked about it, you will be installing an application in the virtual server. So manual updates are required. You need to take care of it. And VNet data gateways is completely auto-managed by Azure itself. You don't need to worry about the maintenance part for that. Use case: on-premises data gateway, hybrid on-prem and cloud data integration to bring your data into cloud from on-premises. And VNet data gateway, cloud native, secure Azure data integrations. I hope that gives you a bit of understanding into which data gateway you need to go for. And if you need to dive deep into how you can create or establish with some samples, watch out for the space in the Google Classroom community. I will be sharing the video for you to probably dive deep in. Okay, but as a part of this video, we'll just quickly look at these differences and the deciding factors on which data gateway type you need to choose. Okay, all right, let's move on. And let's quickly look at the capacity stock keeping units based on your solution or which SKU you need to choose. The capacities are actually split into different stock keeping unit SKUs, and each SKU provides a set of fabric compute resources for your organization. And your organization can have as many capacities as you need it. So okay, let's jump back to the browser to look at different capacity SKUs that are available provided by Microsoft. So capacity, as you already know, we had a bit of introduction into the capacity. Okay, so you can think of it as a compute resource that are required to get the job done for your data analytics environment, right? So listing pool of resources allocated. And let's scroll down, look at different capacity SKUs that are available. And capacity units are nothing but it's used to measure the compute power available for each SKU. So F2 is the minimum SKU with 2 capacity units, and it can go up to F64. And then trial account that we are currently using, that we have activated for a couple of months, it's having 64 capacity units. It's equivalent to F64. Otherwise, if you need lower options, you can go for it. And you can buy these capacity SKUs in Azure portal with the account that you need to log into the portal. Okay, and you have higher capacity SKUs as well. Okay, and if you need to dive into different SKUs to understand more about it, I can share the link in the community as well. Okay, let's jump back to the presentation. So you need to decide which SKU you need for your solution, and again you need to assess the data set, whether it is massive or the load, the SKU that capacity that needs to be managed. So decide your SKU accordingly, and then yeah, you can plan your SKU accordingly. And let's look at different recommended settings in the Fabric admin portal. So I will quickly take you through the admin portal and different tenant level settings and domains or different settings what we have there. Let's jump over again back to the Fabric portal. Let me come back to home and click on settings, scroll down. Under governance and insights, you can click on admin portal. That will take you to the admin portal. Okay, now very important point here. Okay, so since I have the Fabric administrator role, I'm able to look at all of the options under the admin portal to be able to manage all of the settings for the entire organization. And if you don't have that Fabric administrator role, you will be able to see only the capacity settings, nothing else. You will not be able to manage the tenant and different options with respect to workspaces or. Okay, so in the Microsoft official documentation, you can also see that I've just mentioned. So to access the admin portal, you need a Fabric license and the Fabric administrator role, right? As you can see here. Without that, if you're not in one of these roles, you only see capacity settings in the admin portal. Okay, so that's exactly I was pointing. So since I already have, let's log in back to the Azure portal. And just give me a minute. Just to show you again whether I have the required role. Okay, so enter ID users, just to cross check whether we have the required role for that user, SM Azure Academy, and you can go to assign roles. We've already assigned, it's taking a bit of time, just a moment. Yeah, so we've already assigned Fabric Administrator, and this user can manage all of the aspects of Fabric. That's the reason you are seeing all of the settings that this user can manage and control the settings for the entire organization, right? So you can see different, we may not be able to look at every setting because you can see under tenant itself, its settings are quite huge. Maybe we can look at different categories and just quickly glance through different settings. Or from exam point of view, we can look at some of the settings, but we can't go through each and every setting as a part of this video. Under tenant settings, you can see whether the users can create Fabric items, whether it is enabled for entire organization or not. So different users, whether they can create different Fabric items or not, that is enabled. So users can use production ready features to create Fabric items. So you can enable that. It is already enabled, and you can see different settings like users can create and use ADF mount items that are many of the settings are in preview. As you can see, Microsoft is building that at the moment, like sustainability solutions, retail data solutions. Those are all disabled for entire organization. And you can see database mirroring in preview, and mirrored Azure Databricks catalog, that is in preview, that is new at the moment. Those are all different settings that you can have a look. And help and support settings, domain management settings, workspace settings. So we talked about different components in introduction video. So if you want to control different settings for your workspace, yeah, obviously to create the workspace is enabled for entire organization. You can control that in case if you need to apply the setting only to specific security groups, not for the entire organization. If you have some groups defined, you can enable the creation of workspace only for that specific groups. Okay, so you can do that. And use semantic models across workspaces, that is enabled. And different settings are there. Information protection, how we want to apply sensitivity labels to different artifacts, and allowing users to apply sensitivity labels for content, so with respect to information protection. And export and sharing settings, external data sharing is in preview. So whether guest users can access Microsoft Fabric at the moment, they can do it. So you can see guest users who have been added to your intra directory can access Fabric and any Fabric items. If you want to control that, you can control that from here. Okay, so it's just a toggle for all of these settings. So if you have the required role, you should be able to control the settings for your entire organization. Okay. That being said, yeah, there are many sharing settings. You can see exporting it to CSV, exporting to Excel, whether you can control that. It's, I think, by default enabled, I guess. So you can control that as well. You can download the reports, exporting the reports as XML documents, image files disabled, all those things. So let's go through it. We may not be able to go through each and every setting. It's not possible, but you can go through the settings, and in case if you have any questions, you can post it in the community. Feel free to ask in the video as well. Okay, app related settings, integration settings, like they're allowing the XML endpoints and analyze the in Excel with on-premises semantic models. It's enabled by default. Okay, so you can control that. Maybe I think we will revisit these settings when we look at the data set, and then when we dive deep into the course, we may revisit these settings and then control as well. Okay, but at the moment, you just be aware there are a lot of settings under tenant that you can control. And if you go to usage metrics, you can open the admin monitoring workspace to look at the usage metrics. Then users, you need to get into the 365 admin center to manage the users, admins, and groups there. Okay, it will take you to a different portal. And domains, we talked about it in the introduction video. Domain you can create to help teams in your organization and make the governance bit easier for your team. Like, you can create domains like finance team or HR, and then assign relevant workspaces to them, and you can control that with domains. Capacity settings, which is very important. Even without Fabric administrator role, you will be able to see this capacity settings. So right now you can see, or be a premium, embedded, trial, Fabric capacity. I think you can see the trial and who are the capacity admins there. And if you click on actions, you can see who are all the service admins there, right? So SM Academy at the rate of Sheikh Mohammed.in, the capacity name, and you can see the capacity units. As I told you, I think trial account, Microsoft is providing 64 capacity units, which is more than enough for you to build some sample project end to end that we are going to do in this course with COVID-19 dataset, and to explore the different experiences and play around with the platform itself. Okay, and you can see the workspace related settings, Azure connections. You can connect to different Azure resources from here. Workspaces, you can see different workspaces that you have here. And yeah, so I think on the left side, we'll get into the workspace that we have created for DP-600 shortly, but you can control the workspace related different workspaces that you can see here. Okay, custom branding, protection metrics, and different options are available that you can go through in Fabric admin portal to control the tenant level settings and others capacity settings for your organization. Let's jump back to the presentation. So we quickly looked at different settings in Fabric admin portal with respect to tenant, and we looked at which role, the Fabric administrator role, which is required for you to be able to control all of the settings for your organization. Without that, you'll not be able to see only the capacity settings is visible for you. Okay, so keep that in mind, and let's jump on to the next slide. How we can implement and manage your TA environment. We already looked at the management part with different settings in the Fabric admin portal that you can control at tenant level, domain, workspace, and stuff like that. So as a part of this implementation, what I wanted to show you is the permission model in Fabric. So how you can implement your workspace or item level access controls for Fabric items. So let's quickly look at the permission model, how you can control the access to different workspaces or even to the different items like lakehouse or warehouse or be it semantic models. Okay, so let's jump back to the Fabric portal. Or before we get into the portal, I just wanted to show you the permission model itself. Okay, so let's look at the Microsoft documentation quickly with respect to the permission model. So the workspace roles, we'll look at the workspace roles. What are the different workspace roles that are available, and then we'll quickly look at those roles that are available in the portal itself. Okay, so why you need this role for workspace? To be able to control access to different workspace and the content within them. You may have different artifacts created like the lakehouse, warehouse, Dataflows Gen2, then the semantic models built on top of your warehouse or lakehouse, and then the reports. All of those artifacts are residing in the workspace, and you need to control access and provide the required privileges for the user to the workspace itself. So there are different roles that are available in workspace like viewer, contributor, member, and admin. So it's self-explanatory. So you can see viewer can only view all of the content in the workspace. They can't modify. Contributor can view and modify all of the content. Member can view, modify, and also share the content in the workspace to others. Admin can have full control. Maybe I think it's a good idea to look at different capabilities and how those capabilities are restricted for different roles. That will give you an idea. And from exam perspective, it is very important. So we will look at a couple of capabilities and how it is restricted to different roles when it comes to the workspace roles itself. Okay, so this is at a very high level. Small set of capabilities like you can see admin have full control. Member can add the members, write data, create items, and read data, but they can't add another admin or delete the workspace. Contributor, they can't even add other members or admins, but they can write or modify whatever data they can in the workspace. Viewer, they can only read data, they can't control members, admins, addition, or writing data to it. Maybe let's look at in detail. We have a detailed list as well from Microsoft with respect to the roles for workspace. Yeah, so maybe I can highlight few capabilities from exam point of view. One thing which I wanted to highlight, I think you can go through this. I can share the link if you want in the classroom community. One tricky thing, so you can see here, reading the lakehouse and data warehouse data and shortcuts with T-SQL through TDS endpoint. Okay, so that is enabled for all of the roles. Okay, viewers can do that, but let's look at this particular capability. Reading the lakehouse and data warehouse data and shortcuts through OneLake APIs and Spark is not enabled for viewer role. Okay, only contributor or higher role users can read the data from lakehouse or warehouse through OneLake APIs or Spark. Viewer cannot do that. So there might be a question in the exam, because we tend to choose viewer role when we see, okay, reading the lakehouse and data warehouse data and shortcuts through the APIs and Spark, we'll go for viewer role. No, you need to have a contributor role if you need to access the data through Spark or OneLake APIs. Okay, so that's one catch which I wanted to highlight. It's important from exam point of view. So go through different capabilities and try and understand what. So you can see only viewer role is enabled for these capabilities, right? Viewing and reading content of data pipelines and notebooks, Spark job definitions, ML models and experiments, KQL databases reading, connecting to SQL analytics endpoint. So we will talk about what SQL analytics endpoint. When you create a lakehouse, a SQL analytics endpoint would be created, and you can read the data through that endpoint from lakehouse. Okay, and reading the lakehouse or data warehouse data through with the T-SQL through the TDS endpoint. So that is possible, but through Spark it is not possible with viewer role. Okay, so go through different capabilities and familiarize yourself with respect to the Fabric workspace roles, because from exam point of view, this is very important. They might ask you which role is required based on different capabilities. Okay, so that is one thing I wanted to cover quickly. And let's jump back to the presentation. So that is with respect to the workspace. And if you need to control item level access, that is also possible. Okay, maybe let me show you the workspace roles in the Fabric portal. Let's look at the course workspace itself. I've just pinned it. Let me move on to the DP-600 course workspace that I've created, and there are some artifacts which we will look into it in the further videos. Here you can see manage access for this particular workspace, or you can go to the workspace and you can see the list of workspaces that you already have. And in this DP-600 course workspace, you can see manage access. Click on that. So you can add people or groups, and when I try to do that, you can provide the user email ID or group email ID, and you can see the list of roles that are available that you can provide: admin, member, contributor, and viewer, and provide the least privilege to that user. And to be able to provide that, as I mentioned, look at the different capabilities and then decide which role is required for the user and then provide controls accordingly for the workspace. So as you can see, by default, the logged in user is the admin who can control all of the aspects in this workspace, DP-600. Okay, the item level access controls are also possible. Okay, so you can, let's say I have a lakehouse here, COVID lakehouse. So you can click on the three dots. You can click on share. So you can grant people access to this lakehouse. Okay, you can share this lakehouse, and there are different permissions that you can provide. By through SQL endpoint, they can read the default dataset, but to allow them to read directly in the lakehouse, grant some additional permissions. And what are all those additional permissions we have? Either you can provide read all SQL endpoint data, which is accessing all of the lakehouse data using the SQL endpoint. Okay, so they can read the SQL endpoint data. Read all Apache Spark, which is like accessing the underlying data files with Apache Spark. Okay, so that is one permission. So you need to decide which permission that you need to provide for the user or to the people that you're sharing this lakehouse to. Okay, so this is at the item level, not at the workspace level. You are granting people access to this particular item, which is the lakehouse. Okay, and building reports on the default semantic model, that is another permission that you can provide, and you can notify the recipient as well. Okay, so that is the item level access control. And if you need to control all of the artifacts inside the workspace, then you need to provide workspace level roles that we just discussed. Okay, all right, so let me jump back to the presentation. So we looked at different workspace roles, how we can implement that and control access, and even the item level access controls for different Fabric items. Okay, so I hope you got some idea about the permission model by now. And implementing data sharing for workspaces, warehouse, and lakehouses, we just quickly looked at briefly how we can share your lakehouses or different notebooks as well. Okay, so even this is one of the notebook that I've created for DIM generation that you can share. Again, you can share it via email or link for them to be able to look at this notebook. You can again control how you want to share this notebook, Spark notebook itself, whether you need the users to share it or edit it or just run the notebook alone. So different controls are available with respect to notebooks. So for each and every item, the controls differs. Okay, like lakehouse, we have seen how we want the user to read the data, whether they can access the SQL endpoint or provide access to the underlying data. A notebook, whether the user wanted to run the notebook or they wanted to edit. So for each and every item, the sharing controls differs. Okay, so you need to be able to understand that. Okay, jump back to the presentation again. We'll cover a few more points. So we looked at the workspace item level access controls, then data sharing for workspaces, warehouse or lakehouse, or even notebooks models. You can look at it, and then how you can manage the sensitivity labels in semantic models and lakehouses. Maybe in the later part of the course, when we build those artifacts, I can show you how we can manage the sensitivity labels. But I think we looked at how you can control the settings in the Fabric admin portal with respect to sensitivity labels. But we'll look at it in detail in case if you want to create one. When we create the semantic models for our course using COVID-19 dataset, we will look at it. Okay. And configuring Fabric enabled workspace settings, we just looked at it. What are all the different settings that are available? Okay, I'm sorry. I think we looked at the access part, but let's look at different workspace settings, that are available as well. Click on workspace settings. So we earlier looked at Fabric admin portal settings, but these settings are with respect to the workspace itself. We can see you can customize the name, description, license information. This workspace is part of trial license. Okay, and the semantic model storage format, you can see that, and the connection link, Azure connections if there are any, if you have configured to Gen2 storage, and system storage, Git integration if you want to control the source control for your workspace. You can integrate your Git and then manage the code and back up your work. OneLake settings, and you can also download OneLake app like a file explorer to seamlessly integrate your data. Okay, like a Windows file explorer, you can download and have an app locally as well. Workspace identity, there are different settings that you can go through under data engineering science. You can see the Spark settings. As a part of trial, you can have a memory optimized node family with number of nodes ranging from 1 to 10, and you can control that. As a part of trial, we have this default settings which we are not worrying much about it, which is F64, which is more than enough. You can see the runtime version for Spark. And under data factory, you can see some settings like Apache Airflow settings. Okay, so just be aware what are all the different workspace fabric enabled settings that are available that you can control at the workspace level. Okay, so let's jump back to the presentation again. So we looked at all of the permission models and managing the fabric capacity and configuring the capacity settings as well, right? So I think we already looked at, let me jump over to the fabric admin portal again. Resources, extensions, admin portal, capacity settings. So here it is a trial, so we can't control much. So maybe I think as I've told you already, you can buy different SKUs from Azure portal. In case if your trial ends, you can purchase different capacity units based on your requirement from Azure portal. Okay, so I can show you probably later, but with trial account, you no need to worry for 2 months. But how we can purchase the fabric capacity SKUs from Azure portal, maybe I will show you in the another video. Okay, so that being said, I think we are wrapping up this video. Yeah, so thank you very much for watching, and I hope this video helps you to understand how you can plan the data analytics environment, implement different controls to your data analytics environment, and how you can manage with different settings at the admin portal level, and which role, the fabric administrator role, that you require to be able to control all of the settings for your organization. And it is very important for you to understand and assess your data set, or have a questionnaire with your customer to understand their requirements and then plan your data analytics solution accordingly. So please consider subscribing, and so that you'll be notified with future videos or further videos in the series that we plan for the course. And I'll see you in the next video. Thank you so much for watching. Hi everyone, welcome back to the channel, and welcome back to the course on DP-600 Microsoft Fabric with real world project. And in this video, we'll be looking at managing the analytics development lifecycle. And if you don't know me, this is Sheikh Mohammed, Azure Solutions Architect and Fabric Analytics Engineer. So let's dive in to the roadmap quickly. So we are in a 10-part video series. So we earlier looked at a couple of videos already there as a part of this course. So video 1, we looked at the introduction to the course and the dataset COVID-19 overview. And in the video 2, we looked at how we can plan, implement, and manage a data analytics environment. And in this video, we'll dive deep into how you can manage the analytics development lifecycle itself. And later on, we'll be looking at the data ingestion into lakehouse, warehouse, and how you can transform the data and implement star schema with SCD type 1 and type 2. Then we'll be looking at performance optimization, and then we will be designing and building the semantic model with the dynamic row level security and object level security. And then we'll be optimizing, and then we'll be doing some exploratory analytics as well. And finally, we'll be looking at some exam preparation tips as well when we finally wrap up the course. And if you're not in Google Classroom community yet, so I would recommend you to check out the Google Classroom community. So let me jump over to the Google Classroom community quickly. So this is the classroom that I've created just to help you with all the required resources that we'll be creating throughout the course. So here you can see a stream with the posts, and whenever we post a new video, you'll get a notification, obviously from YouTube as well as from the Google Classroom community as well. And you can also look at the resources, so that I'll be keep on adding as and when we progress throughout this course. So right now you can see I have posted the link for the ECDC COVID-19 dataset, public dataset, and the official study guide for the DP-600 exam as well. Okay, so the link will be provided in the description, so you can join. You can just join through the link, and you'll be notified whenever a new video is posted or any other resources will be posted in the Google Classroom community, right? All right, so if you haven't checked out the previous videos, I would recommend you to go through the introduction for this course and the dataset overview, as well as how you can plan your data analytics environment and manage your environments, because that is quite important. So I talked in detail about how you can plan and manage your data analytics environment, and how you can control access to workspaces and item level access in detail as well. So check out those videos. Okay, before we dive into this video to see how we can manage the analytics development lifecycle, please consider subscribing to the channel so that the future videos, when I post it, so you'll be able to get a notification and look at the videos further as well. So consider subscribing. Let's dive deep into this video now. So to start with, we will talk a bit about how you can implement version control for a workspace in Fabric. So in this course, we will try as much as we can to get some hands-on, because that's the idea or the intention behind to build this course with the real-world data set and provide you with the hands-on as much as we can. So I'll try and see how much I can limit the presentation slides so that you can have a look at the Fabric portal and different settings, how we can play around with different artifacts or components in the Fabric. So that's the idea, entire idea of this course. So I will try to limit the presentation with a few points, and then we can jump over to the portal and then see the concepts or settings or whatever it is, the capabilities of Fabric in action, right? So let's quickly look at so nothing much in the slide, so I just want to dive deep into the portal to show you how you can set up the Git in Fabric for your workspace. So we will jump back right in, but I don't want to talk about the basics of version control that you require. So in any software development lifecycle, okay, or especially in data analytics, you need to make sure you have the version control in place, and it's much required. So even Fabric is providing a couple of options for you to connect your Git, so to either Azure DevOps or GitHub. But in this video, we'll look at how you can make a connection to your Azure DevOps organization, and how you can connect and integrate it, and then see how you can make changes to the components or artifacts, whatever it is, be it lake houses, notebooks, or Dataflows Gen2, and then we'll see how the commit is happening. So it's all the basics. We don't want to get into the basics, but we will see how this capability can be done in Fabric itself. So let's jump back to the Fabric portal. So here I'm in Fabric portal. So we are seeing the DP-600 course workspace. So on the top right, you can see the workspace settings, right? So I've already integrated the Git, the Azure DevOps, but I can just show you if it's a brand new workspace, and if you're following along in this course, I think you can go ahead and integrate the Git. So I can quickly show you how we can get it done. So under workspace settings, so you can see there are a lot of options. So in the previous video we looked at in brief, but you can see there is a Git integration option, right? So here you can connect to your Git. So maybe I can open a test workspace to show you how it looks like even without connecting to the Git itself, right? So here you can see I've connected to the organization, the project Git repository already, and the branch itself, right? So the connection is already established. So let me open another workspace, not this one, the DP-600, maybe a test workspace, let's say, which I have here. No components are there in this workspace, but just to show you how it looks like when you have a brand new workspace and if you wanted to enable the Git for your workspace. So click on workspace settings, Git integration. There you can see the Git providers, Azure DevOps and GitHub. So click on Azure DevOps, and it will show you the Entra ID account or Azure AD account. So you can click on connect, and if you already have the organization there, it will show up there. Otherwise, if you haven't created any organization, so what you can do is you can navigate to dev.azure.com, and then you can try and log in with the same user account that you've activated your trial fabric account, right? So then you can create the default organization, and then you can set up the organization first. Okay, that you can do. That will be pretty much simple. So I don't want to guide you through that process. It will be easy, and if you face any challenges in setting up the organization in Azure DevOps, please feel free to reach out. I can glad to help on that. So that's how you can connect, and then you will need to have a project, Git repository and branch. You have to tag it, right? So if we go back to our DP-600 workspace, let me click on workspace settings, Git integration. So it is already linked, as I mentioned. So the Git repository name is SM Academy, as you can see here under the organization SM Academy 026. That's the default organization. If you click on this projects, you'll be able to see all the capabilities in DevOps. And if you're new to DevOps, it's pretty much simple. You can go through different capabilities in DevOps, like the dashboards, repositories, pipelines, test plans, artifacts. You can go through it, but from exam point of view, you don't need to know more about DevOps in detail, but just know how you can integrate the Git in your workspace. So that's more than enough. But to get some hands-on, you need to have this organization repository created so that you'll be able to link and then get some hands-on in Fabric. So that's the idea. So here it is already linked. So let's see. So once you have the Git integrated into your workspace, you can see the source control button enabled here, right? So with right now, I think I've made some changes to one of the artifact, and then it is not committed to the repository. And that's the reason you can see there is something we need to commit to the repository itself, right? You can see if you click on source control, you can see the current branch, and if there are any changes that are pending that we need to commit to the repository, that you can see there. And yeah, it says this notebook, ECDC cases transform notebook is modified, and then we need to commit it, right? And yeah, I think you can start making changes once the Git is integrated, and then let's try and see, if we can try and commit. So, and before we commit it, you can come here under repository. You can click on commits in this repository. You can see. So when I integrated this Git, this organization from Azure DevOps, I just added an README file, and then I committed 3 different items, and then I did a test commit just to see how that commit works. Maybe we can try a quick commit to see. Don't have any updates. We can say test commit, and we can try to commit this particular item, this notebook. All you need to do is just click on commit. It will do the job for you. So pretty straightforward. once you integrate the Git into your workspace itself. Okay, so it's done, and now you can see all of the changes are committed, and there is nothing pending from this workspace, right? So if you go back to the commits, there you can see the test commit that we have done just now, and if you can click on that, you can see the notebook, okay, whatever notebook that we have committed, and then the difference is, so you can see I've just added df just to see just to test this functionality. That's it. It's pretty simple. Okay, so that's how you need to integrate the Git, and it's pretty straightforward. At the workspace level, you need to integrate the Azure DevOps or GitHub, and then you are there. Whatever changes you make, you can commit selective items, or if you want to select and commit all of the items, you can do that. And the branching, as you are already aware, you can create different branches and then maintain the branches, and then you can point to a particular branch as well. Here I have pointed to main branch, so all of the commits will go directly into the main branch. So if you click on branches under repos, you can see there is only one branch, but you can always create a new branch, and then you can commit to that branch, and then you can stage the changes to the main branches, or how the ideal workflow looks like. You can plan it accordingly. Okay, but here, just for demonstration purposes, I have created only the main branch, and then I have committed just to show you how the Git integration works in Fabric. Okay, so that's all about the Git integration functionality in Fabric. It's pretty straightforward. You can go ahead and link it, and then start making changes and see the version control in action in Azure DevOps. Okay. All right. So let me come back to the presentation. So we looked at the version control and then a quick hands-on. So if you have any questions, feel free to reach out to me in the Google Classroom community, or comment in the YouTube video as well, so that I'll look at it and then try to help you as well in case of any challenges in setting up or integrating your Git Azure DevOps. Okay. So with respect to the Fabric trial account, if you are this far in this video, I hope you have already set up the Fabric trial account. So in the in the second video, when we are in the planning phase, I talked a bit about how you can set up the Fabric trial account without even the business email address. So you need to have the Azure subscription, and then you need to create the user in the intro ID, and then with that user you can activate the Fabric trial account. Okay, so if you haven't activated it, look at that previous video, video 2 in the course in the playlist, and then set up the Fabric trial account, and then you can work on integrating this DevOps stuff, and then start building lake houses and data warehouses. And if you want to follow along, I would recommend you to create a Fabric trial account, and then try to integrate Git and get some hands-on with, because the whole idea of this course, just to reiterate again, is to give you hands-on as much as I can. Okay, so that's the whole idea with the sample data set, the real world data set, which is COVID-19. So if you're following along, just go ahead and create a Fabric trial account, and before that, get the Azure subscription. Don't worry about linking your credit cards and all. It's a pay as you go, as you know, right? So most of you are aware it is pay as you go. So you can you'll be paying the amount, or you'll be billed only for the services that you'll be using, right? So nothing to worry. You can set up the Azure subscription, and then create the user in the intro ID, and then you can activate the Fabric trial and then get some hands-on, because there is no point of going through videos and then without getting any hands-on. There is no point of looking at only the theory. So please go ahead and get your subscription, Azure subscription, and then activate your Fabric trial. Then you'll be billed only for and for Fabric trial you will not be billed, right? So at all, it's free for 2 months. So if you're creating any other services in Azure, maybe you need to make sure to look at the pricing tier and then play around with the services, right? So go ahead. Yeah, let's move on further in this video. So let's look at the deployment pipelines and then the impact analysis of downstream dependencies. So we will quickly look at the deployment pipelines, how you can set up the deployment pipelines with different stages in Fabric. So let's jump back again to the portal. So here I'm again in the DP-600 codes workspace. So again, I've already created a deployment pipeline. Okay, so that's the reason you can see view deployment pipeline on top here. Otherwise, it will ask you to create a new deployment pipeline for this particular workspace. So what is this deployment pipeline? So we'll quickly look at this capability that Microsoft is providing in Fabric platform itself, right? So so even if you can go on the bottom left, you can look at different experiences, and workspace. If you click on workspace, you can see different workspaces that you have already created, and then you can see deployment pipelines. You can navigate to deployment pipelines from here or from within the workspace as well. Let's try and navigate to deployment pipelines from here. This will take you to a page where it will show whether you need to create a new deployment pipeline or the existing ones will also be there, right? So let me click on the already created one just to show you. So when you create this deployment pipeline, the whole idea is to stage the changes right from development to production, right? So here you can see I've created 3 different stages. So the development stage, and then I have linked the workspace. So the idea here is to link the workspace to each stage. And then when we are making some changes to the items, be it lakehouses, warehouses, or notebooks, then the changes will be staged to the further stages like test into a different workspace, okay, and then we will be pushing it to production finally. So that's the idea of deployment pipeline. So here you can see in development stage I've linked the DP-600 codes workspace, and I think this is the earlier capability. Now I think Microsoft introduced new view as well, just the experience, the user interface. You can see if I toggle new deployment pipelines, you can see a different view. If I toggle back, you can see this, and you can see there is no warehouse, no dashboards. I think only limited items we have at this moment in this workspace. So I have created one lake house for the demonstration later on in this course when we dive deep into the preparation and serving data, which is 40 to 45%. So lake houses you can see, and 2 notebooks are there, okay, and you can see an orange icon, right? So what does that say? So the changes were made to the content since the last deployment. So there are some changes I've made to the development stage which is not deployed into the test environment yet, and between test to production it's synced completely. No changes were made to the content. Okay, so it's completely synced between test and production, but I've made some changes just to test how this capability works. And you can also look at, so I think what I've done is I've just deployed from development stage to test, and then it auto created a new workspace like DP-600 codes test, and then I've deployed again from test to production, and then if it has auto created DP-600 codes production workspace. So each and every stage we need to link the workspace to that particular stage, okay, and then whatever changes goes through to any of the components inside that workspace will be staged between different stages. That's the whole idea of this deployment pipeline. So I've created this COVID deployment pipeline already just to demonstrate how this capability works for you, right? So also here you can see what are all the changes. If you click on more options, you can do a compare right from here, and then review the changes as well. If you click on compare, so you can see, just scroll down, so you can see, yeah, so that this particular notebook has some changes which needs to be pushed between from development to test environment. And if you click on review changes, it will open a different dialog for you. You can review the changes right within this experience. Okay, so here you can see I've just added DF just to see how this capability works in deployment pipeline. That's it. And let's try and push this. Click on deploy and see how that works. So it's just a click of a button, you can deploy to a different stage. Click on deploy, and then it's trying to deploy from development stage to test now, as you can see in action. Now it's done. So now we can see its development and test is completely synced, but we need to deploy these changes from test to production. Okay, so again, from this stage to this stage. It's pretty straightforward, and if you go to workspace, you can see this is our main course workspace. And when I created the deployment pipeline and then try to deploy to test and production stages, it auto created for us. Okay, or you can have a different workspace, and then you can try and stage your changes accordingly. Okay, so that's the whole idea of deployment pipeline, and I hope I've given you some idea into this capability. Okay. And you can also, one more thing, you can also look at the deployment history, right? So across different stages, what were the changes that we were trying to deploy, right? So from to test or to production, and how many items we have pushed, and you can click and see the different items as well, right? So how many items pushed into this production stage last time, and Lakehouse, couple of notebooks, so we can track the history of deployments as well from here. Okay, yeah, so let's go back to the presentation. So we quickly looked at the deployment pipeline capability in Fabric. Okay, so now we'll also look at how you can perform impact analysis of downstream components from lakehouses, data warehouses, data flows, and semantic models. So just a snapshot, but let me take you through how you can do this impact assessment in case of any changes in any of the upstream components in Fabric. So let's jump back again to the Fabric portal. So let me come back to the DP-600 course workspace. So here you can see it already tagged the stage for this workspace when we created the deployment pipeline, and you can view the deployment pipeline, and then the Git integration is also done, and it's all synced already, right? And here we have a couple of views. One is the lineage view that you can see, and the list view as well. If you click on list view, you can see the Git status, type of the component, lakehouse or notebook, and then the owner, stuff like that. But if you want to look at the lineage view, it will show you a lineage view like this from lakehouse, what are all the components and all. So how we can do the impact assessment, right, or impact analysis from the upstream components. So let's say we have a lakehouse, COVID lakehouse here. So in the next video, we will dive into how we can ingest the data into lakehouse and stuff like that. But right now, for this video, we will look at the analytics development lifecycle and different capabilities. Okay, so here you can see there is an icon. I don't know what to name this icon, but you can see it shows the impact across workspaces. So if you click on that in lakehouse, COVID lakehouse, so it will show the impacted child items by this lakehouse, all the child items or all the downstream items, and it will say child item 7 and then the downstream items as well. And you can see what are all those items as well, right? So browse by the item type, you can look at the item types, and you can see different notebooks are there already under this lakehouse that are tied. Okay, and then the child items, if you go to child items, you can see 7 impacted items. Okay, so the analytics endpoint, COVID lakehouse, and then the notebooks as well. Okay, okay, so it's not duplicated. Maybe it's trying to show different stages. I'm thinking maybe it could be a bug as well, because I can see it's replicated. The same notebook is replicated. Maybe Microsoft is working on this, I'm not sure at the moment, but we can explore that later. But if you're making any changes to the lakehouse, so you need to perform this impact assessment or analysis to see what are all the downstream components that are going to be impacted if you make this change. That's the whole idea. So it will show you all of the downstream items or child items, and then how you need to plan your change accordingly for that upstream item. So that's the whole idea of this impact analysis. And you can also notify the contacts in case if you need to if the owner of the downstream component is someone else, right? So you can always notify them. So there is a button called notify contacts. So you can click and then you can send a notification message. You can compose the message that is required to all the contacts for all impacted workspaces. Okay, so it's pretty straightforward, but it's powerful capability which you need to do this impact assessment when you are making any changes. And in case if you are trying to do the impact analysis, if you're, let's say if you're making some changes to this notebook ECDC cases transform, so I can look at the impacted items, nothing is there, so no downstream items involved from this notebook. Okay, and similarly for dim generation notebook also nothing is impacted, so I can see there is no no components further in the downstream. And if you are making some changes in the analytics endpoint, obviously one impacted item, which is the semantic default semantic model that you can see here. So you can come to the lineage view, and this is very simple lineage view. We are yet to build the components in this course, but in an enterprise setup, imagine there could be many components that are created in a workspace, and then you have to make sure you need to do this impact analysis to be able to kind of do the assessment and then action on it accordingly, and then notify the contacts for any downstream dependencies. So that's the whole idea. Okay. That being said, let me come back to the presentation. So that's it about this slide. And then I wanted to talk about XMLA endpoints for semantic model connectivity from client apps. So we will talk a bit about what XMLA endpoint is. Okay, but unfortunately, this capability I cannot demonstrate because it is tied to the premium licenses. You know, with trial account we cannot demonstrate, so we cannot look at that capability in the Fabric. But I can give you some theoretical concepts. Maybe when we, if you enable Fabric premium license, then I think you should be able to explore this settings. Okay, and look at this endpoint. But I can tell you how the format of this endpoint looks like and what is this XMLA endpoint is all about, and by default what is the permission level that it has, and then how we can control that as well. Okay, so what is this XMLA endpoint? So XMLA is nothing but an XML for analysis protocol which is required for communication between different client applications and the actual engine that manages your Power BI workspaces and semantic models. Okay, so workspaces use this, and these communications are through what are commonly called XMLA endpoints. Okay, so XML for analysis. So client tool, be it the SSMS, SQL Server Management Studio, like how you can connect to Azure analysis services, right? If you deploy, if you know about analysis services service, once you build the semantic model, you will deploy into that analytical engine, and then you can connect to that analysis server in SSMS and then control or look at different aspects of the semantic model database and stuff like that. So similarly, this XMLA endpoint will provide you a format like this at the bottom that you can see here, which you can connect to the engine itself, and then establish the connection, and then look at the database, which is the semantic model itself, and then further perform any change, or if you have the required role, right? The XML is the communication protocol that you need to understand, used by the Microsoft Analysis Services engine, which runs Power BI semantic modeling, governance, lifecycle, and data management. So data sent over the XMLA protocol is fully encrypted, and what you need to know is it is read-only by default. Okay, so if you need to enable it or make it read-writable, they need to switch the setting. Let me go back to the Microsoft documentation quickly. If you can just give me a minute. So I can share this link if you want to read a bit about how you can establish the connectivity to semantic models once you have the model ready with the XML endpoint. You can go through that, but what I wanted to show you is, if I just scroll down bottom, yeah, So how you can enable the XML read write, because by default, as I mentioned, it is going to be read only, so you can only read the data. Okay, but if you want to enable it, so as I mentioned, by default, premium capacity or premium per user semantic model workloads have XML endpoint setting enabled for read only. This means client applications can connect to the semantic model and it cannot perform any write operations, right? We need to enable the read write setting. So how we can enable it for premium capacity? You need to go to the admin portal, and then under capacity settings you can see Power BI premium capacity name, and then there is an option to toggle the XML endpoint to read write. But unfortunately we cannot see this setting. Maybe I can quickly show you that under admin portal, since we are in a trial account. I go to admin portal, under capacity settings, taking a bit of time. You can see here there is no premium capacity for us, so Power BI premium no, and we are having only the trial account, so we cannot do much about it. If you have a premium account, as I mentioned, you can see the setting to enable the XML read write as well. Okay, and if you have premium per user, again in the admin portal you can select the premium per user and then enable it. And how you can connect to the premium workspace? So let me quickly show you the format, right? So this is how the format looks like. Power BI api.powerbi.com version 1, then the tenant name and workspace name. Okay, so that's how the format looks like for the workspace connection. But if you need to connect to the semantic model, you need to provide the database name when you're trying to connect, let's say from SSMS tool, right? So that I can quickly show you as well. If you come down, so here you can see how we can get this URL, right? So in workspace settings, premium, there will be a tab called premium, and then you can go to workspace connection, and then you can copy the workspace, the URL, the XML endpoint. But unfortunately, if again with the trial account you cannot look at that. If I go to the workspace and settings, you cannot see that, yeah, I think it's under workspace settings. There will be a separate tab called premium, which we cannot see now at this point in time. Okay, so don't worry about it, but theoretically you need to know what is XML endpoint and how by default from exam point of view you need to know it is read only, and how we can enable read write for that, and what are the different settings in Fabric you need to know, right? All right, so once you copy the workspace connection, then let's say if you're trying to establish the connection from SQL Server Profiler or beat the SSMS tool, you need to provide that under server name. You need to provide this copied workspace connection, and then you need to point to the database, which is the semantic model itself. Okay, so that's how you can establish the connection itself, and then the XML endpoint is all about. So let's go back to the presentation. So that's exactly I wanted to let you know about XML endpoint for semantic model connectivity from different client applications, like be it SQL Server Management Studio or any other tool of your choice. Okay, and how you can enable the read write from the Fabric admin portal if you have premium license, and then how you need to copy the workspace connection and then establish the connection with the semantic model name itself. So you can see the format I have mentioned here again. So it is Power BI api.powerbi.com version 1, then your tenant name / your workspace name. All right, so with respect to Power BI files, how you can create reusable assets from Power BI, like the template files. So those things I think we will look at it later in the course when we build some reports out of Power BI. We can look at it. Okay, so that being said, we will wrap up the video, and thank you so much for watching. So just a quick summary. So in this video we looked at how you can manage the analytics development lifecycle end-to-end in Fabric, and we looked at the deployment pipelines, how you can create different stages and then link the workspaces across different stages and then deploy across stages when you make some changes to the components in Fabric. And then we looked at the Git integration. Okay, so we looked at how you can link the Azure DevOps and then version control, establish version control for your workspace itself, and how we can push the changes to the repositories, and then you can create branches and stuff like that. We quickly looked at Azure DevOps integration as well in Fabric. That which is very important, you need to know from exam point of view as well. And then we looked at the XML endpoints, why you need to know the XML endpoint and how we can establish the connection to the semantic model, and what is the default setting and how we can enable read write. And as I said, it's restricted to premium license, and unfortunately we cannot do a demo on that this video, but later point in time, in case if we enable premium, I can show you that in a different video. So thanks so much for watching, and please subscribe so that you'll be notified on any future videos that I'll be posting in this course. And I hope this video helps you to understand the lifecycle, the development lifecycle, how you can manage it. And if you have any questions or comments or feedback, feel free to post in this video or the Google Classroom community. Happy to answer those or take in any feedback as well. Thank you. See you in the next one. Thank you. Hi everyone, welcome back to the channel, and welcome back to the brand new course on DP-600 Microsoft Fabric with real world project. And if you're new to this channel, please consider subscribing. And we are planning a 10-part video series, and this is video number 4. And if you're new to the course, please consider watching the other 3 videos as a part of module 1, where we talked about the introduction and code structure. And in the video 2, I talked in detail about how you can plan the data analytics environment when you're setting up one. And in video 3, I talked about the analytics development lifecycle, how we can set up the Git in Fabric, how we can integrate the Azure DevOps and stuff like that. So watch those and prepare yourself for DP-600. So let's talk about what we are going to cover in this video. So this is the first video in module 2. So to prepare and serve your data, which is the major proportion for your DP-600 exam, I would say. 40 to 45% of the questions you can expect in this module. So most of the questions will be around preparing and serving your data. So we are starting our module 2. So let's dive into this video. And in this video, we will be looking at the data ingestion into a lakehouse or warehouse. We'll also talk about shortcuts and why we need shortcuts in Fabric, and what is this capability that Microsoft introduced in Fabric. So let's get started with this video. So quickly look at the roadmap. So we planned a 10-part video series, as I mentioned, and we have a Google Classroom community. I will quickly take you through so that you can consider subscribing to the Classroom community, so that you can follow along through this course, and then whatever artifacts or resources that I'll be creating throughout the course, you can access in the Google Classroom community itself. So as I already mentioned, first 3 videos we focused on the course Fabric introduction, and then the COVID-19 dataset that we will be using for our project or the course. We looked at the overview of the COVID-19 dataset. And the video 2, we looked at how we can plan, implement, and manage a data analytics environment in detail. Video 3, as I mentioned, we looked at how we can manage your analytics development lifecycle. So in this video, we will quickly look at the data ingestion methods into a lakehouse or warehouse, and some of the capabilities like the shortcuts in one lake, then the fast copy in the Dataflows Gen2. So those are some of the capabilities in Fabric that we can look at as well. So let's dive in. And before that, let me quickly take you through the Google Classroom community. So here we are in the Google Classroom community that I've created. So you can look at the resources. So whenever I share any resources under DP-600 course materials, you can see the ECDC COVID-19 public dataset links. And then the official study guide links are posted there. And then whenever a new video is out, you will get a notification as well from this Google Classroom community as well. And also I have posted how you can set up the free Fabric trial account without having a business email address itself. So you need to create your Azure subscription, and then you can create user and then activate it. So I haven't created a video around that, but I've shared one of the co-creators video link in the classroom community so that you can benefit out of and set up the Fabric trial account and get some hands-on throughout the course. Okay, let's go back to the presentation. So let's dive into this video and see what are all the different data ingestion methods that you can use based on your workloads. Okay, so I just wanted to quickly show you a comparison matrix based on different features that will give you a bit of idea based on different parameters or factors. You can consider which ingestion methods are suitable for your workloads. So it's not a single rule, so you need to assess your workloads and then you have to decide which ingestion method is suitable for you, and we'll talk about shortcuts as well shortly. So there are different ways you can ingest your data into the Fabric environment, right? So we have Dataflows Gen2, we talked about it a bit in the previous videos, and we have Spark notebooks, and we have pipelines, the ADF capability, right? So Azure Data Factory pipeline capability. Then if it's a very simple data set, a direct upload is also possible. I've just listed that as well here. So with respect to the ease of use, so Dataflows Gen2, obviously, if in your team, it depends on the skill set. So if it's no code drag and drop UI, so if you don't have the required skill sets to code in PySpark or SQL, then I think Dataflows Gen2 is an option, but still from performance standpoint and the workload standpoint, you need to assess those factors as well. So there are a lot of factors in combination you need to assess, and then you need to decide which data ingestion method is suitable for your workload. Okay, so if it's structured, semi-structured data, you can go for Spark, or it doesn't matter, Dataflows Gen2 or pipelines, even pipelines as well. But if you're opting for Spark notebooks for the data ingestion, you need to have that skill set to be able to code the PySpark stuff and SQL stuff there. Okay? And pipelines, it's visual and some configuration is required. So that's about ease of use. Data types, we have looked at it. And with respect to performance, so Dataflows Gen2, it's medium for moderate data. And Spark notebooks, as you're already aware, mostly it's very high for large data sets. So if you're having data that needs to be ingested at massive scale, so Spark notebook is always a better option, right? So go for it. And data pipelines we can use for it for complex workflows. Still, data pipelines can support large data sets, and so you have to decide which data ingestion method you need to go for it. Okay. Direct uploads, it's very files, some files, Excel or CSV files with some small data, you can directly upload it, but you don't need to go for other ingestion methods. Okay. And transformation with Dataflows Gen2, you can use it's basic to moderate. You can transform your data, but if there are advanced transformations, as I spoke about it already with COVID-19 dataset, if we need to look at the rolling averages or cumulative cases, COVID cases, or cumulative deaths for every region across the world, then those kind of advanced feature engineering transformations require Spark notebooks. So later on in the course, we will be using the Spark notebook for the transformation purposes. So we'll not be using Dataflows Gen2, but for ingestion methods, to provide a quick demo, we can look at the Dataflows Gen2 and pipelines and all. But as a part of the course, the intention is to provide you with hands-on as much as I can, so that you can follow along through the course and then get some hands-on and make yourself confident for the DP-600 exam. Okay, so that's the idea. And pipelines, customizable in workflows, you can go with pipelines as well for transformation. But if it's complex transformations are required, go for Spark notebooks. It's an ideal method to go ahead. And with respect to automation, yeah, you can support Dataflows Gen2 support scheduling, and Spark notebooks not directly you can schedule, but you can schedule it via pipelines. and pipelines. All of those ingestion methods supports the scheduling capabilities that we'll be quickly looking at. And scalability, Dataflows Gen2, not much, scales to some extent, but Spark notebooks, always you can scale for very large and complex data as well. And pipelines are also highly scalable, so you can think about that as well when you are designing your solution. So that's at a very high level, based on different factors, deciding factors, you can say, data types, performance, transformation, which data ingestion method you need to opt based on your workloads, right? And if it's from enterprise point of view, if the data set is massive or at large scale, always probably you can think about using Spark notebooks for massive transformations. Or if it's of medium complexity, then you can think about pipelines or Dataflows Gen2. Also, as I mentioned, depends on the skill set that you have. So you can look out for Dataflows Gen2 as well. Okay, but assess your workloads and then decide which data ingestion methods are suitable for your workloads accordingly. Okay, so let's move on. So we'll try to get some hands-on as much as we can. So just at a high level, I'm showing you the comparison matrix based on different factors. Let's move on. So we'll quickly, what we're trying to do is we will quickly look at the Fabric portal and then we can do some hands-on. So we'll look at the COVID-19 dataset overview and then we can try and see the ingestion part using Dataflows Gen2 or manual uploads. So how we can manually upload the file, it's as simple as that. And just for demonstration purposes, I'll show you the Dataflows Gen2 as well, how we can use that Power Query experience to do the transformations or kind of eliminate some of the columns and then load it into a lakehouse. So maybe we can quickly look at that and then we can proceed with the other capabilities. So let me jump on to the Fabric portal. So here we are in the DP-600 codes workspace. So and by now I hope all of you are aware a bit about what the workspaces or different components in Fabric like workspaces, and you can see in the previous video we set up a Git integration and you can see the source control button there with 3 changes are yet to be committed, and we set up a deployment pipeline with different stages as well in the previous video when we talked about how we can manage the analytics development lifecycle. Okay. So let's move on to, I've already created a Dataflow Gen2 that you can see here, df underscore COVID-19 cases. Let's move on. So I'll quickly show you what I try to do in some of the basic operations like eliminating some of the redundant columns, renaming columns, and stuff like that. So you can get familiar with the UI itself. So this is the Power Query experience, right, that I mentioned in a Dataflow. So you can look at the query settings on the right, click on that. So you can hide this as well. So you can see here there are different steps applied to this data, right? So right from how I pull the data from the source. So you can click on the settings next to source. So I actually pull the data from the storage account from my Azure subscription. Okay, so that's the source that I brought in the data. Okay, so one of the Azure blob. And then you can see what are all the steps that are applied, right? So kind of you can see the navigation step. Okay, so what is that CSV file that I brought in from the Azure blob storage? You can see the folder path as well. So that storage account URL there. And then of the steps that we have done, I'm not getting into each and every step, but just give you a bit of flavor on what I tried. So some of the columns that we renamed. Okay, so let me quickly show you. So the actual data set, if you are aware, just to quickly show you, has a lot of columns like the continent information, countries and territories, country territory code, date underscore rep, which is the reporting date. Okay, the case reporting date, then deaths, GOID, And these are the attributes. If you're new to this video, these are the attributes for the COVID-19 dataset that we are going to play around, right? So if I come back here, so let me get into the final. Some of the columns I removed. You can see here some of the steps that we applied, removed the columns, renamed. Not major operations, as I mentioned. So you can click on the last step and you can see the data, the source name. So data_rep has been renamed to reporting date. Very basic operations that I've done just to show you how the UI looks like and the Power Query experience, right? So whenever you perform some operations, you can always see the step being applied here on the right side, right? So reporting date, then the split day, month and year, cases reported, deaths reported, countries and territories, GOID, country, territory code, continent, ISO country. So some of the columns, like the redundant columns, like the data that has been loaded, the load date, and the reporting date has been duplicated there, so I've removed that. Okay, so you can see here the load date was there that I've removed. Okay, and then you can see date rep. Let's look at the preview so that you'll get an idea. So you can see the load date which I have removed already, and those are the basic operations that I've done. And then the final data set you can see is here once we have performed those basic operations to rename the columns and remove some of the columns. And then what we are trying to do is we are trying to ingest this minimally transformed data into a lakehouse. So on the right side you can see the data destination. Once from the source, after applying all of those steps to remove some of the columns and rename the columns, you can load it into a data lakehouse or warehouse. So here you can see I've already mapped to a lakehouse, so you can connect to the data destination like this. The connection is already there. If you want to edit the connection, you can look at it. So there is a new connection with the authentication kind, organizational account. Okay, and pretty much simple. Okay, so you can do it, and you can see the settings for the connected lakehouse. So when you hover over there, so the workspace is DP-600 codes, the lakehouse is COVID lakehouse that we have, and then the staging table as well. So where you need to load the data and what should be the table name. So I named it as COVID_staging, and the update method is replace. And the column mapping, when you try to do the configuration for the data destination, it will automatically map and allow for the schema change as well. Let's go back to the COVID lakehouse. Okay, so it will ask you to close the data flow before you navigate away, and whenever you make some changes, it will be auto saved as well. Okay, so you no need to worry about saving your changes. As and when you perform any changes to your data set, it will be auto saved itself. Okay, so let me close this Dataflows Gen2. Let's come back to the COVID lakehouse. We open the lakehouse. So, and I think before we get into it, let me show you the refresh history for that Dataflows Gen2. So I'm here in the workspace. You can see the Dataflow COVID-19 cases here. You can always look at the refresh history. So when we published the Dataflows Gen2 and then we ran it. So today I've already executed this job, and you can see the status is succeeded, and very minimal data set, right? So it just got executed within a few seconds. Okay, let me close that. Back to the COVID lakehouse. So you can see the COVID staging table is loaded already. Okay, so I will talk about the other partition tables and all, but the COVID_staging is the table that we have loaded after minimal transformations using the Dataflows Gen2. Okay, so you can see here the source name, reporting date that we have renamed from date_rep to reporting date, and day, month and year. These are all there, but some of the columns we removed as well that are not there. So okay, so we looked at how we can ingest the COVID-19 data from Azure Data Lake Gen 2 to the data lakehouse using Dataflows Gen2 experience. So we'll also look at how you can manually upload the file. I've done that, so just to quickly show you. And we will talk a bit about shortcuts now. So before we get into shortcuts, let me jump over to the Fabric portal. And let me click on the lakehouse, COVID lakehouse. And you can see here ECDC underscore cases. So that's a direct upload. So if you have the CSV file, you can directly go ahead and upload the data. Okay, so you can see under the files, so under the tables, you can, let me minimize that. Under files, so I have uploaded this ECDC cases.csv file, and what you have to do is you need to create a delta table. You just click on these three dots and load to tables and then create a new table. That's it. That will create a table for you as well. Okay, so that's how we created this ECDC cases data table. So here you can see there are no transformations, nothing. So the data has been loaded directly from the file, okay, as a delta table. So all the delta tables in Lakehouse, you can see there is an icon, delta icon. So that depicts your table is a delta table with the storage is in the Parquet format. So I hope most of you are already aware about the Parquet format. I'm not going to get into in detail about what this Parquet format is all about. It's all about the columnar storage format, so which is very much efficient for analytical workloads. So you can read a bit about it. So I'm not going to get into the actual storage format itself, but you can see there is a icon for you to recognize whether the table is a delta table or not. Okay, so that's a direct upload, and you can see the file has been loaded as is with the continent information, load date, ISO country, and you can see the data, the table redundant columns as well, like date rep is again repeated, right? So we have date underscore rep and we have date rep also there with the load date. And if you have seen the COVID staging that we have just done, after removing some of the unwanted columns or redundant columns and then renaming the columns in the Dataflows Gen2 experience, we have loaded into the staging table, okay, through Dataflows Gen2. And there we have the source name column and the renamed reporting date columns, and some of the redundant columns has been removed as well. Okay, so just wanted to show you the difference. Okay, so how you can upload the file directly if the file is already structured and you want to directly upload, you can do it so. But if you need to handle a lot of transformations or you need to do some cleaning for your data set, go ahead with Dataflows Gen2 and do the required cleaning, and then you can load it into the lakehouse, like how we have done this just now. Okay, so let me come back to the presentation. So let's talk a bit about shortcuts. Okay, so what is shortcut? So shortcut is nothing but an object in one lake, so that point to the other storage locations. Okay, so Microsoft is trying to unify your entire data across domains or clouds, be it or accounts. So they wanted to provide you with a single virtual data lake for your entire enterprise. So you don't want to duplicate or copy the data from the other region or other source to your Fabric workspace. That will also cost you when you try to move the data around, right? So Microsoft is trying to provide this capability called shortcut, wherein you can point to the exact source itself, like, be it Amazon buckets or Azure Data Lake Gen2, or even internally in the one lake, you can point to different lake houses as well. No need to copy the data around, right? So that's the idea. So shortcuts are objects in one lake that point to other storage locations. The location can be external or internal to one lake. The location that a shortcut points to is known as the target path of the shortcut. Okay, so as I mentioned, shortcuts in Microsoft One Lake allow you to unify your data across domains, clouds, and accounts by creating a single virtual data lake for your entire enterprise. So maybe I can quickly jump over and show you how you can do it internally, or what are the options we have. Okay, Let me jump over to the Fabric portal. So here we are in the COVID lakehouse already. So maybe you can navigate to the workspace and you can see what are all the opened items already, the pipelines, lakehouse. So you can directly navigate to the lakehouse by clicking the lakehouse, COVID lakehouse. Here you can see, maybe let me remove this, okay, which I'll show you. Delete this. So just for demonstration purposes, let's try and see if we can create a shortcut from other lakehouse, okay, or we'll see the option. So right click on the schema. So right now we have only one schema, DBO. Even you can create different schemas as well, okay. So Microsoft is providing that capability here to create different schemas as well. So under DBO schema, right click on 3 dots and you can see there is an option called new table shortcut. Click on that. So that will take you to this window. So wherein you can see there are internal sources from Microsoft OneLake Fabric. You can create a shortcut and point to that data source, or there are a lot of external sources. You can see you can create a shortcut pointing to Amazon S3 compatible, and even Azure Data Lake ADLS Gen 2 as well, and Google Cloud Storage and Dataverse as well. But we're not going to look into the external data sources at the moment, but just keep in mind this capability is so nice that you no need to bring your data from external data sources. All you need to do is make the connection to the external data store, and then create that shortcut, and the data will still be there in the underlying source. You're not moving the data around. All you're doing is just creating that connection string and then just pointing to the target location to bring the data around, okay. That's the idea, but for demonstration purposes, let's try and see if we can create one shortcut internally. So when I click on internal data source OneLake, you can see all of the existing lake houses, like the COVID lake house that we are currently in. There are different sample lake houses that I've created for playing around, okay, in this trial account. So just for demonstration purposes, let's say we have a sample lake house here, okay. So let me click on that and we will see if we can try to create a shortcut pointing to this lake house, okay. So once I click that, under sample lake house, you can see the files folder and tables folder. There are some tables like flights partition, not partition, then flights partition daily, okay. So let me click on, let's say, flights partition table. It will show you all of the Parquet files, which is partitioned by the year, as you can see here. Click on that, you can see even it's partitioned by year and month, and the Parquet files there you can see for this flights partitioned table. So let's try and create a shortcut to this table under this sample lakehouse and see how that works. Click on next. So it says the shortcut location is, okay, COVID lakehouse tables DBO. So that's where the shortcut will be created under this lakehouse, and the source, you can see it's sample lakehouse. This is internal to OneLake, so it's not an external source, just to show you how this shortcut capability is working internally in Fabric. So let's click on create. So there you go. So you can see a shortcut is created for us, and you can see there is a small, the icon is a bit different to what you are seeing with the existing lake tables, right? Delta tables. So here it is a delta table again from the other lake house, but it's a shortcut, so you can still see the data from within this lake house. It will try to pull the data for you from the other source, right? So you're not copying the data to this lake house and then creating a table. So it's just a connection that we are establishing to connect to that particular source and then pull the data. So there is an icon that you can see which says that this is a shortcut pointing to a different data source, be it external or internal. So the data preview is taking a bit of time. Yeah, there we go. We are seeing this data. So from the external, not external, internal to the one lake, but a different lake house that we're bringing data and then creating the shortcut. It doesn't make sense here to create the shortcut, but just to show you how you can utilize this capability to unify your data across your enterprise, to avoid the data movement and then just point to the external sources and then bring the data and then unify your data and then do the analytics. Okay, so that's the idea. So let me delete this as we move along. So let me come back to the presentation again. So we quickly looked at the Dataflows Gen2 experience, the Power Query experience, and then we looked at the manual upload capability, and then the shortcuts and how you can unify your data across domains or even clouds. So you can pull the data from Amazon or Google Cloud storage accounts as well, and then the data resides there, and all you're trying to do is just pointing it to the location. Okay, so it's just the reference that you're providing as a shortcut. It will try to pull the data for you into your lake house or data warehouse. Okay, so that's the idea with respect to shortcuts. And we'll quickly look at how you can implement file partitioning for your workloads in lakehouse. So for this, let me jump over to the portal again. So to demonstrate this capability, how you can create a table and then also partition your table accordingly, right? So I've created a pipeline. Okay, so a COVID pipeline. So you can come to the workspace and you can create whatever new items you wanted to create. Okay, click on new item and you can see data pipeline, Dataflow, Dataflows Gen2 experience that we have just seen, many other items that you can create from within this workspace. Okay, so I've already created a very simple pipeline, COVID pipeline. Okay, and a copy data. Okay, copy data activity is there. Let me just walk you through what we're trying to do here to demonstrate how the data partitioning can happen and how we can enable that setting in case if you are using the pipeline capability and copy data activity to perform the data ingestion for your workloads. So here in the source, so I tried to pull the sample data. Okay, so the connection you can see here, it is the European Center for Disease Prevention. It is the COVID data only. You can do the preview of the data. Okay, so and if you want to create a new pipeline, maybe just let me show you quickly. On new item, data pipeline, and maybe let's name it as test. Create. So it will ask you with, if you want to start with a blank canvas, you can go for it, or with guidance you can do the, you can go ahead with the copy data assistant or practice with sample data and templates. So if you look at templates, there are a lot of templates around. You can see if it fits your workloads. You can always use that template as well. We come back to the close this pipeline test. So COVID pipeline, the source, it's a sample data that I've used for the COVID-19 dataset. You can always preview the data. Click on preview. It's taking a bit of time. Let's wait for a moment. So there you go. It's a sample data set, as I mentioned. So the ECDC COVID-19 cases that we are planning to use throughout this course. If you go to the destination, that's where I wanted to show you how you can do the partitioning using the data pipeline capability, right? So here the connection is there. We are going to load it to the lake house. Okay, and in the root folder is tables or files, chosen the tables. And the table you can see, we are going to load into the COVID_staging_partition. Yeah, yeah. So that's the table we are going to load, and click on advanced. So the table action should be overwrite. You can see we have enabled the partitions when the table action is overwrite, and you can also list the partitioning columns as well. Okay, so here we have ensured the partitioning should be done based on the countries and territories. So I wanted to partition the data based on every country at the top level, and then the second level you can give as many partitioning columns as you want, how you want the data to be structured when in the underlying storage. So after countries and territories, the second partitioning column I've given as year, and then I've executed this pipeline. We can look at the run history. The COVID pipeline has already succeeded. So let's not rerun this. I just wanted to show you how the partitioning works, the capability that you can utilize using the copy data activity in the data pipeline. So let me go back to the COVID lakehouse. So as we have seen, the table got loaded, this DBO COVID staging partition with the partitioning columns as countries and territories and year. Okay, let me go back to the COVID lakehouse. Click on COVID lakehouse. Here you can see the COVID staging partition table. Click on that. So it's the sample data that we have loaded as is without any cleaning or the transformations, right? So it's loaded as is. But what we can see here is, click on these three dots to see whether the data is now partitioned or not. So I think the COVID staging table that we have loaded with the Dataflows Gen2 experience. Let's have a look at that. Click on the three dots and click view files. So here you can see the files itself, right? So the delta log files, if you get into the delta log, the log files are there, and then go back, you can see the Parquet files are not, it's not partitioned at all, right? So when we loaded the data from the Gen2, data lake Gen2, and then we did some transformations using the Power Query experience, and then we loaded, but it's not partitioned at all, as you can see. Let's look at the files that we have just loaded into this COVID staging partition table and see how the structure looks like. Click on view files, click on this table, COVID staging partition, click on view files. So there you go. So you can see the data is now partitioned in this table. Okay, so you can see we have given a couple of partitioning columns. First one being the countries and territories. I wanted to partition the data based on every country, based on countries and territories column, and then if you can see it's partitioned based on every country, as you can see here. And then if you get into the respective country, you can also see the data is also partitioned based on the year. So the second partitioning column we have given as year. So under Afghanistan, you can see the data is loaded into 2019. There is a Parquet file loaded, and then in 2020 you can see there is a Parquet file loaded. So that's the idea, and I wanted to show you how you can partition the data files, right? So when you're using the data pipeline and copy data experience. So this is also possible when you're using Spark notebooks for your transformations and then finally loading the data into the lakehouse. Okay, that being said, you can also use Spark notebooks for your partitioning strategy. So when you do some basic transformations during data ingestion phase, and if you want to load the data into the lakehouse tables with the partitioning columns defined in your notebooks, so you have to plan it accordingly. And this is very important. And if you're working on a massive data set, or if you're trying to ingest a massive large data into the lakehouse, the partitioning strategy needs to be defined properly. So for example, here it is the COVID data, so I wanted to partition it based on the countries and territories, and I wanted to then partition it based on the country, year as well after country. So a couple of partitioning columns that we have defined here. We just looked at it, and then we have loaded the data into the lakehouse COVID stage partition. So it is very important for you to think about the partitioning strategy so that the further consumption or downstream operations would be much efficient when we try to pull the data out of this partition table. Okay, so that's about it. So let's go back to the presentation and we will see what else we need to talk about in this video. So we looked at shortcuts, we looked at how we can implement the file partitioning for workloads in Lakehouse using the data pipeline experience and copy data experience, copy data activity. Okay, let's talk a bit about this capability fast copy in Dataflows Gen2. What is this all about? And as a part of exam, we have this in study guide. So let me take you through a bit on what this capability is, and we'll quickly show you in the Dataflows Gen2 that we have already utilized to load the data, the COVID data as well. So fast copy, why we need this? So when you enable this setting in Dataflows Gen2, so Microsoft is providing this capability for you to ingest massive data at scale. If you need to ingest terabytes of data, so when you enable this setting fast copy in Dataflows Gen2, what it will do is in the backend, it will automatically switch to the data pipeline copy data activity. Okay, so it will enable that, and then it will try to utilize the backend copy data activity to do the job for you, and you no need to worry about the infrastructure behind. Microsoft will take care of that for you, but you need to enable the setting, and you need to know what this fast copy in Dataflows Gen2 if you are ingesting massive terabytes of data. There are some prerequisites. We will go through it, and only when it meets a specific threshold, it will try to switch the backend to a copy data activity in data pipeline. Otherwise, it will not. So we will have a look at it in action. So let me jump back to the portal. So I'll just give you a quick background, and then we'll look at in Fabric portal with the existing Dataflows Gen2 that we have used, whether the setting is already enabled and what was the engine that it was trying to use as well. So here I'm in Microsoft documentation for the fast copy in Dataflows Gen2. So when you need to ingest terabytes of data, right, with the easy experience of Dataflows, okay, when you need this capability, so with the scalable backend of the pipeline copy data activity, so all happens is when you enable this capability, Dataflows automatically switch the backend when the data size exceeds a particular threshold. We will see what that threshold is without needing to do any other configuration. Okay, so it will automatically do the job for you when you enable the setting. Okay, so let's look at the prerequisites first. So here you can see the file data, right? So the files are in CSV or Parquet format, at least 100 MB. Okay, if the file size is lesser than that, I don't think it will switch back to the copy data activity. The fast copy would be enabled. Only when the size is 100 MB or greater, I think it will automatically enable that for you and then do the required ingestion for you. Okay, so let's see how we can enable that setting in first place. Okay, so let's go back to the portal, Fabric portal. Here I think you can expand this. We are in the Dataflows Gen2 experience, the Dataflow COVID-19 cases Gen2 that we have just looked at in the earlier in the course with some basic operations we have done. Let me expand this ribbon, okay, and click on options, and you can see there are several options are there at the global level and the Dataflow level. Just scroll down under the Dataflow. The last option you can see there is a scale. So there you go. So I think by default it is enabled. So I haven't enabled this when I created the Dataflow Gen2. Allow use of fast copy connectors. So it's enabled for you. Okay, it is already enabled. And how we can check this, whether it utilize the fast copy connectors during the data ingestion for the simple data set that we have just loaded. So click on OK. and then maybe minimize this ribbon. And then I think on the applied steps, for every applied step, okay, let's go to the top. Okay, so here you can see, just navigate to the source applied step. Okay, so you can see here, this step is going to be evaluated with fast copy. It says it's going to be evaluated with fast copy, but whether it actually met that prerequisites and then it enabled it or not, that we have to see. But I think it says, since the option is enabled, all of the steps you can see, it says it's going to be evaluated with fast copy. Okay, or till the renaming columns, and then the everywhere you can see all of the steps we are seeing that. Okay, but let's look at the actual run that happened for this Dataflows Gen2. So let me go back to the workspace after closing this Dataflows Gen2. Close this. So here, DF COVID-19 cases. You can look at the refresh history. So let me click on this last refresh or the load that happened. So here you can see some of the information we can see here. Okay, and I'm just looking for, yeah, there you can see there is a warning, not applying fast copy for source below size threshold. There you go, because I think the file size that we're trying to load is around 5 MB, right? Not more than that. You can look at the file. Okay, so it's not from the file. I think we were loading from the sample data, or the file from the lake house, right? So let me go back to the, let me go back to the Dataflows Gen2. The source is the storage account, not the file directly. We kept the file in the storage account. So the source settings, it is the storage account that we pull the file from. So let me go back to the storage account quickly. Let me go back. So I think this is the storage account that we pull the data from. Okay, so let me go back to the storage account in Azure portal and look at the file size quickly. Okay, we have a container, COVID container, ECDC cases CSV file, and it is a very simple file which is close to 5 MB, right? So not more than that. So let me cancel that, Azure blobs, and then come back to the workspace. Okay, let me close this again. That's it. Come back to the workspace and then look at the refresh history. Click on the last execution, and you can see here the warning says it didn't apply the fast copy since the size is very limited or lesser than the threshold. So the threshold what we have seen is 100 MB. That's the threshold. I'm not sure if you can control that, but as per the Microsoft documentation, it is 100 MB. If your file or the data that you're going to ingest is more than that, or 100 MB, at least 100 MB, it will try to enable the fast copy for you, and then it will do the job for you. Okay, so but in our case, for the COVID-19 sample data set, even though we have enabled fast copy at the Dataflows Gen2 level, it didn't apply, and it throws a warning to us. It did not apply that due to the size threshold. So there you go. I think you can see the engine as copy activity when it's trying to use. Okay, so which we cannot unfortunately see at the moment as we are using a very simple data set, but you need to know you can enable that capability, and then if it meets the threshold, it will do the job for you, and it will be much faster, and you can even load terabytes of data with the Dataflows Gen2 experience. Okay. All right, so let me click on this activity, COVID write to data destination. There we can see the engine, I guess. Yeah, there you go. So under this COVID write to data destination activity, you can see the engine is dash. But from the Microsoft documentation, we have seen if it's trying to use the fast copy connector, the engine type would be copy activity. Okay, so check the fast copy indicators to see if your query can run with the fast copy. So the engine type shows copy activity. But in our case, we have seen the warning. It didn't try to use it due to the threshold, very limited data. So the engine, it did not use the fast copy connector. Okay, so you can see the warning here as well. Fast copy source size below threshold. Let's also quickly look at how we can schedule the data pipelines and data flows. So it's pretty straightforward. So let me jump back to the portal. Let me close this Dataflows Gen2 or the refresh history, sorry. And here, I think you can, if you want to schedule the data pipelines, it's pretty straightforward. And you can also use the data flows inside the data pipeline. So the data flow activity, you need to bring it in, and then you can execute if you want to execute the data flow from within the data pipelines. So we have the copy data activity that we demonstrated for the file partitioning capability. So here you can schedule your pipeline, and right now I think the schedule is turned off, and you can always schedule the run for your pipelines. Okay, and you can define the schedule as you want, as per your business case. You can schedule the pipelines, and even the data flows can be scheduled as well, and you can go through it. So it's pretty straightforward. Yeah. So let's come back to the presentation, and I think that's a wrap for this video. So let's quickly summarize what we have seen in this video. So we looked at shortcuts, what shortcut capabilities in Fabric, and how we can connect to external sources or even internal sources to your OneLake, and just define that connection to be able to pull the data into your workspace. And we looked at how we can use different data ingestion methods, be it Dataflows Gen2 with the fast copy connector. We talked a bit about fast copy connector, how we can enable it, what is the threshold limit that which is 100 MB. And we also looked at the use case for the COVID-19 sample data, which is 5 MB, and there was a warning says that since it doesn't meet the threshold limit, it did not, even though the fast copy is enabled, it did not utilize the connector. So that we have seen in action. We looked at some manual upload stuff as well. From the files, you can directly create the delta table directly after uploading the file in the file section in the lakehouse, in the COVID lakehouse that we have just created. And then we looked at the file partitioning capability. So in the data pipeline, so in the destination, when you try to load or ingest the data into your destination lakehouse, how you can partition the file when you're using the data pipeline itself. So that we have seen using the copy data activity in the data pipeline, and you can decide on how you want to partition the data accordingly based on your business use case. And then we looked at the fast copy. We talked about it in the Gen2, and then the scheduling part for data pipelines and data flows. And that's it for this video, and I hope this helps you to understand what are all the different data ingestion methods that you can use to bring the data into the Fabric environment or to your workspace, and then load it into your lakehouse or warehouse. And we looked at the sample data, COVID-19 data that we're going to utilize throughout this course, and how we can do the data ingestion into the lakehouse, and how we can utilize different capabilities in Fabric like the fast copy in Dataflows Gen2, or how we can partition the data when you are trying to ingest the data into the lakehouse. So if you have any questions, feel free to post in the comments or in the Google Classroom community, and I would be glad to help you further, and I'll see you in the next one. Please consider subscribing so that you will be notified with the future videos as well. Thank you so much for watching. Hi everyone, welcome back to the channel and welcome back to the brand new course on DP-600 Microsoft Fabric with Real World Project. And if you don't know me, this is Sheikh Mohammed, Azure Solutions Architect and Fabric Analytics Engineer. And we are in Module 2, preparing and serving data in this 10-part video series on Microsoft Fabric. And in this video, we'll dive deep into how you can transform data and implement star schema. So we'll quickly look at the roadmap for this course. So we are in video 5 and we already built few of the videos around module 1 where we implement, plan and manage your data analytics environment. And we also looked at managing the analytics development lifecycle and then the data ingestion methods into Lakehouse or Varos. So the core idea to build this course is to provide you with as much hands-on as possible with the real world data set. So we are building this course around COVID-19 dataset from ECDC. So if you haven't looked at the previous videos, I would encourage you to go through the previous videos to gain more understanding on Fabric concepts and basics, and then how you can plan your data analytics environment. So in this video, we'll be looking at how you can transform the data. So we'll be looking at the medallion architecture. We'll be talking about it shortly, how we can organize the data from bronze layer, the raw data, and then once you cleanse the data and then transform, you can store it in silver layer, and then you can take the curated data set to your final gold layer. So we'll talk about the medallion architecture, and then we will look at the basics about the star schema, and then the type 1, type 2 SCDs as well, and then we will get into the hands-on. So the video is going to be more extensive in the notebooks. So we'll be diving deep into the notebooks that we built to prepare the required dimensions and then transform the COVID-19 dataset and then load it into the gold layer in the medallion architecture. So we'll go through the concepts in the presentation, and then we'll jump back to the Fabric portal and then learn more about how you can implement the medallion architecture and then build the star schema with the fact and dimension tables for the COVID-19 dataset. And I will also help you to understand what is type 1 and type 2 SCDs and how you can handle the historical changes in your dimensions as well. So that's the idea in this video. And we will quickly look at the Google Classroom community as well. All the PySpark notebooks will be uploaded in the Google Classroom community. So you can download the files, and then you can play around if you are following along in this course. So let me jump back to the Google Classroom community. So here we have the community. So you can see all the resources that we'll be building in this course. The notebooks, PySpark notebooks, be it, or already you can see the ECDC COVID-19 public dataset. Links are uploaded in the course materials, and the official study guide links are also posted. So all the artifacts as a part of this course will be uploaded, and any new videos posted in the course will also be posted in the stream and will be notified. We looked at the Classroom community, so if you haven't joined the community yet, so feel free to join. And also this is going to be a lengthy video, so you can skip to different chapters to learn more about specific topics if you want. Okay, without further delay, let's jump back to the presentation. So to start with, we'll talk a bit about medallion architecture and data cleansing. So we will look at the notebooks, and then we will get as much as hands-on as I mentioned in the notebook with the COVID-19 dataset. But let's look at a few of the concepts so that you will gain an understanding on what medallion architecture is and how you can transform the data and then progress the data through different layers in the architecture as well, right? So we will look at how we can clean the data. So like handling null values, duplicate values, all those cleansing activities we'll be doing in the notebook shortly for the COVID-19 dataset. So with respect to the medallion lakehouse architecture, so there are 3 different layers, data layers you can call, which is bronze layer, silver layer, and gold layer. So essentially when you pull the data out of the data sources, so on the left side you can see be it files or databases or business apps or from sensors, IoT, and other streaming services. So the first layer would be the bronze layer, wherein you will store the raw data as is without any cleaning at all. So nothing. So as is, you're going to store the data in the bronze layer, data layer. And then once you start cleaning the data to handle null values or duplicate values or any new columns, the feature engineering part, if you're adding any new columns to the data set. So once all of the cleaning activities are done, then you can push your data to the next data layer, which is the silver layer, where you'll have the cleansed data in your silver data layer. So once the data is pushed into the silver data layer, so wherein you'll have the standardized data there, which is cleansed, then you will perform all of the required aggregations to push the data into the gold layer. So the data in the gold layer would be curated data, which is ready for further downstream and analytics workloads. So for the COVID-19 dataset, we will see this in action, how we are bringing the raw data as is into the bronze layer, and then what are the required cleansing activities that we need to do to push the data into the silver layer. And then once we aggregate the data at the daily level for the cases reported for every region at the country level, so that we will aggregate and then we will store the data which is ready for further analytical processes. So that's about medallion architecture. So once you have the data in the gold layer, then you will build the semantic models, data models, by performing the required joins from your fact table to the dimensions, establish the relationships, and then you can build the model and then deploy. So, and it's ready for further analysis using Power BI or Excel, the tool of your choice. So the idea or goal of medallion architecture that we're talking about here is to incrementally and progressively improve the structure and the quality of data as it progresses through each stage, be it bronze, which is our raw layer, you can call it as raw source, and the silver layer, which is the standardized or cleansed data in the silver layer, and then the final gold layer, which is the curated data, which is ready for further analytics for the downstream process. So that's how it's easy to also organize your data across different data layers and then store it in the lakehouse accordingly. So that we will see it in action shortly. So let's jump back to the Fabric portal. So here we are in Fabric portal. So I'm in DP-600 workspace, as you can see, and in the earlier videos we talked about building the deployment pipelines, which you can see here, the link deployment pipeline, and then the Git integration as well. Right now you can see there are some of the changes that we need to commit. So if you're new to this course and new to this workspace, so don't worry about it. So we are just starting, so you can look through the previous videos to get some understanding on the Git integration and the deployment pipelines in my previous videos. So for this video, so what I want to quickly show you is, this is the lineage view that we are seeing. So let me switch to the list view. So we will quickly look at a couple of notebooks which I wanted to show you. Or let's go back to the lineage view. So let's go back to the lakehouse, the COVID lakehouse that we have. Let me click on the lakehouse and open the lakehouse. So I have the notebooks already in place. So as a part of this video, I will walk you through the notebooks to build the dimensions and then how I built the medallion architecture here. So you can see I have the lakehouse table COVID bronze raw data, then COVID silver transform data, and then the gold layer, which is COVID gold aggregated KPIs. And then a couple of dimensions we will talk about. The date dimension and then the location dimension. So let me navigate quickly to the notebooks. So we have this dim generation notebook, PySpark notebook. Let me open that notebook. So you can see the notebook, PySpark notebook, is attached to the lakehouse already. One item is added. You can see it is attached to the COVID lakehouse. So you can just minimize this. So what I'm trying to do here is For the data model purposes, for the dataset, COVID dataset that we are looking at here, so I'm building a couple of dimensions, the date dimension and then the location dimension. Okay, so just to quickly show you the raw data from the COVID lakehouse, how the data structure is, if you haven't looked at the dataset before. So let me show you the COVID bronze raw data, which we are going to load in the notebook shortly. So the dataset is quite simple. So we have the reporting date, and then the cases reported, and the deaths reported across the countries, and then the GeoID, you can see the country and territory information, and the continent information will be there, and then the load date. So a very simple data set, a real-time data set for the purpose of this course. So let me go back to the DIM generation. The idea here is, so we'll be transforming the data into the gold layer with the required dimensions. So we'll be building a couple of dimensions, which is the date dimension and then the location dimension. So those are the couple of dimensions that we will be building, and then we will be looking at the notebook to see how we can clean the data, and then how we can transform and load it to the gold layer as well. Okay, so let me go back to the DIM generation notebook. So let me walk you through a couple of notebooks. So the DIM date, as you can see, so I have the script. So don't worry, I'll be sharing the notebook in the Google Classroom community so that you can follow along with this course. You can download and follow along with this course. The idea here is we are building the date dimension from the scratch. Okay, so I'm giving the date range, start and end date, so you can modify as you want. So here it is from 2020 to 2024 December, and then we are creating a list of dates, okay, in a data frame, and then we are creating a Spark data frame out of this list, okay, df dates, and then we are generating the DIM date, okay, with the required columns. So here you can see we are extracting the year, quarter, month, day of the week, week of year, and then the day name as well. Okay, so once I run the script, so you can see this is how it looks like with the date, then the date key, and then the year, quarter, month, day of week, week of year, and day name. So this script will generate the date dimension for you within the specified range that you're providing here. Okay, so the dimension is already created, but let me walk you through so that you can run through the script if you're following along, and then let me know if you have any questions. Okay, so what we are doing is, once we have the data frame dim.date, so we are writing the dimension into the lakehouse. So dim date write.format delta, and then the mode is overwrite, and then we are saving it to the tables in the lakehouse as dim date. Okay, so expand the lakehouse. You can see the COVID lakehouse. So we have the dim date already generated. Okay, so you can want to look at the data, just navigate back to the lakehouse, click on the explorer, click on dim date, just to have a view. We're building this dimension from the scratch, so you can see the data is already loaded from the script from scratch. So I have the date key and the required attributes for the date dimension as well. Okay, that you can see there. And let's come back to the DIM generation notebook. So we have loaded the date dimension from the scratch, and then we will also scroll through, and then the DIM location. So we also need to generate the location dimension as well for the purpose of this demonstration, to load the gold layer for the COVID-19 dataset. And what we are trying to do here is, the idea here is to build the location dimension from the dataset itself. So as you know by now, we have the ECDC cases CSV file loaded in the files section, right? So we go back to the COVID lakehouse, and the explorer, you can minimize the tables under files. You can see we have already loaded this ECDC cases CSV file, which is around 5 MB. Okay, so The idea here is to generate the location dimension from the available dataset itself, which in our case it's ECDC cases.csv. So I'm using Spark read format. Okay, the CSV, the format is CSV, and the option we are saying the header is true. Then load the file into the data frame. Okay, and then we are what we are doing in the second line of code, we are selecting the distinct countries and regions. So df.select countries and territories, continent, and then the ISO country dot distinct, and then we are adding few more columns to the location dimension, which is the location key. It's going to be a monotonically increasing ID. Okay, and then we'll have the effective start date, end date, and the current flag. So the idea to add this effective start date, end date, and the current flag is to showcase the SCD type 2 dimension, which I'll come to it shortly. Okay, so I'll explain. We'll get to the concepts of what type 1 and type 2 in the presentation, and then we'll come back and look at this dimension and what are all the possibilities when there are historical changes in this location dimension as well. Okay, so for now, just keep in mind this dimension, we are building it as a SCD type 2 dimension. Okay, so we'll come back or revisit again this dimension shortly when we discuss about type 1 and type 2 slowly changing dimension SCDs. Okay, so here once I run the script, dim location data frame, you can see the countries and territories are loaded with the continent information, and then the ISO country location key, which is the monotonically increasing ID. We called a function called monotonically increasing ID, so you can see it keeps increasing with the data. Okay, and then the effective start date and end date, which we are providing here as a default date. Okay, so for now, and when there are changes to any of the entries, that's when we need to talk about SCD type 2, how we are going to preserve the historical changes in the dimension and then add a new entry with respect to SCD type 2, or if it's type 1, we'll be directly overwriting the data itself. So we will quickly look at the notebook that we are going to use to see how we can progressively transform the data right from bronze layer to the gold layer. So let me load this ECDC cases transform notebook. Let me load that to walk you through. Quickly walk you through this notebook. So we have this data frame. So you can see this is the user interface. Once you open the PySpark notebook, you can see you can connect to a standard session or high concurrency session. You have all the other options to run the notebook if you want to run all of the cells or specific cells. And whenever you make some changes in Fabric, it will be auto saved as well. And you can see which language you wanted to use in Spark, PySpark or Scala or Spark SQL, and also T-SQL if you want, right? So let's quickly run through the notebook to see how we are transforming, cleaning, and then storing the data in silver, and then finally moving the data into the gold layer. So DF bronze data frame, wherein we are reading the data, Spark read.format CSV. The option we are giving it as header true, and we are loading the file from the files ECDC cases.csv, just a 5 MB file. So we're just loading and then displaying this data frame. So you can see here it contains the date trip and other the daily cases and deaths across the countries in different parts of the world, right? And I think if from right within the result set, you can also see just scroll up, you can inspect the data for each and every column as well on the right side, if there are any missing data or how many unique values are present in the column and information like that. You can have a look. So let's run that. So once you click on run, right, so it will connect you to the standard session. It will be started in 4 seconds, as you can see, and then the cell would be running immediately. So you can see it's succeeded, so it's that quick. Okay, the next section, what we're trying to do is we are calling a function, we are importing a call function from PySpark SQL functions, and then we are trying to check for the duplicates, okay, if there are any duplicate records found. So all that we're trying to do on top of the data frame bronze, df bronze, and then we are grouping data based on date rep, countries, and then the continent, and then we are saying dot count dot filter, where the column of count is greater than 1, so that will give you if you have any duplicates. So that we're storing in duplicates data frame and checking if duplicates.count is greater than 0, then the duplicates record found for the following date country combinations, okay, else no duplicate records found. So let's run this. Okay, so there are no duplicate records in the dataset that we have from ECDC. It's clean. Okay, so then let's move on. So, and we're also looking at the count of this raw data that we downloaded from ECDC, which is around 61,900 records present. So let me scroll down. So what we are going to do now is we are going to store the raw data as is, as I mentioned, into the bronze layer as delta table. So the syntax here is the data frame that you built, df bronze dot write dot format delta, and then the mode is overwrite, and then we are trying to save it in the table section under the DBO schema as COVID bronze raw data, so which is already done. Okay, so I'm not going to run the script again. Okay, so once you run the script, you can see the raw data as is from the file will be stored as delta table in this table. Okay, so that you can see here. So let's scroll down. Okay, so in this script, what we're trying to do is we are trying to see if we have any null values as a part of data cleansing activity. So from the data frame bronze, we are getting a list of columns into the data frame with dot columns. Then we are trying to loop through each and every column to check for null values. So we are basically using a for loop for column and columns. And then the null count, what we're trying is we are using the filter function, dot filter function, okay, and df bronze, the incoming column, whether it is null, dot count, okay, and then we are trying to print, okay, that column has the count of null values. Okay, so but once we run the script, I think there are few null values in cases, 454 null values that we can see in the cases attribute. It's okay, and then we can see country territory code has 123 null values. And then this column, I think this is not required, the population data 2018, so which is completely null. As you can see, the count of the data set is 61,900 and everything is null, so we can get rid of this column as well from the data set shortly. So okay, I think we have already checked the duplicates, so the code is duplicated here, so which we can ignore. And as I mentioned, we can drop the pop data 2018 column and then we can store it in the df bronze cleaned data frame. Okay, so we can start cleaning some of the redundant columns, and then we can also handle the null values as we go forward. So we cleaned it, okay, so and then stored it in df bronze cleaned. And then in this script, what we're trying to do is we are trying to fill the null values with the there are a couple of few strategies that you can use to handle the null values, and what we're trying to here is we're going to replace the nulls in the cases that we have seen with zeros instead of null, and then we are trying to replace the nulls in the country territory code with the unknown. Okay, so instead of keeping it as null, we are going to keep it as overwrite it as unknown. Okay, so for that we are utilizing the fill na function in the data frame df bronze cleaned, and then we are passing the 0 to the cases attribute. So if it is null, it will be replaced with 0, and for country and territory code, if it's null, it will be replaced with unknown, right? And then we are again storing the data, clean data, back into the df bronze cleaned. Okay, so that's how we are doing it. Let me scroll down. and then we are running the same script that we just checked to loop through every column and see if there are null values as a part of validation. And you can see there are no null values present. Okay, so I'm not running each and every block of code here. It is already developed for you. You can download the notebook from the Google Classroom community, and you can try and execute and follow along as and when we progress through this course. Okay, so null values are handled and there are no duplicates as we checked. So and those are the couple of cleaning activities that we have done in this ECDC COVID-19 dataset. Then I think we can look at how we can transform the data and store the data in the next data layer, which is our silver layer, right? So what we're trying to do here is, so let's do some transformation with the data. So the idea here is we will also create some attributes or features to the existing dataset as well. We'll be performing some feature engineering as well. So to this dataset, so what I'm planning to do is we'll be calculating the cumulative cases and cumulative deaths as well. So for that, we'll need to specify the window to calculate the cumulative cases and deaths, and also we will calculate the 7-day moving average for the cases and deaths as well. So some of these attributes we'll be building in this notebook for analysis purposes once we build the data model as well. Okay, so here from PySpark SQL window, I'm importing the window function. Okay, and then I'm specifying the window specification. Window.partition by, I wanted to partition by countries and territories, and then .order by year, month, and day. So that's going to be the window specification. So we're just specifying the window spec to apply that window when we calculate the cumulative cases and deaths. Okay, and that is going to be partitioned by for every country, and then we are going to order it by year, month, and day for every country. That's how we are specifying the window partition. And in this script, what we're trying is, so we are importing the sum from PySpark SQL functions. We are importing sum. And then we are trying to calculate the cumulative cases. So we have the data, clean data and df bronze cleaned. Then we are creating a new attribute with dot with column function. We are calling it as cumulative cases. Okay, and then we are utilizing the sum operator, sum function, sum of cases dot over a specific window, right? So the window spec we have already defined here. It should be partitioned by countries and territories, and then order it by year, month, and day. So we are passing that window spec to calculate the cumulative cases for every country, and then order it by the time period, right? So that's why we're passing the window spec to the this particular calculation here. Okay, that we need to calculate the cumulative cases, and then we are storing it in df data frame df underscore silver. Okay, and then we are again calculating the cumulative deaths similarly, which is we are applying the sum function to calculate the sum of deaths over a specified window. Okay. So let's run this. So once we have executed this script, part of the script, so we'll have the data stored in the df silver with a couple of columns that we have created as a part of feature engineering. So to calculate the cumulative cases and deaths over a specified window that we have defined. So I'm using display function to see how the data looks like in the df silver, right? So here you can quickly see if the data is all right. So at the end of the data set, there you can see the cumulative cases column got created, and then the cumulative deaths got created. Okay, so you can just have a look at the data if it's created correctly. So let's scroll down, and also I think you can use some magic commands. I hope all of you are aware, and if you are new to magic commands, so if the notebook default setting is PySpark, even you can override that with a magic command to write, let's say want to write a SQL query, you can always use the magic command, and then you can write some queries in the PySpark notebook and look at the dataset as well. So for that, we are creating create or replace temp view COVID data, okay, from the data frame. Then you can use the magic command %SQL. Just to show you, you can write the SQL queries, then you can look at the data as well. Okay, let me scroll down. So I'm also checking the distinct of continent and countries and territories from the COVID data as a part of data lookup. That's fine. Just scroll down and let's look at so we looked at how we can store the data as is in the raw layer, and then the cleansed data will be stored in the silver layer, okay, as in the medallion architecture. And then we'll now look at how you can aggregate the data by time periods if you need to aggregate one, and then you can load the data finally in the gold curated layer as we talked about. So in this part of script, I think the data is already at the daily level, okay, so the ECDC cases data that we have downloaded. But I think just to demonstrate how you can do the aggregation in PySpark, maybe I can show you how we can aggregate the data by week as well as month as well, okay, so by different time periods. So here from PySpark SQL, we are importing functions, and then we are aliasing it as F. And what we're trying to do here is we have a daily ag data frame. So from silver data frame, we have the clean data already in the data frame silver, and then we are trying to group the data by date rep, year, month, day, and countries and territories, and then the continent, okay. And we are trying to aggregate, so we are using .add function, and then aliased functions f.sum of cases, we are aliasing it as total daily cases, and then the f.sum of deaths, we are aliasing it as total daily deaths, okay. So you can directly use the required functions from the data frame like .group by or .ag, and then you can start grouping your data and then store it in another data frame to proceed further. And if you need to aggregate the data by week, so we are trying to use a date trunc function here to truncate the date to the week start. How we are doing this? So we have silver.with column, we are creating a new column week, and then what we're trying to do is we are calling the date trunc function, okay, and then we are passing the first parameter as week, and then we are passing the column date rep to the function as well. So that will truncate the date to the week start, okay, and the data set, and then we are trying to group it based on the week and then the countries and territories, and then we are aggregating the data, okay. So we'll look at how the aggregation happens shortly, and then similarly you can also do the aggregation at the monthly level as well using the same date trunc function here, okay. And then all you need to do is pass the month as parameter to date trunc, and then the column that will truncate the date to the month start for you, okay. And then you can, so once you need to create a column. With column will create a column, week column, and then you are passing that week column to the group by function, okay. So once you run the script, and we are using show function to show the data, the aggregated data, just to quickly show you. So let me scroll a bit up. So here you can see the daily aggregated data, the date rep, year, month, day, countries and territories, the continent, and then the total daily cases and total daily deaths, okay. So that we are going to consider further. So we are going to build the data model at the daily granularity, okay. So we'll be picking this data set moving forward just to showcase how we can also aggregate at different time periods. You can see here at the weekly level, we have also aggregated the total weekly cases and total weekly deaths for every country, okay. And the third data set, we have also aggregated the data at the monthly level as well, that you can see the total monthly cases and total monthly deaths. All right, so let's move on. And I'm just looking at the daily data frame that we have just created and aggregated the data by day. I think the data is already aggregated at the daily level from the source, just to show you how you can perform the group by operation and then aggregate the data at the daily level or monthly or at the week level as well. Okay. So the daily aggregated count matches with the data source. So we have around 61,900 records, and I'm just checking the minimum and maximum date in the data frame that we're working on. So the initial data frame. So just to see the start and end time periods for the dataset that we're working on, the COVID-19 dataset. So we have data from 31st of December 2019 till December 14, 2020. Okay, so approximately 1 year of data we have the COVID-19 dataset that we are working on. Okay, as part of next step, what we are going to do is we'll calculate 7-day moving average for cases and deaths. So the reason why we are going to feature engineer these attributes in the dataset and then push it to the goal layer is to handle any noisy data, right? So the idea here is to smoothen the data. So we are going to specify the 7-day window, and then we are going to calculate the moving average. So consider or imagine there may be cases, that could be reporting delays, case reporting delays, or that could be holidays, and there could be spikes in cases and deaths for a particular day due to that. And to avoid or to smoothen those fluctuations, I think it's a good idea to calculate 7-day moving average for both cases and deaths, and then we can fit it into the dataset, and then we will load it into the code layer for further analysis when we build the data model. Okay, so that's the idea. So here in this script, what I'm trying to do is I'm importing window again to define the window specification. We are importing from PySpark.SQL import window, and then we are also importing SQL functions as well. So here I'm defining the window specification, window spec, window.partition by countries and territories. And then we are ordering it by date, reporting date. So I can provide this dot rows between and then passing -6,0 will calculate the 7-day moving average from the current day for me, right? So that's the idea. And then we are calculating the 7-day moving average. So we have this daily aggregated data frame, and then we are using with column 7-day average cases. And then we are calling the function alias f.average total daily cases from the daily data frame, and then we are passing the window dot over the window spec that is defined. And then we are storing the data in DF Silver, and then still we are using this DF Silver to feature engineer some of the columns, the cumulative cases, deaths, and then 7-day moving average as well. Okay, so let's look at this output. So you can see we have the 7-day average cases and 7-day average deaths added to the dataset. The daily aggregated dataset. So we have added 7-day. We calculated 7-day average cases and deaths, and I think the cumulative cases and deaths, I think we earlier added to a dataset already. Let me scroll up a bit. Okay, so I think once we aggregated the data by time periods, I think we are considering this daily dataset, and then we are going to calculate the cumulative cases and deaths on top of this daily aggregated data frame. Okay. So for the 7-day moving averages, we are calculating on top of daily aggregated data frame, and then we are storing in DF Silver. So you can see we have the 7-day average cases and deaths added to this data set, and then we are quickly specifying the window spec we talked about before to calculate the cumulative cases and deaths as well. Okay, so once we have those columns calculated, cumulative cases, cumulative deaths, and then the 7-day moving average cases and deaths, we are displaying this DF silver here. There you can see we have the reporting date in the split year, month, and day, countries and territories. We have the continent information. We have total daily cases, aggregated data, and then we have total daily deaths for each and every country at the daily level. And then we have the 7-day moving average cases, 7-day moving average deaths. Then we have cumulative cases and cumulative deaths as well. Okay, so here you have a look at the data. Let me close this. So you can see here, I think this is for just to eyeball the sample data for Afghanistan. You can see the total daily case for 25th of February is 1 case recorded. You can see there, and the 7-day average cases has been calculated, moving average, and then no deaths reported, and you can see the cumulative cases as and when we move on to different time periods. So you can see it is calculated correctly. So here we can see for Afghanistan country, on 8th of March there are 3 cases reported, and you can see the moving average has been calculated. Cumulative cases also has been calculated. So just to validate. So what we're trying to do now is we will try to store the cleaned and transformed data as a delta table in the silver layer. Okay, so we have the transform data. We did the null cleaning and we looked at the duplicates. There are no duplicates, and then we perform feature engineering to calculate the moving average, 7-day moving average for cases, deaths, as well as cumulative cases and deaths. So the transform data we are now ready to store it in a delta table as COVID silver transform data. Yeah, so that's the script to write as a delta format, and then we are saving it to tables, so which is already done. So that you can see the COVID silver transform data. Let me go back to the lake house, COVID lake house, just to show you. Click on tables, and you can just scroll down. Yeah, the silver transform data. Just give it a moment to load the preview for the transform data. So there you can see whatever cleaning activities that we have done, and then the transformed or couple of columns or feature engineered columns are added here or not. We can have a quick look. The reporting date, year, month, day, countries, continent information. You can see the total daily cases, 7-day average columns, and then the cumulative columns are added. So that's going to be our silver layer. Once we feature engineered and then the clean data, we are storing it in the silver data layer. Then we call it as silver transform data, COVID silver transform data. Yeah. Let me go back to the notebook, ECDC cases transformed notebook. And then we can also look at the count. So it's 61,900 records in the silver layer. So at this point in time, we have the raw source data loaded in the bronze table, and then we have performed some cleaning activities and then performed some feature engineering activities to calculate the 7-day moving average and cumulative cases, and then stored in the silver data layer as a delta table. And now what we'll try to do is we will load the data into the final fact table or the gold curated layer, right? So for that we looked at a couple of dimensions that we created. in a different notebook, the dim generation notebook. So we created the dim date from scratch, and then we created the location dimension from the available data set itself, right? So we need to perform the required joins from the silver layer, the transform data, and then we load the gold curated data. So let's look at how we can do that. So we show you the script. So again, we are importing the functions from PySpark SQL. What we are trying to do here is we are creating a df transform data frame, okay, and then I'm using spark.sql, and then I'm writing a query to pull all of the data from the COVID lakehouse from our silver data layer, which is COVID silver transform data, and then storing it in the data frame. Okay, and then what we're trying to do is we're going to perform a couple of joins based on the date reporting date. So we have this dim date. We are pulling the data from the date dimension, then we are storing it in dim date, and we are creating a fact table data frame, and then we are trying to join the transform data, okay, to the date dimension on the basis of the join columns are date reporting date from df transform, and then we are joining with the date key in the dim date, and we are performing an inner join, okay, and then we are also dropping the date rep column, which we don't want, and then storing it in fact table. Similarly, we are performing the location dimension join from the transformed, okay, the fact table, okay, so it is already stored in fact table, so we are picking up the fact table and then performing the join to the dim location based on the countries and territories on the transform data, and then the countries and territories on the location side as well. Okay. So I think we already looked at a couple of dimensions that we have created. Just to quickly show you the dim location that we created. So we have the countries and territories, the continent information, and ISO country location key, which is a monotonically increasing ID, and then we will shortly talk about the SED type 2. So we have the effective start date and end date. In case if there are any updates to the existing entries, we'll preserve the historical information. We have the flag as well, whether it is current or not, right? Let me go back to the notebook. So scroll to left. So we have performed those joins, and then what we are trying to do is we are selecting the required columns for the fact table. So from our dim date, we are pulling the date key. So because the idea here in fact table will be storing only the dimensional keys and then the metrics, or the KPIs, you can call it. So we have the date key, we have the location key, and then we are storing all of the required metrics like the total daily cases, total daily deaths, 7-day moving average cases, 7-day moving average deaths, then the cumulative cases and cumulative deaths. So those are the metrics we are going to look at and analyze when we build the semantic model or data model later on in the course. Okay, and we are also adding the load date, which is going to be the current date when we load the script, when we load the fact table. Okay, so we scroll down. Good. And finally, we are trying to store the built fact table. Selected columns will be returned. So one key thing here is when you write to the delta table, here I'm just trying to partition the data based on the location key as well, because when this fact table is being consumed by downstream processes, and when the data is partitioned, it will be much efficient to pull the query the data based on the location itself. We're trying to write to the delta table, and then we are partitioning it by location key. I will show you how the data is partitioned by looking at the file section. So we have used format delta, and then we are using mode override, and then we are saving it as gold COVID Gold aggregated KPIs. We name it as COVID Gold aggregated KPIs under tables DBO schema, right? So that's about it. So let's look at the Lakehouse back. So let's look at the Explorer here. Here you can see the gold aggregated KPIs data. Once we perform the required joins to the dimensions, we have loaded the data. So let's look at how the data looks in the gold layer. So you can see here we have the date key, we have the location key, which is the increasingly monotonical ID. So that's the location key, and then we have the daily cases, daily deaths, and then we have the 7-day moving average cases and deaths, and then the cumulative cases, cumulative deaths, and then the load date when we have loaded. We have seen so far, we have seen how we can progressively structure your data through different layers in medallion architecture, from bronze to silver, and then finally to your gold layer that is ready for further analytics, right? So we looked at how we can create a couple of dimensions for this use case for COVID-19 dataset, and how we have cleansed and then move the data around from a bronze layer to a silver layer, and then we perform the required joins, and then we loaded the KPIs or the metrics into the final gold layer as well. Okay, let's quickly look at if the data is partitioned correctly. The partition key we provided as location key. So when we wrote the final aggregated KPIs table into the gold layer, COVID gold aggregated KPIs. So let's click on these 3 dots, click on view files. There you can see the data is partitioned by location key. You can see for every location key there is a folder created, and if you click on specific folders, you can see the Parquet file stored inside that particular location key. So that's how we are partitioning the data files based on the location key. For each and every location, you can see there is a folder created and the data is partitioned accordingly. Okay, let's go back to the presentation. We will quickly look at the basics for SCD type 1 and type 2, and then we'll come back to the Fabric portal, and we will talk about the use case for type 2 SCD in our location dimension. Okay, so SCD type 1, so it is going to be a direct update. So you can see here when there is a change to any of the attributes in a particular record for any dimension. So here there is a change in the phone number for a particular salesperson. So you can see there is a direct update to the existing record without preserving any historical entries in the dimension itself. That is a direct update, and it is type 1. And the type 2 is whenever there is a change to any of the entries for a record in the dimension, we will preserve the historical data, and then we will create a new entry, and then we will also create the effective start date and end date to have the timeline specified there, and then the flags as well, whether is current flag, the historical record would be expired, and then a new entry would be created with the flag as true. So that's what is happening here in the image. You can see here for a salesperson, for 296 salesperson, there is a update in the sales region. So this salesperson's sales region got updated from 4 to 5, as you can see here. And what is happening is we are expiring the previous 296 record with the end date as 23/5/2024, and then the flag as false. Then a new record 369 with the SK 369, it is created and then inserted with a new start date. Okay, so that's how SCD type 2 dimension works. So if we go back to the portal, so let's open our location dimension in the COVID Lakehouse. So I think the ideal candidate to explain the SCD type 2 scenario here in location dimension would be, I think, the Czech Republic, right? So let me sort it by ascending, because there was a name change for the country Czech Republic to, I think, some other name. So let's look at that. I'll also provide the evidence for that. for you to understand. So you can see here, I think there is a name change. It is not Czech Republic. So they changed it to Czechia. Okay, so let me open this Wikipedia. You can see here, I think in 2016, they decided to change the name of the country from Czech Republic to this name. Yeah, how we want to pronounce it, Czechia, right? So that was approved, and in 2016 they changed the name. They endorsed the short name. Okay, so the political leaders endorsed it. So that's a great candidate to talk about ACD type 2 dimension, because you have an entry here, and the continent is Europe, and we have the ISO country code as CZ. Let me highlight it, it will be easy. And the location key is 19, and we have put a default or dummy start and end dates. Okay, so with the flag as true. So I think, imagine the entry was Czech Republic before 2016, and then in 2016 we had to expire that record, historical record, and then we created this new entry with the start date from 2016. Because I'm not going to demonstrate that, but imagine how the data looks like if there is a change to any of the entries in the dimension. So here it is the name change, the country name change itself. So we preserve the previous historical record, Czech Republic, with the start date as the initial date or any dummy date back in time, and then we expired that record during 2016, and then we created this new record with the changed name to Czechia, and then we added that with the true flag. The historical record would be expired with the current flag as false. So as simple as that, just to demonstrate how to handle those changes going forward. And then we built this dimension as ACD type 2 dimension. So you can see we have the effective start date, effective end date, and the current flag, right? So whenever there is a change to any of the attributes, we expire the historical record for reporting purposes. If I wanted to report back in time, let's say in 2015 or 2016, so those historical reporting would still report the previous name, Czech Republic. So we have loaded the location key in the fact table. In such a scenario, if we need to report the historical data, imagine back in time before 2016, then I think the previous name would be picked for reporting with a different location key that was generated, right? And for this entry, we have a different location key that is loaded into the fact table. So the reporting right from 2016 would refer to this record, and the reporting reflects the new name for this country. So as simple as that. I hope you understand that, the idea of ACD type 2 dimension, how we can preserve the historical information over time and perform the reporting if we need to report the historical data or the current period. Okay, let's talk a bit about the star schema basics. So we already built the fact table for COVID-19 dataset. We also built a couple of dimensions, location dimension and then the date dimension, and we performed the required joins to load the final goal layer table. Okay, so we looked at that in detail with the help of PySpark notebooks. Now let's look at the basics of star schema to better understand why we need one when we do further analysis. Okay, so star schema is a mature modeling approach widely adopted by relational data warehouses, right? It requires the data modelers to classify their model tables as either dimension or fact. And the reason why we name it as star schema is because the fact table forms the center of a star, and all the related dimension tables, as you can see, forms the points of the star, right? So that's the reason we call it as star schema, as you can see in the sample image here. Okay, and it is some of the benefits of star schema. If you ask me, it is very well optimized for analytical workloads and analytical queries, that you run on top of the data model is much efficient because of fewer joins that we are producing between the fact table and the required dimension tables, right? And we also create the required indexes in both the fact and dimension tables, which makes the analytical queries much efficient and faster, right? And also from maintenance point of view, star schema requires very low maintenance as the data warehouse or data lakehouse evolves when the design evolves, right? So very less maintenance with respect to there is no overhead, maintenance overhead. So that's the very basics what the star schema is, and then we already looked at building a couple of dimensions, and then we built the fact table. In the subsequent videos, when we design and build the semantic data models, we will see how we can establish the relationship, be it one-to-many. So mostly the relationship between the dimension to the fact would be one-to-many, right? So one from dimension side to the many on the fact side. Okay, and we will also look at shortly the bridge table, why we need a bridge table in case if we need to establish many relationships between the two entities. Okay, so why we need a bridge table in case of many to many relationships. But from star schema point of view, so I think it's predominantly one to many relationships between dimension to fact. Okay, and we will see this in action when we get to the design and building of semantic models shortly in the course. Okay, so that's, you need to know the star schema basics. Okay, so let's move on, and it's a prerequisite. It's considered as a prerequisite for enterprise Power BI semantic models. Before we build the semantic models, you need to have those fact and dimensions ready so that you can establish the relationships, and then you can build your data model optimized for further analytical workloads. Okay, so analytical queries are concerned with filtering, grouping, sorting, and then we'll summarize the data. So the fact data is summarized within the context of filters and groupings of the related dimension table. So whenever we filter any dimension, the filters propagate to the fact table to summarize the data and render the result for us from the data model. So we will see all of these in the semantic modeling section when we design and build, and then finally we get to the Power BI to produce some reports, and we'll apply some filters and see how the data is getting summarized. So from COVID-19 dataset use case, so we have few KPIs we talked about, like the 7-day moving average cases, deaths, then the cumulative cases and deaths. So I think we will be looking at the 7-day moving average trends, okay, the cases trends and deaths trends across different countries. So that's one good candidate. We can look at it when we get to the analysis, exploratory analysis part later on in the course. Okay, so let's move on. So let's talk a bit about bridge table that I just briefly mentioned. So just in case if you need to establish many to many relationships in your data model, so predominantly it would be, as I said, one to many, one in dimension table to many records, right, loaded into the fact table, right, for that particular dimension. There could be many entries in the fact table, so it's one to many relationship. But there are possibilities you need to design many to many relationships. How you can do that? So to avoid complexity, Microsoft is recommending to create a bridge table in between. So let's take a classic example here. Okay, so for this many to many scenario, so this classic scenario relates two entities, as you can see here in the diagram. So bank customers and bank accounts. So imagine that customers can have many accounts, right, and the accounts can have multiple customers. In this case, when an account has multiple customers, we call it as joint account holders, right? So that scenario, so both are possible. So this is a classic many to many scenario, and we need to establish the relationship between these two entities. How do we do that? That's when you need a bridge table to model the relationship between these two entities, account and customer. A third table, we call it as bridge table, is required to kind of uniquely identify the account and customer combination, right, association. So the purpose of this bridge table is to store one row for each customer and account association. So here we will store the account ID and customer ID only. Uniquely, it will store the information in the account customer bridge table, and we will call this bridge table as factless fact table, because we don't have facts stored in this table, but it still tries to relate these two dimensions, account and customer, right? So that's the idea of bridge table. I think keep in mind, if you need to model many-to-many relationships, you need a bridge table to design those relationships. Okay, so maybe we can, once we're done with this course, maybe I can create a new video to showcase or demonstrate how we can model these entities. But for now, as a part of this course, just keep in mind, if you need to model many-to-many relationships, you need to have a bridge table, and this is very important from exam point of view. You will have some questions related to bridge table, so this is part of the study guide itself. Okay, so I hope you understand the concept itself to design the many-to-many relationships. And thank you so much, and we are wrapping up this video. And just to quickly summarize, so this video, we are trying to transform the data. So initially we looked at how we can cleanse the data, and we looked at medallion architecture, right? So how you can store the raw data as is in bronze layer, then start cleaning your data, and the cleansed data in a standard form would be stored in the silver layer, and then you perform the required aggregation. So in our COVID case, the data is already aggregated at the daily level. If you want to perform aggregation at monthly or weekly level, you can do that. We have demonstrated that. So you can aggregate the data, and then the final perform the required joins to a couple of dimensions. So we created a couple of dimensions, one location dimension and then the date dimension. We have a separate notebook for that. So we perform the required joins, and then the final curated data we stored in the gold layer. So in the as a aggregated KPI table, we stored it. So we looked at that in detail in the PySpark notebook. So I'll be sharing those couple of notebooks, the DIM generation notebook as well as the ECDC COVID transform notebook we looked at in detail in this video. So both I'll be uploading in the Google Classroom community. So please join the community, and then you can download the required resources, the notebooks, directly from the Google Classroom community. Okay, and then we quickly looked at the SCD type 1 and type 2, and we looked at the use case in our COVID-19 dataset. We created the location dimension, so we looked at the use case in case of any changes, how we can preserve the historical data, and we looked at the star schema basics. Okay, and we also looked at the bridge table in case of many-to-many relationships. So I hope you enjoyed the video. So keep learning, and if you haven't watched my previous videos, I would encourage you to watch those in module 1, and subscribe. Consider subscribing so that you'll be notified with the rest of the videos in this course. So enjoy the learning, and thank you so much for watching. Hi everyone, welcome back to the channel, and welcome back to the brand new course on DP-600 Microsoft Fabric with real world project. And we are in module 2, preparing and serving data, and in this video we'll dive deep into the monitoring tools that you can look at in Fabric, and also the performance optimization techniques across different components in Fabric as well. And if you're new to this channel, let me introduce myself. This is Sheikh Mohammed. I'm an Azure Solutions Architect and Fabric Analytics Engineer. I have close to 15 plus years of work experience in IT. Let's dive into the roadmap. We'll quickly look at the roadmap. So we are building a 10-part video series around DP-600, and the goal of this course is to provide you with as much hands-on as possible. And we are building this course around real-world dataset, which is COVID-19 dataset. And if you haven't looked at my previous videos, I would encourage you to look at my previous videos to go through the COVID-19 dataset that we are looking at as a part of this course. And we also completed module 1, wherein we looked at planning, implementing, and managing data analytics environment, and how you can manage your analytics development lifecycle, and the data ingestion concepts and shortcuts and all those concepts as well. In video 5, we also looked at the transformation of COVID-19 dataset, and then how you can organize your data using medallion architecture and the basics of star schema and type 1, type 2 SCDs. So we looked at all of those concepts in detail in video 5. And without any further delay, let's dive deep into this video, wherein we will look at how you can identify the performance bottlenecks across components in Fabric and how you can use different techniques to provide resolution for those bottlenecks as well. Okay, and let me quickly take you through the Google Classroom community, and you can, whatever resources or artifacts we'll be creating as a part of this course will be uploaded into the Google Classroom community, and you can find the link in the description of this video. Let me quickly take you through the Classroom community real quick. So there you go. So we have this Classroom DP-600 Fabric Analytics Engineer, and you can see in the stream the posts or announcements that I post whenever a new video is out, or all of the resources you can find there. And under classwork, you can see all of the DP-600 course materials that we are creating as a part of this course, the PySpark notebooks and the official study guide links and COVID-19 public dataset links. And if you're following along, I would encourage you to raise a request and join this community, and you can download the notebooks and look at other resources that I'll be sharing in this community. Okay, let's look at the performance optimization matrix that I have here. So the idea here is to expose you to different tools that we need to use in Fabric to identify the performance bottlenecks, be it Dataflows Gen2 component or Spark notebooks or SQL queries. So I have provide the distinction here across different components. What are the different tools that you can use in the Fabric to identify the performance bottlenecks, and the resolution part, what are the different techniques that you can use to provide resolution for those bottlenecks as well. That's the idea. So I thought it's easier for you to understand with this matrix. We will quickly go through this in brief, and then probably we can jump onto the Fabric portal to look at different tools that you can use for identification across components. And then we can talk about techniques, and then we can also go through some of the Microsoft documentation to expose you to different techniques that you can use for providing the resolution when there are performance bottlenecks as well. Okay, so let's look at it in brief. So Dataflows Gen2, I think monitoring tool, it is not specific to one component. You can use across all the components. You can look at the monitoring tool, and then you can navigate to the Spark history server, or you can look at the refresh history for Dataflows Gen2 as well. So let's talk about Dataflows Gen2. I will take you through the monitoring tool, how we can use the monitoring tool in the Fabric to track the activities that we are performing in Fabric. Okay, so monitoring tool is one thing you need to know, and you can also look at the refresh history in Dataflows Gen2 and look at the details. Maybe I will show you shortly the refresh history for one of the data flow that we have executed. And notebooks, you can navigate to Spark history server, and then you can look at the DAG and the job details to identify if there is any performance bottlenecks at the job level. And you can also look at the executor metrics there, and I will also take you through the Fabric capacity metrics app. So there are a couple of components are there. You can look at the compute as well as storage in the capacity metrics app, which will come in handy whenever you need to identify if there is any resource consumption that you need to look at if it is really intensive. And SQL queries, we have the dynamic management views. So one example is you can what we're having here is DM execution query stats. So probably I will take you through some of the DMVs that you need to know to be able to identify the long running queries, be it or frequently running queries. So you just need to know, and then Fabric is already providing the abstraction for you to look at the query insights. So we will go through that as well. And you can look at the query execution plan to identify the actual execution plan, and then try and identify if there is any need for index to be created in case of complex joins you can optimize those as well. And we'll talk a bit about techniques, but I think we can look at the tools first for identification, and then we can jump onto techniques. And then we'll talk about each and every technique, be it Dataflows Gen2 staging, fast copy. In my previous video, I provided a demo. We'll probably quickly look at it in brief. And the applying incremental refresh, which is currently in preview in Dataflows Gen2 to improve the performance without doing a full load. And you can also push the filters early to reduce the rows processed. Okay, and notebooks, obviously the data partitioning will come in handy for parallelism. So we already looked at it for our COVID-19 dataset. To partition the data from when we write to the goal layer, we partition the data based on location. So that we can look at quickly as well. And the broadcast joins in case of smaller data sets without or avoiding shuffles when you are performing join to a larger data set. And if the data set is like dimensions, if it's small, you can broadcast it to different nodes across the Spark cluster. So that is an optimization technique that you can use. And you can, this is very important, you can enable optimized writes and view order for delta tables, okay, in Lakehouse. So that is enabled by default, but you need to know what is view order clustering or what is optimized write for delta tables and what it is doing and how it is helping to optimize the writes to the delta tables in Lakehouse as well. Okay, so we'll go through that. And SQL queries optimization, as I mentioned, you can look at the execution plan and then fine tune by creating the required indexes, right? So that will come in handy to optimize the performance in case of SQL queries that you are having complex queries and complex joins. Definitely there are opportunities to look at the indexes, right? So whether you have created those indexes correctly. So the way we can do it or identify is with the help of the execution plan that you can look at, right? And you can also use temporary tables and apply filters early to narrow the data set further on, okay, as and when we progress or process the data further. So those are all the key ideas as a part of this video. With this brief, I think we'll jump over to the Fabric portal to look at the identification tools first, each and every tool, and then we'll talk about techniques using the Microsoft documentation, and even with the COVID-19 dataset, what are all the techniques like fast copy in Dataflows Gen2. It's enabled by default, and what happened to the COVID-19 dataset, because it's of minimal size, which is 5 MB, and they have a threshold limit. Only when it reaches a threshold limit, you can the fast copy will be enforced, you can say. So we'll look at all of these in this video, and let's jump to the Fabric portal right away. Let me come back to the Fabric portal. So we'll look at the monitoring tool, as I mentioned earlier on. Let me navigate to, so you can see here, once you click on this 3 dots, there are different things you can pin, okay, and if I can navigate to monitor section, there you go. You can see all of the activities that we performed recently in Fabric workspace, and you can see the item type, be it semantic models or notebooks. So all of the activities will be listed here with the status, whether it is successfully completed or failed. From there on, you can navigate to Spark history server in case of notebooks. So we will look at it as well. So this will give you even different controls to enable different columns as well. If you need to add more columns to this view, you can control those as well. Okay, and even you can filter the list here based on the job succeeded, failed, or in progress. So all of those controls are provided here in the monitoring tool for you. So maybe let's look at the notebook. So here you can see the Spark application. So let me click on this already executed notebook, okay, Spark application. If I click on that, so you can see the different jobs that we executed as a part of this particular Spark application or the session that got initiated. So you can look at the run details here, how long the total duration the session was active. You can see the application ID, the run duration, and you can see the runtime as well, Spark 3.4 and the Delta 2.4, and the configuration as well, like driver cores, driver memory, 8V cores, executor cores, other information as you can see here. Right? But if you want to look at more details about these jobs, what you can do is you can navigate to the Spark history server itself. That will take you to a different tab. So let it load. So here you can see that particular application ID and the Spark session that you can see here. If you need to look at this particular session in detail, you can always go to that particular application, look at different jobs, like 84 completed jobs that you can see here. And you can also look at the stages, environment, and other information as well. And if you need to drill down to a specific job, you can also do that and look at the DAG as well. The visualization would be there. So if there are failures or if the job is taking too much of time, you can always come to the Spark history server and drill down to the lowest level, and then you can try and identify the problem or fine tune as well. Okay, so let me close this and let me go back to the monitoring tool. Close this as well. Go back to monitoring tool. So similarly, I think if you also need to look at different item types, you can do that. So you can see here the data pipeline, Dataflows Gen2 we have for COVID-19 cases. You can also look at the historical runs for those. You can look at the details here as well. Okay, but for Dataflows Gen2, let me take you through quickly the refresh history, right? So you can come to the workspace, DP-600 course workspace, and for this particular data flow, you can look at the refresh history as well, right? So once you click on refresh history, you can see the last refresh, and when you click on that particular refresh, you can get more details about what are all the activities that got executed as a part of this refresh. So we wrote the data to the destination, and you can see there is a warning. I talked a bit about fast copy in the previous video. There is a threshold limit. Only when it reaches that limit, it will kick in. Otherwise, for COVID-19 dataset, it's a minimal dataset, so it's just giving a warning. It's not applying fast copy. So maybe when we get to it, I can show you, maybe give you a brief about fast copy when we talk about the techniques. So let's look at the tools first, and then we can move on to the techniques, and then we will touch a bit about fast copy as well. Okay? So which is a very interesting feature provided in Dataflows Gen2. So under the hood, it utilizes the data pipeline copy activity to help you with ingest terabytes of data, and they have a threshold limit. If it's a smaller data set, it won't be applied. Even you can control the fast copy as well. Okay, so we will look at it shortly. So refresh history, you can look at if there is any issue during the Dataflows Gen2 execution, and then you can try and identify the problem accordingly, right? So let me also take you through the Fabric metrics app, capacity metrics app. So for that, let me come to apps here, click on apps. So here you can see Microsoft Fabric capacity metrics app already installed, right? If you don't see this, all you can do is you can click on get apps. That will take you through here, and you can go and install the Fabric capacity metrics app. Okay, that's it. So just click on the Fabric capacity metrics app. So here, as I mentioned, there are a couple of tabs that you can see, or pages you can see. One is compute and storage. So let me probably minimize this and zoom in a bit. Review. So there you can see under the compute, you can see the trial account that is attached to the capacity, and you can see probably the different options for users, operations, duration, or capacity units. How many, capacity units, the usage of capacity units for our workspace. So there you can see different components or items and the usage accordingly here to track. And the utilization also, you can keep a track here. And if there is overage or other information, you can look at here with respect to the compute. Okay. So here under, if you just scroll down, you can also see the items or the workspace that is consuming more capacity units, right? So you can see the workspace DP-600 cores. This particular item, which is ECDC cases transform notebook, is consuming this much of capacity units, and the duration and the users and other information you can see here. Okay, so the compute usage, you can come to this capacity metrics app and you can have a look and identify if there are any items that is kind of intensively consuming resources. You can identify those from this app itself. And you can navigate to storage as well and look at different workspaces consumption as well. Here you can see my workspace consuming significant storage, close to 7.54 gigs. Okay, and DP-600 cores, very minimal, only few artifacts we have. You can look at the storage as well, and across workspaces you can also filter by date range and look at the billable storage and other information as well. Okay, that's the idea. I think you can go back, click on go back, that will take you to the apps. Okay, and even you can look at other apps if you want to install from within Fabric. You can install those as well. So from identification point of view, we looked at the monitoring tool, capacity metrics app, we looked at refresh history, and what else? We looked at Spark history server in case if you need to identify any bottlenecks in any of the jobs. You can navigate to history server and then you can look at different jobs and then try and identify the problems there, right? Let me come back to the presentation. So we will quickly look at the DMVs as well. Okay, so and the query insights with respect to SQL queries. What are all the DMVs that you need to know? So let me quickly take you through those as well. So here I'm in Microsoft documentation. So I will make sure to provide all of this documentation links in the Google Classroom community for you to look at all of these details as well for all of the DMVs, but it's quite a lot. But we will look at the DMVs used to provide the abstraction for you to look at the query insights. For example, the long running queries and frequently running queries like those. So here I think you can see all of the execution related DMVs, dynamic management views, that helps you to identify or spot any long running queries in case if the query is taking longer, let's say. So here you can see a ton of DMVs. You know, this is execution related, but you can see there are a lot of other DMVs that are available. We are not going to look into those. Even in execution related DMVs, I wanted to focus on few of the DMVs like the DM execution query stats, DM execution requests, that will give you. So let me click on that particular DMVs. So you can go through the information. So it returns the information about each request that is currently being executed in SQL Server, right? And you can look at the different columns that it returns. Okay, the session ID, request ID, the status. Okay, whether it is running or sleeping or suspended. Okay, and the command as well. So here you can see it will just it will be providing just the command, like whether it is a select command or insert command or delete update commands. Okay, but if you need to look at the actual query that got executed, so you need to be able to use another DMV, which is DM execution SQL text with the SQL handle that you'll be getting here, right? There will be a handle that you need to pull and then provide it to this DMV to identify the exact text or the SQL query that is having a problem. Okay, So there are a lot of DMVs involved, but we will quickly touch upon few like the execution requests, execution sessions. That will give you the authenticated sessions on SQL Server. Okay, it returns one row per authenticated session. So you can look at the active sessions at the moment in the SQL Server as well. Okay, you can go through the details. I'm not going to get into each and every column on the information, but these are all useful DMVs you need to know. And Fabric is already providing abstraction for you to look at the query inside. So we will quickly look at that as well. Okay, so DM execution SQL text, you can pass the SQL handle from the execution request and then look at further information there. And there are many other useful DMVs, dynamic management views, that you can use to identify if there is any performance bottleneck with respect to the SQL queries that you'll be executing. Okay, so that's the idea. So if I go back to the Fabric portal, let me come back to the workspace, DP-600 workspace. Let me open the COVID Lakehouse. So what we'll do is we are in a Lakehouse view here. As you can see here, the tables and files view. But what I'm going to do is I'll navigate to the SQL Analytics endpoint so that you can query the data, okay, using the SQL queries. So now you are seeing a different view, right? So here you can see the schemas, queries that you are executing. Okay, you can create new SQL query and then query the data in the Lakehouse. So if I click on schemas, okay, there you can see the list of tables that we have. And let me minimize the DBO schema. Here you can see there is a separate schema called Query Insights. So that's the abstraction that I talked about, that Fabric is providing to you already. Okay, abstracting those dynamic management views already for you. So there you can see the execution requests history view already abstracted for you from the DMV we just looked at, and the long running queries, frequently running queries, and then the execution sessions history as well. Okay, you can always look at the information, like if you want to look at the long running queries, just click on it. It is already abstracted for you. You can identify the problem queries and then try and fine tune further by looking at the execution plan as well. Okay, there you go, we got it. So here you can see the data preview for the long running queries. You can see the median time, last run time, okay, start time, then the statement IDs. You'll have other useful information here, the query handle, that I query hash, and you can see the last run command information as well. Okay, so you can, based on the timings, okay, the last run, total elapsed time, that's the metric that you need to look at in case of long running queries. You know, what is that query that is taking longer, and then look at the execution plan further and try and fine tune the query or create the required indexes and then rerun and check, fine tune and check if the query is performing better as well. So those are the abstractions I wanted to show you, the frequently run queries as well. Then you can look at the sessions information, the requests we talked about. Let me quickly show you the preview. So here you can see the requests history, the total elapsed time, the login information, okay, and then the row count, whether it has succeeded or not, the session ID, the program, and other information, useful information that you can see here, and a query hash and the other information. Okay, so that's about query insights and the required DMVs that you need to know. So I'll be sharing the link to the Microsoft documentation. You can learn more about different DMVs if you want. Okay, so now we already looked at the tools that you need to know to identify some of the performance bottlenecks across different components like the Dataflows Gen2, notebooks, and SQL queries. Now let's talk about the techniques for resolution. So let's talk about the Dataflows Gen2 staging, fast copy quickly, and then the applying incremental refresh in Dataflows Gen2. And with respect to notebooks, we already looked at partitioning, but we'll talk a bit about it. the broadcast joins, as I mentioned, and then we will talk about optimized writes and reordering for delta tables. Okay, so let's look at it one by one quickly so that you will get an idea. Let me come back to the Fabric portal. We open the already existing data flow, the DF for COVID-19 cases. So here in this data flow, I think what you can see here, just wanted to show you, there are, to right click, you can see quite a few options like enable staging, incremental refresh. I think it's in preview, public preview at the moment, I guess. So we'll look at it, and then the require fast copy. So we will talk a bit about all of these three settings quickly. So let me navigate to this blog from Microsoft Fabric about the incremental refresh, which is in public preview at the moment. So the idea here is to ensure that only the data that has changed since the last refresh is updated. Okay, so that will improve the performance. So that's the key. And once, when you're trying to enable this option, you will have this window for you to set up or provide some configuration here, because you need to set up the filter. Okay, the filter column, which column you need to choose, that particular date or daytime or daytime zone column to filter by, and the extracting the data from the past. In this instance, it's 2 weeks, and then the bucket size and other configuration that you need to do to enable the incremental refresh in Dataflows Gen2. Okay, so it's quite easy to set up. So if in case you know the data is changing frequently at the source, you can configure the incremental refresh to improve the performance of Dataflows Gen2. Okay, then let's talk about fast copy. So as I already mentioned in my previous video, we did a demo on that as well, and you can I would encourage you to watch that as well. But in brief, I can quickly provide you a brief information about fast copy as well. So I think this is not enabled by default here, so you can enable the require fast copy, and the idea here is it will try under the hood to use the data pipeline copy activity in case of large data set that you're trying to process. There is a threshold limit. I talked about it in detail, so which is close to 100 MB. So only when the data set size is huge, or if it's trying to meet that particular threshold, it will kick in, and then it will try to utilize the data pipeline copy activity to improve the performance under the hood, okay, in the backend. Otherwise, if the data set is smaller, I think it won't kick in, even if you enable this setting, fast copy. So maybe let's quickly show you that. So I come back to DP-600. Let's close this Dataflows Gen2. Let me go to the workspace, and then here you can look at the refresh history for this Dataflows Gen2. And as I already mentioned, you can click on this activity, and I think this is just a 5 MB file, the COVID-19 dataset that we are trying to process. So you can see here there is a warning. Even when we enable the fast copy, it did not kick in, since it's saying, you know, not applying fast copy for source below size threshold. So the bytes that we're trying to process and the threshold, as you can see, is way higher, right? So it's not meeting that threshold, the data size. Hence, it's providing a warning. It's not applying the fast copy. Otherwise, it will be providing that capability for you to improve the performance when you're processing your data in the Dataflows Gen2. Okay, so that's the idea about fast copy. Let me come back to the Dataflows Gen2. So we talked about incremental refresh, enabling incremental refresh in your Dataflows Gen2 queries. Okay, and also we talked about fast copy. So let's talk a bit about staging, why you need to enable staging, and how you can improve the performance when you're executing your Dataflows Gen2. Okay, so let me go back to one other documentation. Okay, so this is a data factory spotlight. This article provides you useful information about how you can improve performance for your Dataflows Gen2 in Fabric. Okay, so let's look at the staging feature that will help you. We quickly come down or scroll down. So we'll quickly look at how we can controlling the staging for Dataflows Gen2. So what's the idea of staging here, right? So before you load your data into the final output destination, so you may want to stage your data in the lakehouse to improve the performance, right? And that you can do only when the data size is huge. So here they have listed few examples where you might not want to load data directly to the destination without enabling staging. So what are those scenarios? If your data source does not contain big data volumes, or if you're not joining data from different sources, or if you're not performing memory or compute intensive transformations such as joining or aggregating large data volumes, right? In such a scenario, you may not want staging enabled, so you can directly write to the destination. Okay, but if you want to control staging, if the data size is huge, you can do that. We'll have a look at it quickly. So here they are providing a quick example when you're trying to load the data from a 100,000 CSV file to a Azure SQL database, right? So I think it's not required. So in this scenario, they're saying 100K records to my Azure SQL, and I would like to apply some few transformations like renaming and removing columns and filter out columns. But for these type of transformations in data volume, staging data is not required, right? So it's not massive data that we're looking at here. So you can disable the staging for any query by right-clicking the query and deselecting the enable load action. I think it's not enable load, it's directly you can enable staging or disable it by right-clicking a specific query, okay, in your Dataflows Gen2. So here there is this useful diagram. So what happens in case if you're not enabling staging? It will be this mashup engine is the Dataflow engine. It will be used directly to load the data from source to destination. In case if you are enabling staging, what happens is the data will be pulled and loaded into the lakehouse staging lakehouse. So I think in the backend it will create a separate lakehouse to store your data first, okay, and then optimize the data probably by partitioning the data. So it is completely abstracted, you no need to worry about it. So all this will be done in the backend, and once the data is loaded into the staging, and Microsoft is leveraging the Spark compute engine to speed up the process, the transformation process, and then finally load it into the output destination. So that's the difference when you're trying to enable staging or when the staging is disabled. And please keep in mind, if you are enabling staging for smaller data sets, there would be a overhead. There could be overhead that could degrade the performance as well. So enable it only when it is required. So when the data size is massive, you can enable the staging for your Dataflows Gen2, and that will improve the performance for you as well. Okay. So that being said, let's go back to the presentation. So we looked at different capabilities or techniques that you can use to improve the performance of Dataflows Gen2, like be it fast copy or staging or incremental refresh, which is currently in preview. So let's talk a bit about if you are using Spark notebooks for your transformation, how we can optimize the performance. So in that case, I think we'll quickly look at the data partitioning, which we have already done for the COVID data, and then we will talk about the V ordering and then optimized writes for delta tables. So let's jump back to the Fabric portal. So here, let me close this Dataflows Gen2. So let me open the notebook from the workspace, which is DC-DC cases transform. So we have already done some transformation in the previous video as a part of transform data, and then finally the gold aggregated data we wrote it to a delta table. Let me show you that. So here you can see, so we already wrote the final gold data after transformation. We wrote it to this table called COVID gold aggregated KPIs. You can see here we already partitioned at the time of writing by location key as a delta table, and then we loaded. Right? So here, if I can navigate to the lake house, under tables, you can see the gold aggregated data, COVID gold. Let me expand this, COVID gold aggregated KPIs table, which is our final gold table. Okay, for further analytical process. Let me click on this 3 dots and look at view files. You can see the data is partitioned based on the location key already. Okay, so when we wrote it to the lake house as a delta table, we partition the data for efficient processing further on, right, by the downstream process. So that's the key, and data partitioning will come in handy. And I think there is this blog by Sally Daba. She talked about efficient data partitioning with Microsoft Fabric, best practices and implementation guide. So she did exactly the same. She talked about and she provided a bit of introduction about what data partitioning is. It's the data management techniques. So we are trying to shard or divide the data into more manageable chunks. The primary goal is to improve the performance and scalability and manageability in case of large scale or big data systems, right? So that's the key. And here you can, she provided a sample example with the yellow trip data, taxi data, and she did exactly the same that we have done in the previous video. While writing, she's partitioning by year, month and day, and you can see the in the lake house the data is partitioned by year, month and day, and then you can see the Parquet files loaded there. I'll provide the link again in the community. You can go through and also follow along if you want. Okay, so let me come back to the Fabric portal. So we talked about data partitioning. Let me take you through a couple of other techniques about how you can optimize the delta table, right? So there are a couple of techniques we need to know. Okay, so but it is enabled by default. I will show you from the Spark history server. It is already enabled. You no need to enable it. Okay, it's enabled by default, and if you want to disable it, I don't think there is a reason for you to disable. You know, it provides benefits when you're writing it to the delta table. So I think we can also look at the Spark configuration to show you those settings that's enabled by default as well. But let's try and understand these couple of techniques, the optimized write and reordering when you're writing to the delta table. So reorder is nothing but a write time optimization. So I'm here in the Microsoft documentation just to quickly take you through to understand this concept. Okay, it's a write time optimization to the Parquet file format directly. Okay, so it's basically it's trying to apply some special sorting, right? So and row group distribution and dictionary encoding and compression as well on the Parquet files. So you no need to dive deep into what's happening in the background as a part of reordering, but at a high level, just keep in mind it's applying special sorting and the compression techniques on the Parquet files when you're writing, thus requiring the less network and disk and CPU resources and compute engines to read it. So once it's returned into the lake house, then further on when the compute engines, when it's trying to read it, it will be much faster. So they are providing some metrics here. So the reorder sorting has a 15% impact on average write times, but provides up to 50% more compression as well. Okay, so it improves the efficiency, okay, the cost efficiency as well as the performance as well. It's 100% open source Parquet format compliant. So all Parquet engines can read it as a regular Parquet files. So no need to worry about it as well. Okay, and how you can control this. So let me show you the configuration. Okay, the Spark .sql.parquet.vOrder.enabled is true by default. Let me show you. So let's open the monitoring tool real quickly. We open this Spark application. We will navigate to Spark history server quickly just to show you the configuration. So open the application. So navigate to environment, and you can see the Spark properties listed here. Let's do a quick search on vOrder, and there you go. There you can see the Spark SQL Parquet vOrder enabled is true by default. So I didn't set it explicitly. It is enabled by default for you when you are writing to your Delta files in the lakehouse. So it is enabled already for you, but you need to know what this technique is. From exam point of view, you need to know both of these techniques to optimize the Delta files, table files that we are writing to the lakehouse. Okay. And the second technique is, let me come back to the documentation. So that's how you can control the vOrders technique. Let's talk a bit about, let me scroll down. Let's talk a bit about optimize write as well. Okay. So optimize write is another technique. So wherein it addresses the small file problem. So what is the small file problem? So when you're ingesting data into the data lake, right? So there are many characteristics which constantly write lots of small files. Okay, so it's possible, and this scenario is commonly known as the small file problem, they call it. Okay, and how we are trying to address with optimize write. Okay, so the big data processing engine like Apache Spark perform most efficiently when using standardized large file sizes, right? So a lot of too many small files will create a problem for the compute engine to read and process, and that's where the optimize write technique will come in handy. And how we are going to do it is optimize write in Delta Lake, and it's available in Synapse Analytics as well. Okay, in the Spark engine, that actually reduces the number of files written, and I think it's trying to, its aim is to increase the individual file size of the return data. So it will try to address the small file problem, and the target file size can be changed as per the workload requirements, but the idea here is to address the small file problem to standardize the file size itself. Okay, and again, this feature is also enabled by default in Fabric runtime. You no need to explicitly enable it. Okay, but you need to know what this optimized write is as well. Okay, so let me come back to the Spark history as well. We just looked at the vOrder, which is enabled by default. Let's also search for the optimized write property. Optimized write. There you go. You can see there spark.microsoft.delta.optimized-write.enable is by default true. So those are the couple of settings which you need to know to improve the performance when you read the Delta files from the compute engines, right? So when you're trying to write to the lakehouse Delta table, so you can partition the data, and then you can apply this couple of, it is enabled by default, so you no need to worry. In Fabric, it is already enabled, the vOrder clustering. It applies some special sorting and compression, and then the optimized write to address the small file problem as well. Okay, so let me come back to the presentation. So we so far looked at how you can apply different techniques in Dataflows Gen2 to improve the performance when you're looking at larger data sets, and also when you're using Spark notebooks, how you can partition the data for parallelism. And also we looked at optimized writes and vOrder for Delta tables as well. Okay, so in case of SQL queries, how we can use different techniques to optimize the SQL query, right? So we looked at the tools or the DMVs that you can use to identify the long running query. So imagine once you figured out, okay, so there is a problem with the query, with the long running query. So you can also look at the execution plan, as I mentioned, right? So to identify where it is taking a lot of time, right? So which dimensional join or which join is taking a lot of time. So to drill down to a specific object, you can look at the execution plan and then look at it further and then try and identify if an index is required. So once you identify, even you can create a non-clustered index with the include operator as well to include a lot of the other columns that are involved as well. That will speed up the query processing as well. So that's the key here, is to try and identify if there are issues with index, even the execution plan, the estimated execution plan. Okay, so we'll give you some suggestions to create some indexes which are missing, or you can manually look at different joins and where it is taking a lot of time, and try and optimize further by creating the required indexes. Okay, so that's the key. And you can also use temporary tables and apply filters early, as we talked about, to try and minimize the data set later on during complex joins as well. Okay, so that's some of the techniques that you can use to create some indexes and also fine-tune the query itself to resolve the bottlenecks, if there are any bottlenecks with your long-running queries. Okay, thank you so much for watching. A quick summary. In this video, we looked at performance optimization techniques across different components like Dataflows Gen2, Spark notebooks, or SQL queries. So we looked at the tools required to identify the performance bottlenecks across different components. And then we looked at the different techniques. For Dataflows Gen2, we talked about fast copy, incremental refresh, and also staging in case of larger data sets to optimize the performance of Dataflows Gen2. In case of Spark notebooks, we looked at the Spark history server, how you can navigate and identify the performance bottlenecks for different jobs that we executed by Spark cluster, Spark compute engine. And then we looked at different techniques like the V-order clustering and then the optimized write to the Delta table files, how we can optimize that. And also we looked at the data partitioning when you write to the lakehouse. And for SQL queries, we looked at different dynamic management views. So we looked at few of the dynamic management views, and then how Fabric is already providing the abstraction to look at the query insights in case of long running queries or frequently running queries, or the requests that are currently being executed, or the current sessions. So those are the different DMVs that you can use to identify any performance bottlenecks with your SQL queries. And with respect to the resolution, we talked about creating the required indexes by looking at the execution plan for your query and try and identify where exactly it's taking a lot of time, and then create the required missing indexes to improve the performance of your SQL queries. Okay, so I hope it's helpful. Thank you for watching. See you in the next one. Hi everyone, welcome back to the channel, and welcome back to the brand new course on DP-600 Microsoft Fabric with real world project. And we are in module 3, implementing and managing semantic models. So in this video, we will cover designing and building semantic models. So if you don't know me, this is Sheikh Mohammed. I'm an Azure Solutions Architect and Fabric Analytics Engineer. Let's look at the roadmap. So we are building a 10-part video series, and we have a Google Classroom community. And I will quickly show you the Google Classroom community. You can join there and look at all of the artifacts or resources that we'll be building, we'll be sharing there. So you can follow along throughout this course. And we have already completed a couple of modules in this course. So the planning, managing and implementing your data analytics environment, and the managing your data analytics development lifecycle. Then we looked at data ingestion, transformation, and then implementing a star schema with type 1 and type 2 SCDs. And we also looked at performance optimization as well. So a couple of modules we have completed already. And if you're new to this course, I would encourage you to look at the previous videos, couple of modules, and look at the COVID-19 dataset overview that we are utilizing throughout this course to demonstrate with the real world dataset. So the whole idea of this course is to help you with as much hands-on as possible with the real world dataset. So we are utilizing COVID-19 dataset to demonstrate the course end to end. So let's dive into this video. So in this video, we will be covering the semantic model storage modes. What are the different modes like direct query or import mode or direct lake? So we'll talk a bit about those different storage modes. Then we will look at how we can build a star schema for the semantic model, how we can define the relationships in a semantic model in Fabric. And we will look at how you can write calculations that use DAX variables, functions such as, say, iterators, table filtering, windowing, and information functions. So I'll show you the demo with the help of COVID-19 dataset. So be till the end of this video to gain more understanding on these functions, DAX functions. And we will also look at how we can implement calculation groups, dynamic format strings, and field parameters. So I can show you this in action with the COVID-19 dataset. And then we will also look at how you can identify use cases for large semantic model storage format. Okay, so how we can configure that as well in Fabric. And we will also talk a bit about composite models, how we can design a composite model, and what's the use case for composite models as well. Okay, so let's get started. Okay, let's talk a bit about semantic model storage modes matrix. So I wanted to help you to understand through this matrix with different features, so it's easy to understand. That's the idea of building this matrix. So we have different storage modes, as I briefly talked about. So we have import mode, direct query, and direct lake, right? So let's break down each and every feature right from storage location and performance. So we'll help you to gain some understanding into different modes. So with respect to storage location, so import mode is always in memory, right? So if you talk about Azure Analysis Services analytical engine where you deploy the data models, it's completely in memory. So you need the data movement to the memory from your original data source. So it's an in-memory cache. Direct query, there is no data movement. It's a direct query. So it's the data lies in the source itself, source database. Direct lake is a game changer in Fabric. So it's also something no need to move the data around to your memory like an import mode. So it talks to the files stored in data lake directly, and then it's near real time as well, right? So it's very much efficient compared to direct query. Okay, so performance point of view, performance is really high in import mode, but the only thing which you need to keep in mind is to move your data around to the memory, and that requires some time to move your data into the memory, right? And it's low latency. Once you have the data in memory cache, it is highly performant and low latent. And direct query depends on the source database speed, so nothing we are moving around, so it looks at the source speed itself. Direct lake is near real time, so low latency for lake data with respect to performance. Refresh needs feature, so import mode, scheduled refresh. Direct query, no refresh required because we are directly talking to the source database. It's a live query. And direct lake is also near real time, no refresh. So only in import mode you need a refresh from the source database itself. Okay, and data size limits, it's very limited by Power BI Analysis Services, Azure Analysis Services memory. So direct query depends on the source, and direct lakes optimized for large lake datasets. Okay, complexity support, import mode, you have full Power BI transformation support and DAX support. Direct query, very limited support, DAX support. If you don't know about DAX, it's data analysis expressions. We will talk about different functions in the later part of this course, this video. And direct lake, similar to import mode with the lake advantage. So direct lake is going to be game changer. So I will also demonstrate quickly with a Microsoft documentation diagram as well shortly. So best use cases. So for smaller high performance data sets, you can use import mode, but you need to have a strategy in place. And it is ideal if you need to have all of the historical data in the underlying tables and then expose only a few years in the report. Then you can go for import mode and restrict the data set in the memory, so you can load whatever is required. That's it. So in that kind of cases, use cases, you can go for import mode. Otherwise, I think large direct lake based is near real-time performance, you can go for it. Okay, so near real-time models. Direct query, large data sets needing live queries, but when you compare direct query and direct lake, I think Direct Lake is much more efficient and faster with respect to the performance. If that's at a very high level, the different storage modes or options that you have for semantic models, and you can decide which mode is suitable for your use case, and then probably implement it accordingly. Okay, let's quickly look at this diagram to better explain these three different storage modes. So here you can see the import mode, wherein we take a copy of all of the source tables into the memory cache, and then it's fast but latent and the data is duplicative, right? So you need a copy of data in the memory, and then you can start analyzing the data further. With respect to direct query, yeah, it is near real time, okay, but it's slow, okay, so not like direct lake. So you can see on the top of this diagram, the import mode is in the center, and at the bottom you can see the direct lake capability, which is perfect, right? So it's pretty much faster compared to direct query, and there is no data duplication also happening. It talks to the delta table files directly in the data lake, and it's near real time, and it's much perfect with respect to performance. It is quite performant as well. Okay, so that's at a high level what are all the three different storage modes that you need, and depending on your use case, as I mentioned, you can also go for import mode, or direct lake would be the first choice if you need a performant solution, okay, or in case if there is a requirement to copy have all of your data in the underlying tables, and then only you need a specific data set in the data model and report, then you can go for import mode. Okay, now let's look at the star schema implementation in the semantic model that we have built on top of the gold aggregated KPIs that we have built in the previous videos for the COVID-19 dataset. So I'm here in DP-600 codes workspace in Fabric portal. So we have the COVID lakehouse that we already built, and we have the SQL analytics endpoint. So let me move on to the lakehouse. So once the lakehouse is loaded, you can create a new semantic model right from within the lakehouse, or you can even switch to the SQL analytics endpoint by clicking on SQL analytics endpoint. Here you can see there is a home tab and also the reporting section. So if you navigate to reporting, you can manage the default semantic model, or you can create a new semantic model from within the analytics endpoint as well. So we're not going to create a new one right from the scratch. So I've already created the model and then established the required relationships to demonstrate for this video. So let me go to the DP-600 course. So when you click on new semantic model, you can choose the required objects or the tables that you want in the model, and then start establishing the relationships between those fact and dimensions. So here we are in the workspace. So I have already created the COVID-19 model that you can see here. So let me move on to the model. So okay, so let me click on open data model. That will take you to the data model itself. So here you can see under the model you can see different options like calculation groups, measures we have built, and relationships, tables. What are all the tables we brought into this semantic data model? Okay, so as a part of the demonstration, so I've brought in the dim date dimension, location dimension, and then the COVID gold aggregated KPIs that we have transformed and then finally loaded into the gold layer. When we talked about medallion architecture, we loaded into the gold layer with the partition as location into the lakehouse. So you can watch my previous videos to get to know more about how we transform the COVID data, and then how we navigated between the bronze and then silver and then gold aggregated KPI layers, and then finally loaded the gold aggregated KPIs. Okay, so you can watch those videos. If you are new to this course, I would encourage you to watch those previous videos. So for the sake of this particular video, I'm not going to get into the intricacies of those medallion architecture. So we already have the gold curated data for the COVID dataset, and a couple of dimensions we are going to establish the relationships in this video with the fact table, which is our gold aggregated KPIs. Okay, so you can see here we have this gold aggregated KPIs table, and then we have dim date and location. So basically I've established a couple of relationships. Once I brought in the fact table, which is a gold aggregated KPI table, and then couple of dimensions. So we are going to make this very simple for the demonstration purposes and also for the reporting purposes later on in the course. So we have this fact table. So dim location, you can see it is going to be a one-to-many from dim location to the COVID gold aggregated KPIs. You can double click on that relationship and you can see what the relationship is all about and which column we have linked. So from COVID gold aggregated KPIs, it is the location key that we have linked to the location key in the dim location table. Okay, and you can see the cardinality is many to one from location to the fact table. Okay, sorry, it is many to one from the fact table to the location table. So one on the dimension side and the many on the fact table. Okay, so that's the cardinality, and the cross filter direction is single, and we are making this relationship active. Okay, so it is already done. So just to let you know, and dim date, it's again one-to-many relationship on the basis of the date keys. As you can see here, date key linked to the date and the dim date dimension, and it is already, the relationship is already established as well. Okay, so only we have a couple of dimensions that we have linked to the gold aggregated KPIs table. Okay, and then we will talk a bit about some of the measures we have built on top of this fact table as well. Okay, so if you open this COVID gold aggregated KPIs table, so probably when we get to the DAX functions, I will showcase some of the measures we have built and the DAX expressions we have built for this COVID gold aggregated KPIs. Okay, so with respect to the relationships and how you can build the semantic model, design and build the semantic model, so you can right away from the lakehouse or from the SQL analytics endpoint, you can create a new semantic model if the default is not okay for you, and then pull the required objects and then start establishing the relationships, and then your data model is ready. Okay, and keep in mind, as you can see here, there is a kind of warning or a notification from Microsoft. Your changes will be permanent and automatically saved. So whatever changes you do, you don't need to save it explicitly. All the changes will be automatically saved. So please keep that in mind as and when you explore the data model or make some changes in the relationships, or if you're creating some calculated measure, you need to keep that in mind. Okay, so time intelligence, I will get to it when we get to that particular section in this part of the video. Okay, so that's how we built this simple data model. I would say a start schema with the fact table as our COVID gold aggregated KPIs table that we built when we transformed the data in the previous videos, and then couple of dimensions, date dimension, location dimensions, we have linked to the fact table. And one thing to quickly note in the data model, so here in the data model, you can see there is a blue dotted lines on top of each table, right? That signifies the storage mode is data lake. As you can see, if you hover over the line there, you can see the name of the table. The storage mode is direct lake. So earlier on in this video, we talked about 3 different storage modes, and I talked about direct lake and why it is much efficient. So it is direct lake. We are not duplicating the data as such to the memory like in import mode. So any changes to the underlying Parquet files or the data lake will be reflected immediately in the report. Okay, so that's the advantage, and it's pretty much faster. Well, let's quickly look at the calculations that use DAX variables and functions such as iterators, table filtering, windowing, and information functions. So I have quite a few measures with these functions incorporated in this notes. So I'll be uploading this document in Google Classroom community as well for you to access. So we'll also showcase these in the data model that we have built shortly as well. Okay, so daily new cases calculation measure. Here we are utilizing where current cases. So the variable is used here to store the intermediary values like total cases or death counts. Can improve the readability. So you can store it in this variable, and then you can use it on later in the expression wherever you want. Okay, and is blank here is an information function which we are using to ensure if there are blank values that it returns 0. So we are using this information function called is blank to check the current cases, and if it is blank we will be returning 0. So we have leveraged variable and information function within this particular measure, daily new cases. Okay, so maybe I think once we run through this document, we'll take you through the measure we have built in the data model itself. Okay, and then we are looking at 7-day rolling average of daily cases. So we were trying to use the iterators and windowing functions. We name this measure as average 7-day daily cases, and we are storing the window that we are building in date window. And then you can see we are leveraging this average x, which is an iterator function. Okay, so it's an iterator function that we are using to create the moving average by passing in the date window, and then we are calculating the sum of COVID gold aggregated KPIs table, the daily cases column we are passing in there. So that's how we are utilizing dates and period window function and average x iterator function in this measure to calculate the 7-day rolling average of daily cases. Okay, and then let's move on. And then in the cumulative cases, we are trying to use filter and all selected. Okay, so we are trying to leverage a couple of functions there. So again, we are storing the maximum date key in the current date, and then we are returning with the calculate function. We are aggregating with the sum function. And in the filter, we are passing all selected. The reason why we are passing all selected is when we probably later on come to the report, you will come to know why I'm using all selected. So just in case if you need to slice the data based on any filters in the report itself, we need to apply that particular filter in the report itself. Otherwise, it won't be considering that filter in the report. So you need to use all selected instead of all. So we are leveraging all selected and then passing the table name and then the date key, which is less than or equal to current date. So basically what we are trying to do here is the all selected function removes filters within the calculation but keeps those applied at the report level, as I just mentioned. Okay, and the filter function limits these dates up to the current date that we are storing here. Okay, so basically we are trying to calculate the cumulative cases using the filter function and the all selected function. Okay, in this measure. And then similarly the cumulative deaths, same calculation, but here we are trying to calculate cumulative deaths as well. Okay, and then let's look at the summary. So in all of these DAX measures, we are trying to leverage the variables, iterator function like average x, windowing functions to calculate the 7-day moving average, and then the filtering function with the all selected as well controls how the rows are included or excluded, critical for cumulative calculations, so as we have just seen. And the information functions like is blank, if, you can use to provide a condition based outputs as well. Okay, so let's move on to the Fabric portal to see these variables and functions in action. So I'm here in the data model. Okay, so you can probably expand this. So under the model, you can, under the tables, you can see there are under COVID gold aggregated KPIs, you can see I've created quite a lot of measures. And if you want to create a new measure, it's simple as that. You can right click or click on this 3 dots, create a new measure. It will create a new measure for you. So let's look at one by one the daily new cases. You can see here I have this DAX expression here with the variable created, and then we are using this information function called is blank of the current cases, comma current cases is comma 0. So in case of any blanks in the current cases, it will return 0. So that's the idea. So the measure we have built to calculate the daily new cases, and then we look at the average 7-day moving average daily cases. So the exact DAX expression we have just looked at in the document. We are creating that date window variable, and then we are passing the date window and leveraging the iterator function average x to calculate the sum of the daily cases. And so this will calculate the 7-day moving average for me. So we'll also look at a report that I've built shortly to see this measure in action. Okay, so and then let's move on to cumulative cases measure. So we are storing the maximum date key information in the current date, and then we are using the calculate function and the filter function and all selected, and restricting it to less than or equal to the current date. So to calculate the cumulative cases up to the current date. Okay, so similarly cumulative deaths, we have the DAX measure. We have built the cumulative deaths as well. Okay, so those are the measures we have built to demonstrate the variables, DAX variables and functions, important functions from exam point of view. So you can go through this, build the data model from the COVID data set, and try to replicate these measures and build the report as you follow along the course. Okay, so let me move on to the reporting section. So here you can close this or just minimize this. So from the workspace itself, you can navigate to the report. So I've already created one report, or if you want to create a new report from within the model, you can always create a new report. Okay, so open the data model, and then new report. You can click on new report to generate a new report out of this semantic data model. So I've already created a data model, and I have produced few of the reports to showcase this new measures we have built in action. Okay, so here I'm in COVID-19 report. So let's quickly run through this report to see some of the measures we are seeing here in action. So I've built a sample report, like I'm looking at total cases by country. So, and what are all the so just click on edit. This is in reading view. If you click on edit, you can see the data view as well. Okay, so for this report, total cases by country, you can see I've brought in the daily cases. Okay, not a measure. You can also bring in the measure as well. Okay, so if you can switch, you can see there the daily new cases measure we have built. Okay, so we brought in and then we generated this report wherein I can look at the most number of cases. I can see it in Brazil, then Russia, then United States of America, and then United Kingdom, and then it goes on. Okay, so we are looking at this report to identify the daily new cases by countries and territories, and you can see the slicer is at the location level. So wherein I brought in the countries and territories in the y-axis. Okay, and then let's look at the 7-day moving average we just talked about. Let me hide this filter section and visualization section, expand this a bit. So here you can see I've built the 7-day average cases only for Australia, just for the demonstration purposes. I'm picking one country and then filtering and looking at this report for only one country, which is Australia, 7-day average cases with the DAX measure. So I have produced a couple of reports, one without the DAX measure. Okay, I'll show you shortly, and then one with the DAX measure. Okay, which means like you can create the calculated measure right within the data model, but when we loaded the COVID gold aggregated KPIs also, we have calculated those 7-day moving average and all, and then loaded or persisted in the table itself. So I'm just going to show you both the cases. Okay, so here you can see the Australia COVID cases trend. Okay, so if you just click on this report, you can see I've brought in the average 7-day cases from the table itself that we have already calculated, not using the measure as such we have built in the data model. Okay, and then I brought in the date from the date dimension in the x-axis. Okay, so here you can see a trend or a couple of peaks there So the entire scale is from January 2022 to December 2020, right? So here you can see there is a peak during March, and then there is a peak during August, and I've already validated this information or insight in one of the website as well. I'll just quickly show you that as well, just to check the authenticity of this data or insight we are looking at in this report. Okay, so this is without the DAX measure, and this report we brought in the average 7-day daily cases measure. So there you can see a couple of peaks, or the cases peaked during March and August 2020 in Australia. Okay, so to validate that fact, I can quickly show you this link. So maybe I can share this link in the community as well. You can go through the data. So maybe we can, so here it is still 2024. Let me restrict it to 2020 to look at the couple of peaks that we are looking at. So till December, okay, so there you go. So here you can see this is from a website or worldindata.org, the coronavirus tracker for Australia, the daily number of confirmed cases. You can see here from Jan to the December 2020, there are a couple of peaks, one in March and one in August. The cases peaked during those months in Australia. Okay, so that validates the fact or the report that we have produced in Fabric to just check the authenticity or the validity of the data itself. Okay, so you can also move to the reading view to look at the report. I'm not saving anything. So we looked at the COVID cases trend in Australia without the DAX measure, and then this is with the DAX measure that we have built in data model using the iterator function average x, and then we built that date window and passed to the iterator function to calculate the 7-day moving average. And you can see there is a clear peaks during March and August. The cases peaked during those months in Australia. So I think I already mentioned the 7-day moving average will kind of smoothen that fluctuation if there is any fluctuation in the dataset or noise in the dataset, and that will give you a clear picture or clear trend in the dataset itself. Okay, and then I have a couple more reports. Australia. So just for the demonstration purposes, I have considered Australia to show or demonstrate in the report. Otherwise, you can play around with any other countries to look at the information or the trends and cases in across countries in the world. Okay, but for this particular video or for the course point of view, I've considered Australia to look at different metrics in Australia. Okay, so Australia cumulative cases by date, you can see there. I think here we are again leveraging the measure that we have built. Just to quickly show you, so here we have pulled in the calculated measure cumulative cases. Okay, let me move on to the reading view. Here you can see there is a clear trend again from March. The cases peaked, and then again in August the cases peaked to the highest, and you can see the cumulative cases overall throughout that year 2020 is around 28k. Okay, around 28k in Australia. And I think this is with DAX measure, and this is without DAX measure. We have already loaded the data just to cross check if the measure is working fine. I have built a couple of reports by pulling the column or persisted column from the table itself, fact table itself, and then I've used measure to cross check if the data or the insight what we are looking at in the report is fine. So Australia cumulative cases, so you can quickly check that which column we brought in for this report. So you can see here I've not used the measure. Instead I have brought in the actual column itself from the fact table. Okay, so let me move on to the reading view, and then we are looking at Australia cumulative deaths, and there is an insight. So I think the entire 2020 the cumulative deaths is around 908 deaths happened throughout the year. So that's the information we can take away from this report for Australia. Okay, And then let's move on to, I think we have covered almost all of the measures we have built and the different DAX functions we just spoke about. Okay, now let's talk about calculation groups, dynamic format strings, and field parameters, how we can implement these in our data model. So we will quickly look at these in summary, and then we will move on to our COVID-19 data model and see this in action shortly. Okay. So calculation groups, so it allows you to apply some common calculations across multiple measures. So streamlining analysis for similar metrics like let's say year to date and month to date. So I have a couple of measures we are going to create. So year to date and month to date, the DAX expression is pretty simple. You can use calculate function and then selected measure function, comma, the dates year to date, and here dates month to date, and then you need to pass the date dimension from the date attribute from the date dimension. That's it. And we will shortly look at how you can look at these metrics and report. We will quickly show you that. And dynamic format strings, what is dynamic format strings? So in the data model, we can look at how you can apply different formats to values based on the context. Okay, whether you want to apply currency format or percentages format. But from COVID-19 data model point of view, I will show you how you can implement this to look at it in action. Okay, the dynamic format strings in the data model. And then the field parameters. So here I have pasted the screenshot, but we will look at the demo shortly. So here you can see the month to date, year to date. Okay, so I will take you to the report and then show this to you quickly. Okay, and the dynamic format strings as well. And let's look at field parameters. So field parameters let users dynamically toggle between fields or dimensions and visuals. So we will see this in action shortly. So I have a screenshot here, but we'll look at the report shortly. So imagine you need to toggle between different metrics like cumulative cases, cumulative deaths, or 7-day moving averages. So we can create a field parameter, and then you can just toggle between those to look at different metrics within a single report. Let's look at each one of these in action. So let me move on to Fabric portal and the data model we just built. So here in the model, you can see the calculation groups. You can create the calculation groups right from within this Fabric experience. Otherwise, you can use third-party tools such as Tabular Editor to create the calculation groups. Okay. Under this, you can create different calculation items like the current one, which is the actual selected measure itself, and then the month to date, as I mentioned in the document, you can use the dates mtd function and then pass the date dimension date to it. And then year to date we have, and then to show the difference from the year to date and applying the dynamic format strings, I've created another calculation item, so I will talk about it as well. Okay, so the same function we have used it, but the one thing what we have done differently, if you look at the year to date and click on the properties, here the dynamic format string is not enabled, but in the last calculation item ytd_df, I've enabled the dynamic format string. So this is how you can enable the dynamic format string for any measure or the calculation item that you're building, and then you can apply the format string. So here I'm just trying to use this expression hash comma hash hash 0, and the idea is to eliminate, let's say, the .00 in the report. Okay, so year to date has 4.00 the case numbers with .00 decimal points. So I've removed that and then formatted it to make it clean in the year to date _df. Okay, that's what I did in the format string by enabling the dynamic format string and passing this expression to eliminate the decimal points. Okay, so as simple as that. So that's how you can create a calculation group and calculation items. So let's look at the report shortly. So I'm here in the COVID-19 report, and I have this report calculation groups daily cases. Let me load that report. So let me load that report, and then we'll maximize this in focus mode just to have a better view. Here you can see I brought in the date and then the different, so let's look at what are all the attributes that we brought in. Just to quickly look at this report. So here you can see rows I have brought in date, and then in the actual values I brought in the daily new cases measure from COVID gold aggregated KPIs. Okay, that's it. And then in the columns you can see I brought in the calculation group itself into the columns. So what happens is, once you have the measure brought into the values, and then when you're bringing the calculation group into the columns, it does the job for you. So when I move to reading view without saving this, and in the focus mode, you can see the current measure, which is the selected measure, daily new cases. And this report, we are again filtering. We have a filter on this page. We are restricting it to countries and territories, Australia only. So we have the current measure, and then month to date, year to date, and then the formatted dynamic formatted string applied measure as well. So if you look at the data, I think around 26th of January 2020, you can see there are 3 new cases, and 25th we have 1 new cases, and you can see the month to date captures that information correctly for that month, January, and the year to date as well. And if you move on to, let's say, February, 1st of February, we have 2 cases. So the month to date on 2nd February is 4. So the month calculation works fine, month to date. And year to date, you can see after January, it picks up from February as well. So that's the idea. If you need to calculate metrics like month to date and year to date, then you can leverage calculation groups, and then you can look at the measure, the daily new cases in our COVID-19 model. With the help of these calculation groups, you can look at different metrics like month to date, year to date with a single measure. All you need to do is create the calculation groups and different calculation items, and then bring in those calculation items or the entire calculation groups into the columns, and then your actual measure into the values, and then it does the job for you to produce the report. So that you can see this calculation group in action here. And year to date dynamic format strings, as I mentioned, we are eliminating those .00 from year to date, and then we are making the data cleaner to look at in the report. Okay, so that's how the calculation groups works. Okay, so I hope you get an idea. Okay, now let's look at the field parameters in action. So for this, since I can't install the Power BI desktop on my Mac, so I've created a virtual machine in my Azure subscription, DP-600 demo VM, and I have installed the Power BI desktop there. So let me open the Power BI, the virtual machine I've created, just to showcase the field parameters demo in Power BI desktop, how you can create one. So there we are in the Power BI desktop. Okay, so here I've connected to the data model with the help of XML endpoint. And the way you can create field parameters is by getting into the modeling section, and then there is a section called parameters. You can create a new parameter, parameter fields, and then you can pick up the different fields from your data model. Okay, as such. So for the demonstration purpose, I have created this field parameter. I brought in different metrics like cumulative cases, cumulative deaths, 7-day moving average, and daily new cases. Okay, and all you need to do in the report is, we brought in the date and x-axis. Okay, and then in the y-axis you need to bring that parameter that you have created. Okay, so that you've just created in the Power BI desktop. So bring in that parameter in y-axis, and there you can see the report is generated already with the 7-day moving average. And you can just simply toggle between different metrics to see the report dynamically changed very quickly, right? So let me look at the cumulative cases, and there you go. The cumulative cases we looked at earlier on in the video, around 28K for Australia. Again, I have a filter on the page level restricting it to Australia. I'm looking at the cumulative cases here, and then if I want to look at the cumulative deaths, I can just toggle between different parameters to look at the 7-day moving average, daily new cases. Okay, so and then the cumulative deaths. So that way you can achieve this functionality. You can bring in the field parameter to toggle between different metrics. Let's say if you want to look at different metrics in a single report, you can create a field parameter and then you can bring it in the report and then toggle or switch between different metrics to look at the different views of the report. Okay, so and we have seen this in action for COVID-19 data model. Well, let's talk a bit about composite model. So it allows the report to have 2 or more data connections from different source groups. So imagine these source groups can be 1 or more direct query connections and then import connection, or 2 or more direct query connections itself, or any combination thereof. So commonly in many scenarios, the fact table, which usually contains the primary transactional data, set up as a direct query connection to access the most up-to-date information directly from the database. So by using the direct query for large fact tables, imagine you can avoid loading massive data into the Power BI memory cache. It improves the performance, especially when dealing with very large data sets for the fact tables, right? And usually the dimension tables that provide the context to the fact data can be imported into the model memory for quicker access and calculations. So that's usually the way, or commonly the fact table is set up that way, as direct query connection, and then the dimensions can be imported into the memory as import mode. Okay, so with composite models also you can establish many-to-many relationships without even creating a bridge table itself. Okay, so that is also possible. So just keep in mind, what from exam point of view, what is the composite model when you create report, how you can leverage the composite model capabilities to have different data connections from different source groups. Okay, let's talk a bit about large semantic model storage format. So Power BI semantic models that we're building can store data in a highly compressed in-memory cache for optimized query performance, enabling fast user interactivity. With premium capacities, large semantic models beyond the default limit can enable with the large semantic model storage format setting. So we'll quickly see how we can enable this setting, and it's usually required for semantic models to grow beyond let's say 10 gigs, right? And once you enable this capability in Fabric, the semantic model size is limited by the premium capacity size itself, or the maximum size set by the administrator itself. Okay, the large semantic models can be enabled for all premium SKUs, embedded SKUs, and with premium per user as well. So let's quickly see how we can enable this setting in Fabric portal. So here I'm in Fabric portal. Click on the settings and move on to Power BI settings, and click on semantic models, and there you can see different settings for your COVID-19 model. In our case here, if you just scroll down, you can see there are a lot of settings available. And one thing to quickly note, under server settings you can see the connection string. So I talked about XMLA endpoint, so this is the connection string that you need in case if you need to establish connection to your data model from Power BI desktop or even Excel itself. And if you just scroll down there, you can see large semantic model storage format setting, right? So currently it's switched off. It even says the size of the COVID-19 semantic model is just 2 MB, and for most premium capacities, using large semantic model storage format can improve performance. So you can enable this in case if you have a large semantic model, the size probably more than 10 gigs, you can enable this for better performance. All you need to do is have the required permissions to enable this setting. Okay, with this we come to the end of this video. Thank you very much for watching, and let's have a quick summary. So in this video we looked at how you can design your semantic model by establishing the relationships, creating a new semantic model, and then establishing the relationships between your fact and dimension tables. Okay, so and then we also looked at how you can create DAX calculations leveraging different functions like windowing functions, iterator functions, and information functions and variables. So we saw that in action in COVID-19 data model. and then we looked at the calculation groups, and then the dynamic format strings, and then the field parameters, and then we saw those capabilities in action in COVID-19 data model. And then we talked a bit about composite models in Power BI report, and we also looked at the large semantic model storage format, how we can enable that in Power BI settings in Fabric in case if you have a large semantic model to leverage that setting and improve the performance itself. I hope you found this video helpful in your journey to achieve DP-600 exam. Please consider subscribing if you're new to this channel and to be notified with the rest of the videos in this course. And if you haven't looked at my previous videos in this course, I would encourage you to go through the previous videos, the first couple of modules in this course. The whole idea of this course is to give you hands-on with the real-world dataset, which is COVID-19 dataset. I'll see you in the next one. Thank you. Hi everyone, welcome back to the channel and welcome back to the brand new course on DP-600 exam, Microsoft Fabric with real-world project. So we are in module 3, implementing and managing semantic models. And in the previous video, we looked at designing and building semantic models. We will quickly look at the roadmap shortly, where we are in the entire course roadmap. So before that, if you don't know me, this is Sheikh Mohammed. I'm an Azure Solutions Architect and Fabric Analytics Engineer. I have close to 15 plus years of work experience. So let's get started. So let's quickly look at the roadmap. So we are building a 10-part video series, and the goal of this course is to provide you with hands-on as much as possible with the real-world dataset, which is COVID-19 dataset. And if you haven't looked at my previous videos, the couple of modules where we looked at the COVID-19 dataset overview, then we looked at how you can plan, implement, and manage your data analytics environment. Then we looked at managing analytics development lifecycle, then the data ingestion part, and how you can transform the data and implement start schema with type 1 and type 2 SCDs. And then we looked at performance optimization in detail. And then in the module 3, first part of the video, we looked at how we can design and build your semantic models. So let's get started. And if you're new to this channel, so we have a Google Classroom community. So you can join there and access all of the resources that we were sharing throughout the course. So be it the PySpark notebooks, the dataset links, or the notes, then study guide, everything is there in the Google community Classroom. So you can access the Classroom, and under the classwork, you can access all of the resources that I've been sharing right from the start of this course. So in this video, we will be covering the dynamic row level security and object level security, how we can secure your semantic models by implementing row level security and object level security. Then we will look at how we can leverage some of the tools in Power BI and third-party tools to implement some performance improvements in your queries, DAX queries, and report visuals. So before that, we will talk about how we can identify the problem areas, and then how we can optimize further. And we'll also talk about a couple of third-party tools, which is DAX Studio, how we can improve the DAX performance using DAX Studio. And then we will also look at Tabular Editor 3 and how we can optimize your semantic model using the BPA, which is Best Practice Analyzer. How we can leverage that to optimize your semantic models in Tabular Editor 3 as well. And finally, we'll also look at how we can implement incremental refresh for your semantic models, which is quite crucial to improve the performance and make it faster, so without refreshing the entire historical data. Okay, let's get started. So let's talk about dynamic RLS and OLS. So as usual, I'm providing a matrix here with different aspects to better understand with respect to each and every feature. It will be easy to understand, so that's the idea. So we will talk a bit about what is RLS and OLS, and then we'll talk about the primary use cases and the from implementation point of view, how we can implement it, and performance impact and so on. So the purpose of RLS and OLS, in first place, if you talk about row level security, you are trying to restrict access to specific rows within a data set. Okay, So we will talk about the use case as well shortly, and I'll show you from our COVID-19 model as well how you can implement um, such a row level security for your data set as well. And object level security, in general, we will try to restrict access to specific tables or columns in the data set. Okay, it's not at the row level, but instead it will be at the table level or column level. You can restrict the access in a data set. Okay, and the primary use case, so we will be, for RLS, will be enforcing data visibility by user role. So you can think of it as a regional restrictions. In our COVID-19 model also, you can restrict, you can have a role like the Australia users or any specific region roles, and then you can add users to that role and then apply the RLS for that particular role. So it is, the context is at the role level. So you need to create a role and then apply the required role level restrictions. That's how you can enforce the row level security. Okay, but on the other side, on the object level security, we will be hiding, let's say, some sensitive data elements or metadata such as the salary information for employee and so on. Okay, an implementation point of view, you can use the Fabric portal itself to implement the row level security. I will show you how you can implement it shortly. And all you need is the DAX expressions. Once you create the role, you need to define or create those expressions, DAX expressions, to filter and apply the row level security. But in case of object level security, you may need third-party tool like Tabular Editor 3, and it needs to be applied at the model level, typically using the tools like Tabular Editor. So we will also see that how we can implement OLS using the Tabular Editor 3. And security granularity aspect, it's applied at the row level within the tables as we discussed, and OLS, it's going to be applied at the object level, be it table or column. Okay, so performance impact, RLS, it's going to be minimum. The impact would be minimal when filters are efficient. But on the OLS side, yeah, it's going to be minimal to moderate depending on the data model complexity. Okay? So it all depends on the data model complexity. And common applications you can think of, as I already mentioned, the row level security. You can create role-based reporting and dashboards, and let's say, for example, sales by region, right? So for that, you are creating a separate role, and then you're doing the reporting and building dashboards by region. So for that, you're creating a separate role and applying the region level restrictions. Okay, so that we will quickly see in the data model. And on the object level security side, imagine HR data restrictions, for example, the data governance and compliance scenarios. To comply with that, you'll be hiding some of the columns or table itself for HR department. Okay, so you can think of such a scenario. Okay, and tool requirement, as I mentioned, you can directly apply the row level security in Fabric portal, or even you can use Power BI or Tabular Editor. But OLS, you need to have that XML endpoint access to be able to connect to the data model in Tabular Editor to use that tool and apply the object level security. So that is at a high level how you can secure your semantic models to apply the row level security and object level security. And quickly we will see both of these in action. And just to quickly talk about the dynamic RLS, there are a couple of DAX functions that you can leverage to dynamically pull the information. One is the username or user principal name. You can utilize those couple of DAX functions within your dataset by defining the expressions in Power BI Desktop, and with that you'll be pulling the information such as username in the format domain/user, and then you can define the row level security based on what is being returned once you have this function, your expression. Similarly, user principal name will return the user in the format user at the rate of the domain conteso.com. So you can also leverage this functions to dynamically look at the user information and then apply the restrictions accordingly as well. Let's quickly look at the RLS and OLS in action. So to look at how we can implement the RLS, you can click on manage roles, and you can see I have already defined a role called Australia_users, and then we are going to apply the restriction at the row level. Okay, so here we have the list of tables what we have in the data model. Okay, so here if you go to dim location, I have applied a filter on column countries and territories, which is equal to Australia, as simple as that. And you can also look at the DAX expression by switching to the DAX view and the filter that is applied to filter the data for this role. And once you have the role defined, you can assign different users or groups to this particular role. Then I think the RLS would be enforced for those users or groups. Okay, that's the idea. And let me jump on to the tabular editor. So let me open tabular editor. I'm having a separate virtual machine since I'm using Mac. I'm moving on to virtual machine that I've deployed to demonstrate the functionalities or capabilities in tabular editor and DAX Studio. So here I'm in tabular editor. Version is 3.17. Okay, so I'll share the link in the Google Classroom community. You can download and install this third-party tool to leverage all of these functionalities. So you need to have the XMLA endpoint access to be able to connect to this, connect to the data model. And the connection string looks like this. You can look at my previous video how we are pulling this connection string from Fabric model settings, and we're trying to connect to the COVID-19 data model here. Okay, so well, let me. So once you're here in the Explorer, so you can expand roles and you can see the role that we have already created, and under security you can see row level security and table permissions. So you can see RLS is enabled for out of 3 tables, 1 we have enabled it on dim location already, as you can see here. And to apply the object level security, all you need to do is you need to expand the table permissions, and you can see OLS is not enabled at the moment. You can't apply from within the Fabric portal experience. You have to utilize tabular editor 3 to enforce OLS. And then what you can do is here you can see the fact table and the dimension tables here, and the setting is default. And if you look at the drop down, you have a couple of options, none or read, right? So if you set it to none, then I think the OLS would be enforced. Okay, and read, then the table would be visible to the role itself. Okay, so if I need to hide the dim location itself, then I need to set it to none. Then the object level security would be applied and enforced to this particular role itself. Okay, so that's how you can do it to implement RLS and OLS. Okay, and I think if you need to apply, let's say, the OLS at the column level for a particular table, then what you need to do. So then what you have to do is navigate to a table, let's say dim location. Okay, click on dim location. Then under properties, just scroll down. Under security, you can see object level security, row level security. So expand object level security. Okay, so you can see here, okay, we set it as none. So if I come back to Australia users role and then switch, let's say dim location back to read or default, okay, and come back to dim location table itself. Okay, so what we have seen here is, if I can just quickly expand it, so the object level security is applied. So the table is the dim location table is visible to the Australia users role itself. And what if you need to hide any of the column? Let's say I wanted to hide continent column in this particular dimension. Click on that particular column, scroll down under security, you can see object level security, and you can see the role is there, Australia_users, and all you have to do is apply the setting to click on it and set it to none. So this will enforce the object level security to hide a specific column within a particular table. That's how you can do this or implement it with the help of this tabular editor 3. Okay, now let's talk about how we can monitor your semantic model performance. So there are quite a few tools we'll be talking about, and in Power BI Desktop you can find out how each of your report elements, such as visuals or DAX formulas, are performing. So there is a way you can do it by using the performance analyzer. You can see and record the logs that measure how each of your report elements performs when users interact with them, and when the rendering happens inside the report, and which aspects of their performance are most or least resource intensive. Okay, so we'll quickly look at it in Power BI Desktop, how you can leverage this performance analyzer, and we will quickly look at workflow when you're trying to troubleshoot any poor performing Power BI reports. So let me jump on to the virtual machine where I have Power BI Desktop. Already loaded the model. So here you can see I'm in Power BI Desktop. So under view, you can see there is an option to assess your report's performance and identify areas for improvement, performance analyzer. So once you click on that, you can start your recording. Okay, and then you can work with your report to see different metrics inside the performance analyzer. Here I have a report based on different parameters. So looking at 7-day average moving daily cases for Australia country, and here you can see how much time it is taking to render the visual. So here the storage mode is mixed, which is a composite model what I have here. So how much time it is taking for the DAX query to be processed and direct query to be processed, and other information you can look at it. Okay, and you can always copy this query and take it to the DAX Studio to fine-tune the query further, DAX query further. We'll also look at it shortly. Okay, and if you switch, let's say, to a different parameter to daily new cases, okay, then you can see the slicer action is recorded here, and then further actions, what you're trying to do in the report, will be rendered. Okay. Let's also quickly look at the cumulative deaths. I need to look at the cumulative deaths. You can see the report changed dynamically, and you can also see the recorded information to see how much time it took to render the result for the DAX query and direct query. Okay. So that's the idea. So once we have the information from performance analyzer, let's quickly look at the workflow. A 3-step process, I would say, to run your performance analyzer in Power BI Desktop and copy the DAX query from the performance analyzer, the second step, and then you can start troubleshooting your DAX query in DAX Studio. So this image comes from an article by Nicola, okay, from Data Mozart, as a part of optimizing or improving the DAX performance using DAX Studio. So we looked at a quick 3-step process. Once you look at the information from performance analyzer, you can take it to the DAX Studio. So you can load the poor performing DAX query identified using performance analyzer into the DAX Studio for further analysis. Okay, so we will look at the trace analysis as well, how you can look at the query plan and server timings with the example from Nicola article, which is quite useful here. Okay, and we'll also look at the Vertipack analyzer, how we can look at some useful information about storage structures for a data model in Power BI and analysis services. It is actually fully integrated into the metrics feature of DAX Studio, so we'll also have a look at that. And this article is really useful to showcase a very simple example from Nicola. So here I just want to quickly show you he is demonstrating a sample measure called total big orders bad, okay, with the calculate function, and then he is trying to count the big orders, and he called it as bad because this is taking a bit of time when looking at the performance in performance analyzer, and how we are improving the performance by fine-tuning this particular measure. Okay, so he's using filter function, and he's passing the table name and then the column information, which is greater than 10, and we call it as total big orders bad. Okay, if I just quickly scroll down, he's using the performance analyzer as I just mentioned, and he's trying to look at the time it takes to render the information. Okay, the DAX query, you can say it's taking around 11 seconds to render the table. We will come back to his example. So before that, let me show you how you can copy the query and take it to the DAX Studio and leverage some of the metrics to fine-tune the query itself. So let me open the Power BI desktop, and we have just looked at a visual. Let's say, if I wanted to copy this query, cumulative deaths by date, if I want to copy the query, I copied the query, and then here is the DAX Studio tool. I will share the link in the Google community again. You can download the tool. I'm just trying to connect to the data model and then choosing the COVID-19 data model in DAX Studio and this. Well, the connection is established, and once you have the query copied from Performance Analyzer, you can copy it here. And since it is of composite model, whether you need to copy both the direct query and DAX query or DAX query only, so I'm going with DAX query only. And that's how you can take the query to the DAX Studio to look at different metrics. Once you have the query copied onto the DAX Studio here, there are quite a lot of information you can look at, like the query plan. You can enable it, and then you can enable the server timings. Okay, so we will quickly look at what are all the information that you can look at under server timings, and then how we can optimize it using a simple example from Nicola in the article that I've just shown. So, coming back to this article, you can see Nicola, for that simple measure, we copied the query, okay, and we put it on in DAX Studio, and we enabled query plan and server timings, and you can see there are quite a lot of metrics that you can look at here. So the total query time, it takes close to 11 seconds for that query, and then the storage engine total CPU time, and the number of storage engine queries, and storage engine versus formula engine time. So we're not going to get into the intricacies of each and every metric, but you can look at the total query time and then the number of storage engine queries, and just keep in mind. Okay, and if I just quickly scroll down, he's defining total big O as good now. What he's trying to do is using the filter function in the total big O as bad. Okay, the filter function, he's also passing the entire table and then the column information with the filter. So that is kind of compute intensive. Okay, so you can see the storage engine queries are quite a lot. Okay, and here he's trying to replace the filter function with keep filters without passing the complete table. He's just passing the column sales amount with the filter greater than 500, and he's creating this new measure to test it out. So here he's producing two different reports, one with total big O as bad and total big O as good. And he's looking at the performance analyzer and the timing it takes to render both the visuals, right? You can see there is a significant improvement when the DAX query is executed. Okay, so here you can see this is the bad version, which is taking close to 11 seconds, but with the version that he is trying to optimize, it's taking very little time. Okay, so it's about 1/10 of a second that you can see here to execute. This is one simple example just to quickly showcase how you can leverage Performance Analyzer and DAX Studio tools to look at the timing it takes to render the visual, then probably fine tune your DAX queries further, and then see if the performance has been improved or not. Okay, so here I think he's also showcasing he's copying the good query, DAX query, and then taking it to DAX Studio and looking at the information, the server timings, and you can see the storage engine queries has come down significantly from 1099 to 3. Okay, so that's what the claim is from Nicola. So this is just for demonstration purposes. I'll share the link to go through this very simple example. thanks to Nicola for this simple example to demonstrate. Okay, let's quickly look at how you can leverage VertiPack Analyzer to look at the data model structure and how you can optimize it further, right? So here I'm in DAX Studio. If I move on to Advanced tab, you can view the metrics. Click on View Metrics. That will load the VertiPack Analyzer for you with all the required information regarding your data model. And just minimize this. It will take a bit of time to load the model metrics. So here you can look at all of the table level information, the cardinality, what is the total size it takes in memory, and the data type information, other information. So here you have the data. We have a couple of dimension, time intelligence that we have created, and the fact table. You can look at the cardinality, total size, and the data and the other information, encoding and other information. If you can expand a particular table, you can drill down to the column level to look at the size information, cardinality, and other information. Okay, and if you find out any unwanted columns that is consuming memory or size, you can get rid of those redundant columns as well. But for that to happen, you need to try and identify and look at this VertiPack Analyzer to assess the size it takes for each and every column in your fact table or the dimension table. Okay, so here you can see the data type for each and every column. The daily case is date key. So I think there are opportunities to get rid of the location keys in the fact table. I'll talk a bit about the best practices analyzer, and that will capture this information to get rid of the redundant columns. In fact table, you don't need the keys at all. You can hide the keys, okay, so in the data model, and then have it only in the underlying table. So there are opportunities to hide it in the data model, all the key information that will reduce some of the memory footprint itself. Okay, so you can also look at the different dimension information as well. Okay, and then act accordingly. And you can also look at the column information, as we have just seen, the relationships that we have established, the partition information, and the overall summary with respect to the overall size in memory, how many tables you have in column, and the summarized information for your data model. In our case, it's COVID-19 model, so we have 4 tables and 27 columns. This is the XML endpoint that we're talking about, and you can fine-tune your model further using VertiPack Analyzer. Well, let's talk a bit about how you can optimize your semantic model by using tabular editor itself. So we're going to quickly look at BPA in short, which is best practice analyzer, how you can leverage this tool in tabular editor to fine-tune your semantic model itself. So BPA in tabular editor 3, in a nutshell, you can think of it as a tool that scans your model for any issues and provides recommendations to help users enforce best practices. So BPA relies heavily on rules. Okay, so I'll quickly show you how you can import the predefined rules, which is already available. It relies heavily on rules, so each rule belongs to a certain category, such as DAX expressions performance, as I mentioned. So let us jump over to tabular editor and see how we can import the predefined set of rules. You can also create custom rules, but we will quickly look at what are all the predefined rules that are available already. So let me jump over to this blog by Michael from Microsoft. So this article talks about best practice rules to improve your model performance. Okay, so here what I wanted to show you quickly, so there are different categories of rules that you can see here. DAX expressions, there are several rules, then error prevention, formatting, maintenance, naming conventions, performance, and so on. Okay, so how we can load the rules in the tabular editor 3. So there are a couple of ways you can do that. So here they're providing a script for you to connect to the GitHub and then pull the bpa rules.json file, okay, and then import it into your tabular editor instance with the help of advanced scripting window. But in case if there is any issue in executing the script, you can always have a less fancy method. I'll quickly show you how we can do that as well by manually downloading the bpa rules.json file, and then you can paste it in the tabular editor folder. So let's have a quick look at that. Let me jump over to the tabular editor instance. So here I'm in tabular editor. I have already connected to the model, as you can see here. Okay, so under tools, you can always manage the bpa rules, but when you're installing the tabular editor for the very first time, you'll not be able to see any rules running on top of your model to provide the recommendations itself. So in that case, you have to first make sure you bring in the predefined set of rules. Okay, so you can go to the scripting and then you can copy that code. So I will provide the link in the description as well as in the Google Classroom community. You can go through that script and then try it out. If there is any issue, then what you can do is you can go to run command, run, and then just type in local app data, okay, and click on that. That will take you to the app data local. There you can see a tabular editor 3 folder. So you need to bring in the bpa rules.json file and then paste it here. And I think you can navigate to that GitHub link just to quickly show you. So the link will be there in the article itself. So if you go there, you can download the bpa rules.json file and then paste it in the location itself. Okay, so once you paste that, okay, then you are good to go. So come back to the tabular editor, and I think in view, if the best practice analyzer is not visible, just go to view and click on best practice analyzer. That will take you to the perspective itself. Okay, so here it already scanned my data model and then providing some of the suggestions at different categories like formatting, DAX expressions, and maintenance and performance point of view. So these are all the recommendations I'm getting already. So we can have a look at it quickly. Some of the recommendations once the bpa rules ran on top of my model and analyzed and provided some recommendations. Okay, so here you can see with respect to DAX expressions, it's saying column references should be fully qualified. If you just hover over, you can see you can provide a fully qualified name instead of providing only the column name. So that kind of, even from here you can go to the object. That will take you to the object itself, and you can see here the filter expression we have provided to restrict the country to Australia. So it is suggesting to provide a fully qualified name. Okay, the column references should be a fully qualified name. Okay, and with respect to formatting, maybe we can have a look at a few things, not everything, but you can see here formatting, it's asking us to hide some of the fact table columns. What are all those columns? In the fact table COVID gold aggregated KPIs, the daily cases, daily deaths, these are all not required because we are already building a measure on top of these columns. So we'll be using the measure to generate the report. So these columns are not required, and that's why BP is recommending us to hide these columns, fact table columns itself, like daily cases and daily deaths. And you can see it's also asking us to hide some of the foreign keys, which is not required, to be exposed in the model, like the date key, location key. These are all not required, at the data model level. So the recommendation is to just hide it in the data model. If I can come back to, just to validate that, I can come back to the data model. Here you can see nothing is hidden, everything is exposed. The daily cases, daily dates, location key, date key, everything. So I think it's hiding it is very simple. All you have to do is click on the 3 dots and then hide in report view. That's it. So it will hide the column in the data model for you. Okay, hide it in the report view. That's it. So Those are all the recommendations you get from the best practice analyzer, which is quite handy when you're trying to optimize your semantic model. Okay, so these are all some of the examples that you can see in real time for our COVID-19 model. It's recommending to hide some fact table columns, hide foreign keys, and mark some primary keys. And there are several recommendations which you can action on it to improvise and improve your model further, right? And you can go through that. So if you're following along in this course, let me know how it works for you. Okay, so if you're following along with the COVID-19 dataset, okay. And there are some performance related recommendations as well, you can see here. So date calendar table should be marked as date table. Okay, so you can action on that as well. And what else we're getting? Model should have a date table. Do not use floating point data types. There are 6 objects. If you can expand that. So these are all the measures we created, not the measures, the actual calculated columns. It's saying do not use floating point data types for these with respect to the performance. So you can always go through this, and once you action on it, you can come back and rerun the BPA to see if you're good with your data model or if you need to fine tune further. Okay, so this will be very handy when you're trying to optimize your semantic model using Tabular Editor 3. Okay, so let's talk about the final topic, which is implementing incremental refresh for your semantic models. So why you need to implement incremental refresh for your semantic model. So incremental refresh and real-time data for semantic models provide efficient ways to handle dynamic data and improve model refresh performance. So imagine for most of the models, one or more tables contain transactional data, right? So your fact table that changes often and can grow exponentially as well, like a fact table, as I mentioned, in the relational table or in your star schema. So an incremental refresh policy to partition the table, refreshing only the most recent import partitions, can significantly reduce the amount of data that has to be refreshed. So I think there is no point of refreshing the entire historical data. It will be very compute intensive and resource intensive as well. So you need to figure out a way to incrementally set up the refresh policy to refresh the partition that is only required. So imagine that you are having the whole historical data right from 2020, let's say, the last 4 years or 4 or 5 years, and you are getting data on daily basis into your data model. And I think all you can do is, if there are corrections to the previous month, you can put an incremental refresh policy to refresh the current month till date, then along with the previous month. And that way you can set up the incremental refresh policy to refresh only the current month plus the previous month partitions. I hope imagining we are setting up the partitions on monthly basis. In that way we can only refresh the required partitions to speed up the process, right? And it will be immediately reflecting in the cube as well. So what are the benefits with respect to the incremental refresh for your semantic models? It requires very few refresh cycles for fast changing data that are needed in your data model and in your report quickly. And refreshes, as I mentioned, are very faster because we are only targeting the partition that requires refresh in your data model, not the entire historical data, okay, as such. So only the most recent data that has changed needs to be refreshed, not the entire historical data. Okay, the refreshers are more reliable, meaning long-running connections to volatile data sources aren't necessary. Queries to source data run much faster, reducing potential for network problems to interfere. And the resource consumption is also reduced. So meaning the less data we need to refresh reduces the overall consumption of memory and other resources in both Power BI and even in the data source systems as well. So that's at a high level why you require to implement incremental refresh policy for your semantic models, to target only the partitions that needs to be refreshed that are changing, right? So I gave an example to you in case if you are having a daily changing data, and there could be corrections in the previous month that needs to be reported. So in such a case, you can target only a couple of months partition, leaving behind all the historical data to speed up the entire process and bring your data quickly into the report as well. And that's a wrap for this video. Thank you for watching, and a quick summary what we have covered in this video. So we looked at how you can implement dynamic RLS and OLS to secure your semantic models. Then we looked at the performance analyzer in Power BI, how you can look at the metrics and copy the query. And we looked at a quick 3-step workflow to pull the information from performance analyzer and then copy it to your DAX Studio tool to further analyze the query based on different metrics that you can enable. Like you can look at the query plan, you can look at the server metrics, server timings, and then you can act on the DAX query to fine tune it further, so to optimize the DAX query in DAX Studio. And we looked at a quick example by Nicole as well in an article that I'll be sharing in the Google community and in this description. You can have a look at that as well, how he fine-tuned a simple DAX query and looked at both the old world and new world as well. And we also had a look at the incremental refresh policy, why you need incremental refresh in your semantic model to speed up the entire process and reflect the data quickly in your reports as well. Okay? And we also had a look at the tabular editor tool. We talked about the BPA function, which is best practice analyzer, to scan your model for any issues and then provide the recommendations and act on those recommendations to optimize your semantic model in tabular editor. So those are the topics we covered, and I hope you found this video really helpful. And if you haven't watched my previous videos in this course, I would encourage you to watch all of the previous videos to gain an in-depth understanding with the hands-on as well. So because the whole idea of this course is to provide you with hands-on using the real-world dataset, which is COVID-19 dataset. So we are nearing completion of this course with one more video that will be producing shortly to query and analyze the data using SQL. With that, we'll be wrapping up the entire course, and I will see you in the next one. Thank you. Hi everyone, welcome back to the channel and welcome back to the brand new course on DP-600 Microsoft Fabric with real world project. So we are in the final module to perform EDA and querying data using T-SQL. And if you don't know me, this is Sheikh Mohammed. I'm an Azure Solutions Architect and Fabric Analytics Engineer. So let's dive into the roadmap. So we are in video 9, wherein we will look at how we can perform exploratory data analytics and how we can query data extensively using T-SQL. If you're new to this course, I would recommend you to watch all of the previous videos where we talked about the COVID-19 dataset overview and planning, implementing, and managing your data analytics environment, managing your analytics development lifecycle, data ingestion, transformation, and implementing star schema with type 1 and type 2 SCDs, and performance optimization. And we talked in detail about designing and building semantic models and how we can optimize your enterprise scale semantic models as well. And I think we are in final phase of the course. And if you're not sure about Google Classroom community, I will provide the link in the description, wherein I've shared all the artifacts that we have been going through in this course. You can access all of the resources in Google Classroom community as well. And I've just spoken about Google Classroom community, so please find the link in the description, join the community, access all of the resources there. Let's dive into what we will cover in this video right away. So in this video, we'll cover extensive EDA with the COVID-19 dataset that we have been going through. So we will query the data using Transact SQL, T-SQL, and COVID-19 tables. So we will try and explore common table expressions, CTE, how we can utilize CTE, then how you can aggregate and group your data, then filters, then how you can do some trend analysis over time, and how you can do regional analysis with respect to the COVID-19 cases, and so on and so forth. That's going to be the agenda for this video, and it's going to be a complete hands-on in the notebook. And then we will quickly look at the visual query editor experience as well, but it is recommended for mostly low code and no code experience. And I would probably touch upon in brief, will not get into detail, because we will focus more on T-SQL experience. That is, in fact, I believe, which is the much needed skill there. The visual query editor experience, we can just have a quick look and then we can move on. Well, here I'm in Fabric portal. I'm in DP-600 codes workspace. So let's navigate to, let me want to list view, bring up the notebook. So what we're trying to do here is we will try to use the notebook experience, and you can use different programming language of your choice. And if you can see here, what I've chosen is you can use PySpark, Spark Scala, SQL, Spark SQL, and Spark R. But we also have this experience provided by Microsoft, which is T-SQL analytics experience. Okay, so a couple of ways you can query the data, your lakehouse data. So if I move back to our COVID lakehouse, just to quickly show you. So what you can do is you can navigate to the SQL analytics endpoint and then start querying your data from there. Okay, so that is one way you can query your data using T-SQL. If I switch to SQL analytics endpoint, okay, we're getting some error. Let me go back to home and then come back to lakehouse. And yeah, we are in the SQL analytics endpoint, not in the lakehouse, the endpoint of the lakehouse. And here you can see, you can start writing the SQL queries. You can write a new SQL query, or if you want a low code experience, you can write a visual query. We will have a quick look at that as well. And there is this third option, which we are going to go through in this demo. I built a notebook with the list of T-SQL queries, and that will help you to have a different notebook experience altogether. Okay, so let's navigate back to the notebook, and you can see the chosen language is T-SQL under T-SQL analytics. Okay, let's run through this notebook. I'll take you through different cells where we have the predefined code already. We'll go through each and every code blocks to better understand how we can leverage T-SQL experience with the SQL endpoint. Okay, so here you can see I've attached, if you come back to the all sources, you can see the SQL analytics endpoint from COVID Lakehouse has been attached already. Okay, and what I'm trying to do is I've written queries on top of the COVID Gold aggregated KPIs, which is our fact table for the COVID-19 dataset that we have built in the previous videos. We are going to perform some queries on top of the fact table and perform some required joins to the dimensions as well. See how the data looks like, okay, using the T-SQL experience. Let me minimize this and we'll just run through the notebook. So as a part of basic data exploration, so I'm just trying to look at the fact table with top 10. There you can see the result set, and there are few things that you can note in this result set. So you can see the table view with the required information, what we have, the date keys, location keys, daily cases, daily dates, and we computed the rolling average, 7-day rolling average cases, dates, and then cumulative cases and dates and the load date. And you can have a couple of options here to look at the charts. You can produce some charts, and then you can customize the charts, and you can save it as a table, and you can download it as CSV, JSON, XML files, and also you can inspect the data as well. So all of the columns, you can look at the missing data, unique information with respect to each and every column, so that you can quickly inspect from your result set right here. Okay, so just click on that. Let's move on. And what we're trying to do here is we're just trying to count the total number of records to check the dataset size from the fact table, which in fact we know it's around 61,833 records. We are using count of star. This is a pretty simple function to count the number of records from the fact table itself. Okay, so those are the basic data exploration queries that you can write, and you can also write the markdowns, in your notebook experience, how you write the PySpark code. So all we have here is the T-SQL experience, where we don't need to use the magic commands to write the SQL queries. You can right away write the SQL queries, T-SQL queries, because we are already in that environment. Okay, so no need to use the magic commands like you do in the PySpark notebooks. And let's try and look at these summary statistics, how we can summarize the key metrics. So we are trying to calculate the total cumulative cases and deaths worldwide. I'm using the sum function on top of cumulative cases and deaths, then aliasing it as total cumulative cases and total cumulative deaths. And there you can see the total across the world, and the data set we have is only for 2020. Okay, so that data set 61,833 records is from January till December 2020. Okay, and the total cumulative cases and deaths are these. And you can, as I mentioned, have a look at the chart view to better understand. You can also customize the charts, as I mentioned. Click on customize chart and you can change the chart types, whatever you want. The keys, you can even provide a couple of keys, not only the cumulative cases. I wanted to look at the deaths as well in the bar chart. You can add that. Okay, and the aggregation type as average is also given, and then you can apply, have a look at it. And I think the values also you can apply both. There you can see the total cumulative cases, total cumulative deaths. Okay, the overall across the world. So, and what I'm trying to do here is we'll try to get the average daily cases and deaths, and simply we are using the average function to get the average daily cases and deaths. This is across the world, not specific to any region. We will get to some complex queries shortly. Stick to the video to know more about some complex T-SQL queries as well. And I'll make sure to share this notebook in the Google Classroom community. So if you're not in the community yet, please feel free to join the community and access all of the resources there. Okay. So let's try and analyze some trends over time. Here what I'm trying to do is I'm trying to aggregate the daily cases and daily deaths by month to see how the trends look like over the time. So in our case, it's going to be from January till December, month on month, how the cases and deaths look like. For that, I'm using a format and then the date key from the fact table, and we're formatting it in year and month format like this, and we call it as year month, and then we are calling the sum function daily cases and deaths, and the total cases and deaths are computed from the fact table, and we are doing the grouping based on this format, the year and month format. So that will help me to get the month level groupings, cases and deaths, and then I'm ordering it by year month. And that's how the result set looks like. As you can see here, from January till December, how the cases looks like, the total number of cases and deaths. As you can see, the January looks minimal. Then as the month progresses, you can see the cases increased significantly and the deaths as well. And again, if you want to have a look at this in the chart view, so I have produced a chart here, and visualizing this is much better than looking at the table, right? So here you can see the total number of cases and deaths in the x-axis and the year month here. So you can see the significant month would be the November month, right? So the total cases you can see here around 9 million, close to 10 million total cases, and the deaths reported were around 271,000. Okay, so that's the significant month in that particular year 2020 across the world. This is across the world. And then the cases dropped to 500,000 in December, which is quite significant, that we can see in the chart here, right? We can always cross-check the data as well. Okay, so it peaked till November. So what I can see from the trend here is it peaked till November, the cases and even deaths, and then significantly reduced during December month. This trend is across the world, and you can further drill down to a specific country or region or a continent, and then you can look at the metrics accordingly. So that will provide some insights to you. So Then what we are trying to do is we are trying to calculate the 7-day rolling average of daily cases. This time I'm going to compute this only for a specific country, which is Australia. So that will help us to better understand how the rolling average looks like for a particular country, which is Australia here. And with respect to the T-SQL query, so what I'm trying to do here is I'm aliasing the fact table as KPIs, and then I'm calling the date key, daily cases, and then I'm calling the average function, and then I'm passing the daily cases from the fact table, and then I'm having a window here. So if you remember in our previous videos in our PySpark notebook, when we transformed the data, we used inbuilt functions from PySpark APIs to specify the windows, 7-day window, and then we passed that window and then partition ordered by, and then we computed the 7-day moving average and stored it in the fact table. But here just to show you how we can do it in the T-SQL experience, all you have to do is you can use the over function, over keyword, and then we are partitioning the data by location key and then ordering it by date key. And the rows between 6 preceding and the current row, this keywords will help me to go back in time and define the window, the 7-day moving average window for this particular data set. Okay, so the rows between 6 preceding and current row will help me to define the window, 7-day window moving average, and then we are partitioning the data based on every location. Okay, and then we are ordering the data by date key. Okay, so and then we are computing the average across those partitions. Okay, that's how we are doing it, and then we are aliasing it as rolling average 7 days, and then we are performing required joins to the dim location. Then we are aliasing it as lock on the basis of location key, and then I'm filtering the location to only Australia, and then I'm finally ordering it by date key. There you have the result set for Australia. You can see here. So the date keys are ordered, as you can see here. So initially we don't have any cases at all. I just scroll down, sorry about it, close it. So there you can see from January 25th, 1 new cases, and then the 7-day moving average got computed as we have defined in the T-SQL. And to just cross check with the already computed, because we have this as a column already in the fact table, so maybe we can do a quick cross check against the fact table column itself, whether the data that we computed here with T-SQL is right or wrong. Okay, so you can also have a look at the chart here. If I can move on to the chart view, so there you can see the trend. So we discussed about this trend in the previous videos, especially for Australia. Around March towards April, there is a peak in the cases, and then it's reduced, and then again in August there was a peak. That's what we analyzed in the previous videos, and this is what the data is suggesting for Australia. A couple of peak cases during around April and August, and we also validated the data against some third-party websites as well. Okay, especially for 2020 year for Australia. And we can cross-check this data against, so the fact table, as I mentioned, we already have this average 7-day cases. So what I'm trying to do here is writing a query on the fact table, joining with the location, and then filtering by Australia, and then ordering it by date key. That's it. Okay, because we have already computed and then stored the information. If I look at the chart, and it's exactly the same, so that confirms or validates, okay, so what we have computed with T-SQL query is all right. Okay, so here you can see the chart again. So that's the trend for Australia, the rolling 7-day average cases. Okay, and let's move on. So let us do some regional analysis, to get a comprehensive view of the COVID-19 impact by every country. So for that, what I'm trying to do is a very simple query. So again, we are performing the required joins to the location, and then we are grouping it by countries and territories. and all we're trying to do is we are using sum function and average function on top of the required columns, and then the max function on cumulative cases and deaths. That's it. That gives me a comprehensive view of and then we are ordering it by the total daily cases, right? So that tells me Brazil is the top country that has most number of cases in that particular timeline at least. So you can also look at it in a chart view. So you can see from the bar chart, Brazil is significant, followed by, I think it's a bit hard to read, so maybe if you go back to the table, you can see Brazil being the significant, with the total cases, okay, close to 2.7 million, right? And total daily deaths hitting around 181,000 that particular year, followed by Russia and USA, then United Kingdom and Argentina. So you can get a comprehensive view across the countries' total daily cases and deaths and their 7-day moving average in general. The cumulative cases should be the same, right? So because we're computing the total daily cases already, okay, so you can see the same number in cumulative cases and deaths as well. So that is a comprehensive view. So if you move on, what I'm trying to do here in this query, I'm trying to find the top 5 countries with the highest average daily cases. So for that, I'm using top 5 keyword, location, countries and territories. We have performed the join to the location already, and then I'm computing average of daily cases, okay, and then top 5 is the key here, okay, and then we are grouping it by countries and territories and then ordering it by average daily cases descending. That gives me the top 5 with the highest average daily cases that we've just seen in the previous T-SQL. The Brazil is the top country with the average daily cases around 7,721 cases on an average, followed by Russia around 7,605 cases approximately, in USA around 6,094 cases, then Argentina around 5,293. That particular timeline, 2020, the average daily cases that we're computing here, followed by UK. So these are some crucial insights that we can derive, and you can see out of the real world data set. You can see the queries are in action to get some insights and a comprehensive view of the COVID-19 data set from 2020 year. Okay, so let's move on. And what we're trying to do here in this query is we're trying to identify days with the highest number of cases and deaths in the respective location. Okay, so what we're trying to do here is we are using the top 10 keyword again, location, countries and territories, date key. These are some of the columns I'm selecting, keys, and then the deaths and cases from the fact table in the join. And then we're ordering it by daily cases, also by the daily deaths descending. Okay, so that gives me the highest number of cases and deaths, the top days. We're trying to identify the days. Okay, so we can, and also by the country, right, the location. So that tells me Turkey being significant on 5th of December, the cases recorded were highest across the world, which is close to 32,736 cases recorded in that particular day, and the deaths reported were around 193, followed by Poland. And you can see India around July 16th, you can see around 32,695, sorry, cases were recorded in one single day around July 2020. Okay, and the deaths were reported were around 606. Okay, so these are real data that we're talking about, some crucial insights across the country, followed by other countries that you can look at. And if you look at the significant deaths, you can see the United States of America around April 4th, there were 32,425 cases recorded on that day, but the deaths were very significant. Around 1,104 deaths were reported on that particular day in USA. Okay, those are some crucial insights. Again, you need to be able to report in your dashboard. Okay, and all this we are doing with T-SQL experience, which is quite handy. And if you're someone pretty much strong with SQL, and I think this is the playground for you. Okay, so let's move on. And in this query, what I'm trying to do is I'm just trying to showcase the common table expression CTE, how we can utilize CTE and then perform some T-SQL queries with that. And we are trying to analyze the rate of change in COVID-19 cases for Turkey, especially because we observe Turkey being very significant on a particular date in December across the world, with most number of cases recorded and around 193 deaths reported. So I've picked Turkey in December 2020, and I'm just trying to utilize CTE to see that how we can look at the rate of change of COVID-19 cases, especially in December. I wanted to see, because there is one day there is a significant peak. I wanted to study further how the rate of change cases looks like, especially in the December month for Turkey. So for that, what I'm trying to do is I'm implementing a common table expression with operator daily change as that's the keyword. That's how you can build the CTE, and then in the parentheses you can define the query, what you want. Okay, so here what I'm trying to do is I'm just selecting the date key daily cases, and then I'm using the lag function, okay, to calculate the previous day cases. Okay, so I'm using the lag function, passing the daily cases. So the lag should be by 1 day. Okay, over we are using the over keyword, and then we are ordering it by date key, and then we are aliasing it as previous day cases. Okay, from the fact table, and perform the required join on the basis of location key, and then I'm filtering it by countries and territories, only Turkey I want to look at, and that will have the CTE, daily change CTE, that we are building. And then what we are trying to do is we are from the CTE what we built, the daily change, I'm trying to pull the date key, daily cases, the previous day cases, and then the rate of change in cases I'm computing with this simple formula, daily cases minus the previous day cases that we computed using lag function. That will be the change in cases. Okay, and I'm keeping some filters, the previous day cases, because we might have some 0 cases days, so I just wanted to filter it out. So I'm filtering out is not null, not equal to 0, and daily cases not equal to 0, and then the date key between a specific month, which is December, as I mentioned, in 2020. Okay, and there we have the result set for Turkey across December, and I think we have data only till 14th, as you can see here. Okay, and you can see the daily cases reported on December 1st and the previous day cases, and what is the rate of change. So meaning the last day of November there were 29,281 cases reported, and December 1st it peaked by 1938, and that's the rate of change from the previous day, and that's how we need to read this data. And as we already looked at, the 5th being the significant across the world, so you can cross check that 5th of December being the significant 32,736, but the previous day there were 32,381, and the rate of change is close to 355 from the previous day. Okay, and that's how you can read this data across 14 days in December for Turkey country. And you can see towards the end of second week, right, so you can see there is a significant drop that you can see, that you can notice. The previous day cases were around 32,106. Okay, and then on 13th of December, but we don't have that data here, but around 32,106, and what we have on the current day 14th is 29,136, which is like a significant reduction in the number of cases from the previous day. So that's how we can interpret the data, I would say. Okay, and I think you can see here between 6th and 7th also there is a significant drop. So the previous day is around you can see here 31,896, that we have it in the previous day for 7th December, and the 7th of December the recorded case numbers are 30,402, which is a significant drop, 1,494 cases drop from the previous day, December 6th. So these are some crucial insights, that you can drill down further and look at the rate of change of COVID-19 cases for any specific country in any specific month using common table expressions like this. Okay, you can store that data set, and then you can put some filters on, and then you can calculate the rate of changes cases, like how we have seen here. Okay, with that, I wanted to quickly move on to the visual query editor experience that we briefly talked about. Let me move on to the SQL Analytics endpoint for our COVID-19 lakehouse. You can see here, and whatever queries that you are writing, it will be auto saved here, as you can see here, and even the visual query that you are building. So you can create a new visual query, and you can start building your visual query if you want. Okay, so let me quickly show you, but we're not going to get into in detail, as I already mentioned during the start of this video, because we are pretty much focusing on querying the data using T-SQL experience. But it's good to know the visual query editor experience. So here you can see I'm just bringing in the dim location and the fact table. I think there are a lot of things that you can do here. I think when you want to transform the data, okay, here you can see I've performed mergers as well. Okay, so if you just expand this a bit, so you can look at each and every step what we have done in this particular series of steps. So here you can do the grouping, whatever you want to do, and then, as I mentioned, the merging can be done when all you have to do is insert this step. Yeah, that's fine. But here you can let me look at the already merged experience. So it opens a dialog for you, and you can see here I've merged the fact table with the location table on the basis of location key, as simple as that. And the join kind I've given as left outer join from the fact table to the dimension table, and you can specify like visually you can select which join you need to perform. Okay, and then you can apply the merge, as simple as that. And that's at a high level. You can perform a lot of other things. You can view the SQL information once we have written the once you have built the visual query experience, and you can manage the columns and a lot of other stuffs. You can do it, and I'm not a big fan of this particular experience, I would say, because T-SQL is pretty much what we need to write the queries, what we need to write, and then query the data using T-SQL experience. And I think this is for someone in your team probably having no knowledge on T-SQL. If they wanted to build with low code experience or no code experience, then they can go for it. Otherwise, I'm not a big fan of this visual query editor experience. Maybe Microsoft is providing this capability if someone is new to the team, and if the entire team, they don't have the required skill sets to write the T-SQL queries to query your data at all. Okay, so just to show you, this capability do exist if you need to build your visual query experience. Okay, that's it. Okay, that's a wrap for this video. Thank you very much for watching, and I hope you enjoyed this video. I'll make sure to share the notebook in the classroom community, so if you want to follow along. And a quick summary, what we have looked at in this video, we talked about how we can query the data using T-SQL experience. If you have a lakehouse, there are a couple of ways you can write T-SQL against your data to query the data using the SQL Analytics endpoint from your lakehouse. Either you can write the queries individually, or you can build a notebook that is more structured. So what we have seen, and then we ran through some of the queries on top of the COVID-19 dataset to show you how you can leverage T-SQL to query your data and then look at some of the insights. And then we looked at the visual query editor experience, which I'm not a big fan of, as I mentioned, but still Microsoft is providing that capability for you to leverage in case if in your team you are lacking skills, T-SQL skills, and then you can go for the low code experience. So I hope you enjoyed the video. Thank you for watching, and I would recommend you to watch my previous videos, and please like, share and subscribe, and share it with your friends if you think this video is beneficial to someone. Thank you for watching.